We are nearing the end of this course or of the main features of Angular. And in this module, we'll have a look at the Angular modules, at this ng module thing, what it exactly is about and how we can work with multiple such modules in an Angular app and why we would want to do that. And we'll have a look at some general optimizations we can add to our Angular app to make it faster, more performant, and prepare it for deployment, which ultimately is, of course, the goal for any application you're building. So let's dive in. What are modules? And with that, I mean the Angular modules. You will also hear the term module when you're talking about the imports you have in your files, when you import something from another file into another file. That also is sometimes referred to as modules, but these would be JavaScript modules. They're totally not related to Angular, and they're not what I mean. I mean that ng module thing that we have in our app, like the app module or the app routing module. So modules in the end are ways of bundling Angular building blocks together. That would be components, directives, services, pipes. You have to group that all together into such Angular modules so that Angular is aware of these features. Because Angular doesn't automatically scan all the files in your project, it doesn't search all the code you write and automatically detect all components and services. Instead, you need to tell Angular what is a component, which components do you have, and you can then bundle them together into modules. Every Angular app needs to have at least one module, that app module. You can't have an Angular app without it. So Angular analyzes these ng modules to understand your application and its features. You use them to define all the core building blocks, components, directives, services, pipes, and so on. An app, as I just mentioned, requires at least one such module, the app module, but you may split it into multiple modules, and we will do that in this course section. You also have core Angular features that are wrapped into modules, things like the forms module, which we added in the course already. So Angular itself also provides certain features grouped together into such modules so that you don't have to declare like 10 different forms directives. Instead, that forms module gives you all these directives. That is how you can think about that. And important also, you can't use a certain feature or building block without including it in a module. How you include it, if you add it to declarations or providers, depends on the feature you are talking about. So let's have a look at our app module and what we're using thus far. This is our project, and there we have the app module. Actually, this is not the only module, and again, with module, I mean things with that ng module decorator. We got one other module in this app, and that would be the app routing module. Here, we also have a ng module. So we already do use two modules, and we use these modules to set certain things up and group certain things together. Now let's start with the app module. There we have a long list of declarations, for example. As I mentioned when we added things to that list, declarations is in the end an array of all the components, directives, and custom pipes you're using in your application. So all these things have to go into declarations, otherwise you can't use them in your templates or in your routes. We also have that imports array. The imports array here is important because that allows you to import other modules into this module. So the imports array here is important to split your app into multiple modules. Thus far, we created only one extra module, the app routing module, but we're using a couple of modules that ship with Angular, like the forms module, the reactive forms module, and so on. Now, if we were to look into such a module, like the forms module, we would find a module with @ngModule as well. And in there, we would have a declarations array with all the form-related directives Angular supports. So things like automatically detecting a form element to create a form with the template-driven approach, or the required or the email directives. So all of that is basically included in the forms module. And so that you don't have to add all these features individually to your declarations array, we can simply import the forms module, which speeds this up. The providers array here then is another important key in our ng module. Here we define all the services we want to provide. However, I'll come back to services and modules because that's kind of special. It's not the case that you can only use a service in the module where you provide it, or at least that's not always the case. But I will come back to that. For now, it's important to know any service you plan on injecting needs to be provided, and typically you do this in the app module, or you do that by adding that provided in root key here into that object you pass to add injectable. This is an alternative to adding that service to your app module providers array. And this is actually the way I would use because it's faster, but you could also add a service here to providers, and it would also be available application-wide. Now, the bootstrap array is important for starting your app. It defines which component is available right in that index.html file. And typically, you only have one component there. You could have multiple components, which is why bootstrap is also an array. You could define multiple components, but each component would then kind of be detached from the other components. You would be creating different root component trees in your application, and that is rarely what you want because it makes working between these components way harder. So therefore, you typically have one root component and you add that to the bootstrap array. Well, and then we have the entry components here. That simply is important for components you create in code, as you learned in the section on dynamic components. This allows Angular to be aware of this component when it needs to create it programmatically. Now, as I mentioned, we do have one other module right now, and that's the app routing module, which we also added to imports. The app routing module is simply there to hold our route configuration. We could absolutely add this into our app module. We only outsourced it because that's quite a lot of code and it keeps our app module a bit leaner. And that is already one reason for why you might want to split your application into multiple modules. It can make your existing modules leaner and more focused and easier to edit and to maintain. Now, the app routing module simply imports the router module Angular offers us and uses a special method offered by that module, which then takes our route configuration to configure the Angular router with our route config, and then something important happens. We export that router module here from the app routing module. We need to do that because every module, and now that is something you have to memorize, every module works on its own in Angular. They don't communicate with each other. If you declare a component in a certain component, in a certain module, like app module, if we declare recipes component here, then we can only use it in here, nowhere else. We can only use it in here. So we can use the selector in our other components we declared here, but if we would have another module with other components, then we could not use selectors of components defined here in components of that other module. And we'll see this in action very soon. And therefore, here we have to export the router module with our route configuration so that it really is not just available in this module, which would not be helpful at all, but that it is available in the app module where we now import app routing module. And when we import another module, we import everything that module exports, which in this case is our configured router module. And this is how the configured router module ends up in the app module and is available there. So that is generally what we're already doing and what we're already using in our application. We're using these modules and everything works. Now, for smaller applications, you can absolutely leave it that way. Nothing wrong with that. This app module also is not too big. It's certainly manageable. But the bigger your application grows, you might want to split your code to have leaner modules that are easier to manage, easier to understand, and also, as you will learn later, to enhance performance. Not automatically by splitting components, but splitting components will be an important prerequisite to then also enhance performance. So we can work with multiple modules. Instead of having one big app module, we could split that into an app module that defines our app component. And then we have, in this slide here, two separate new modules, so-called feature modules. Now, the term feature module does not mean that you create them in a special way. It's still a class with the @ngModule decorator. It just means that this is a module that groups together components, directives, pipes that are used in a certain feature area of your application. Like in this slide, when we're building, let's say, an online shop, we could have components that are primarily involved in rendering products and individual products, and we could outsource those into a products module. And if we then have an area in our application where we're primarily concerned with orders, then we could also outsource that into our orders module. Now, that is an important step of Angular application development. Splitting your app into such feature modules, because that is the prerequisite to performance improvements we'll dive into later, and that also now ensures that when other developers work on your code, or you work on your code, maybe after a short pause, you quickly know where to look for the setup for this specific part of your app. Because of course, you could be building an application with hundreds or thousands of components and directives, and then grouping them together into logical modules makes working with them and refactoring your code simply much easier. Now let's apply that to our course project where we also have multiple features. Which features do we have in our course project there? Well, if we have a look at it in our app folder, I'd say we have three main feature areas. We have the recipes feature area, so all the components related to recipes. We have the shopping list feature area with all the logic related to the shopping list. And we have the auth feature area, where we have all the components and all the logic related to authentication, even if in this case it's only one component, but still, it's a separate feature. The header and the shared components here, I'd say these are not really features of the app. The header is part of the app component. We do render it there, so it definitely belongs to the root of our application. And regarding the shared components, in this app, we might only use certain features in certain parts of the app. Let's say the alert component, we only use it in the auth component. But it would make sense that we share that across different features of our application, because you could be showing an alert in the recipes area as well when you fail to load recipes. So the alert and so on, these shared things we'll take care about later. They're not really a feature module of this app. But let's dive into creating a module for our recipes then. And for this, in the recipes folder, you simply create a new TypeScript file, and you would name this recipes.module.ts. Just as we have the app module for our general application, so basically the core setup for the entire app, we now have the recipes module that should be responsible for defining the building blocks of the recipe feature area. And for that, you simply export a class here and name it recipes module. That is the naming convention here. Just as you named a recipes component, well, recipes component, you now name the recipes module, recipes module. This class now needs a decorator, and you can probably guess which decorator that is. It is the NgModule decorator. NgModule is imported from @AngularCore. Now the NgModule decorator takes an object which you pass in to configure that module, and there you now can add basically whatever you also added to the app module. So since we're talking about the recipes module here, we, for example, will add declarations and add all recipes related components to this recipes module. So if we have a look at the app module, we got the recipes component, the recipe list and detail and recipe item component, and also the recipe start and edit components. All these components, I'll remove them here from the app module and move them into declarations of my recipes module. So let's grab these here as well, like this. That should be it. Let's remove the line breaks here in the app module. And of course, in the app module, we can now also remove the unused import statements here of all these recipe-related components, because we don't need to import the types into this app module file anymore if we're not using them here. And now, therefore, in the recipes module, we need to add the imports. And here, the IDE might be able to help you. If you get something like a light bulb here, you can simply let the IDE import this. Otherwise, simply add these import statements with the correct paths on your own, of course. So I'll quickly add them all with the help of my IDE here. Can also use all missing imports. And now we made a first important step towards our recipes module, but actually not one that will suffice, not at all. How can we now use our recipes module in the app module? Now, as a first step, since I declare all the recipe components here, we could simply add the exports array to the recipes module and export all components, which we declared here, so that we can not just use them in the recipes module, but in any module that imports the recipe module. And that could be the app module. So here, now I cleaned up the declarations to kind of bring them back. They are now declared in the recipes module. We now have to import the recipes module here. So simply add recipes module to the imports of the app module. And of course, make sure you also add that import statement here at the top, which is not to be mistaken with the imports down there, by the way. This imports array in ng module is there for Angular to add features of other ng modules into this ng module. This import statement up here is a TypeScript feature to tell TypeScript where to find this type, that it sits in another file. It has nothing to do with Angular. Now if you save all of that and let the application compile, and I try to go back to the app, I actually get an error. Router outlet is not a known element. And this error is stemming from the recipes module recipes component. And the problem we have here is that in the recipes component, I am indeed using router outlet. The problem is router outlet is a directive provided by Angular, and it's not magically available in the entire application. It is made available by the router module, which I import here. This is not just there to configure our routes, it also adds routing features like the router link directive, which we use to add a link, or the router outlet directive. Now, I export it here in the app routing module, and since I import that in the app module, this router module and its features are available. Now, you might think that then it should also be available in the recipes module, because we kind of add recipes through this routing module here, right? We go to the recipes route through the help of the app routing module. But this is not how it works. Instead, as I mentioned, and this is really just something you have to memorize, everything in a module works standalone. You can export something to then be able to import it into another module, as I'm doing it here with all these components. But that alone does not mean that in this module, in the recipes module here, you can use features that are made available in the app module. You can only export something which then is usable anywhere else. You don't automatically get access to other content. So the recipe module and the components in there got absolutely no access to all the things we import into our app module. So things like the routing module, but all the forms, that all is not available in the recipes module, and therefore we get this error. Now, how can we fix that? Now, to fix that, there are a couple of ways. One way would be that we simply import the router module like this, without for root, but just like that, and also add the import statement up there, into our recipes module. If we do that and we go back to our application, now we still fail because of app recipe item that uses ng4 and doesn't have access to that, but we don't get that routing error anymore. Now, still we get an error. And this error is related to ng4. Here, the same logic as with the routing applies. You don't magically have access to all these core Angular features. You did thus far because we had everything in the app module. We declared all components in the app module, and we have important imports here in the app module that import core Angular features into the app module, and therefore any component declared here has access to these features. Components declared in other modules don't. And for example, ngIf and ng4 are provided by the browser module. All the forms related things are provided by the forms module or the reactive forms module. HTTP related stuff is imported by that HTTP client module, though this is kind of an exception. This only provides services and no directives or components, and services work differently and therefore are indeed available application-wide, even in modules where you don't add this. But as soon as you use something that's not a service, and I'll come back to that services thing later, as soon as you use something that's not a service, but that offers real directives or any features you use in templates, as soon as that's the case, you only have access to what you import. So to be able to use NG4 in the recipes module, besides the router module, we probably also need the browser module. However, this is now just a special case, and the only special case. The browser module must only be used once, and that is in the app module. Because it does more than just add ngIf and ng4, it does some general application startup work that only has to run once. Instead of the browser module, use the common module in all other places, in all other modules where you want to get access to ngIf and ng4. So here you add the common module, and that is imported from @angular/common. Now with that imported, we unlock ngIf and ng4. And therefore now if we save this, we again get an error, but a different error. This time the problem is the form group directive. And as I mentioned, well, you only have access to what you import. We're not importing the forms module, or here actually, the reactive forms module, because we're using reactive forms in the recipes area. And as soon as we do add it though, and of course for that you also need to add the import statement up here from @AngularForms. As soon as we do add this, we can save this. And now we see that it finally loads again and our application runs again. And if I log in, I can indeed go to my recipes, I can fetch my data here, and that all works. Now we outsource this into a separate module. And the core takeaway you absolutely have to understand is whatever you declare here and whatever you use in the templates of these components has to be imported in that module. It's not enough if you import it in the app module. The only exception to that rule are services. These only need to be set up once in the app module, and you can access them in your whole application, even in components which you added to feature modules. But anything that's used in a template, so components, directives, pipes, these things need to be declared or imported into the module where you plan on using them. It's not enough to use them in another module, even if you export your things to that other module. Even then, it's not enough. Angular treats and parses every ng module standalone. Now, the work we did on the recipes module was a good start. But of course, the only thing we're doing thus far is we're outsourcing our recipes component declaration in a separate module so that the app module is a bit leaner. Now, that wouldn't be the worst reason to do it. It's absolutely fine to restructure your app to have leaner modules that are easier to understand and to manage. Yet, we can actually do more than that. We can also move the recipes-related route configuration away from the app routing module. So I'm talking about this branch here essentially, away from the app routing module and into our recipes module. For that, here in the router module, you could add for child now. Now, for root is only used once essentially here in the app routing module, where we use for root to configure our root routes. In a feature module, which you then plan on importing into your app module, you would use for child, and this will automatically merge the child routing configuration with the root routes. So therefore here we can use for child and pass in that same array of route configuration we passed to for root. Now, to keep this file leaner, and this is totally optional, I'll again create a separate module, the recipes-routing module, and therefore I'll export this class, recipes routing module, which will receive the @ng-module decorator. And I only do that to focus on the route setup in this file and not clutter the other recipes module file with that. So here we have our routes, which are of type routes, which is imported from @AngularRouter and which is an array. And in that array, you add all recipes related routes. And in this case, if we have a look at the app routing module, that means I take this single route, this recipes route, with all its nested routes. I take that, cut it from my app routing module, and move it here into the recipes routing module. So now here we have that route file, that route setup. That of course means that all these imports have to be added, and I will add all missing imports here. So all the recipe components and also the auth guard, that's also important. We use that here too, so that this file now has a correct route setup. And now in ng module, we add imports and import the router module from @AngularRouter. And as I just explained, on that module, you now call for child and pass in your routes. And then just as before, you export this router module here. We export it in the recipes routing module so that in the recipes module, we can actually import our recipes routing module. And again, of course, for that, you need to add an import path. So import recipes routing module from the recipes-routing.module file. So now we're adding the routes here in the recipes area. Now, with that adjustment, in the app routing module, we got one route less. We got all the other routes, but not this route. But now in the app module, we do import the recipes module. And since we register our recipes related routes there, they should still be part of our general routing config. The routing config, is now just split across two files. That also means that here in the app routing module, we remove all these unused imports so that they don't pollute this file anymore. Now let's try saving that. And this looks good. Here I'm in the recipes area and I can navigate around. I can go to new recipes. So all these recipe related routes, they still work just as they did before, but now with our split up route config. And again, here the idea can be that we make sure that we have a leaner app module and a leaner app routing module, and we manage all recipes related things in our recipes module and nowhere else. So we split our app into at least 2 modules, or if you count the routing modules into 4 modules. Before we split it even more, and we also learn about different types of modules we could add, let me dive into one important note about components we load via routing. Like here, the recipes component. The recipes component is loaded whenever we visit /recipes. The recipes component is also declared here in the recipes module. Let me remove that declaration and that export here. And let's see if the app still works thereafter. It doesn't. Now we get that the component recipes component is not part of any ng module. So it's really important to understand that you don't just add to declarations what you plan on using in a template, but you also have to add any routes here that you load via routing, so via routing config. It's not enough to just point at it here, you really just also need to have it here in declarations. The other important thing I wanted to highlight is that now that we manage the loading of our components here with recipes routing, we do define which component should be loaded for which route. There is no reason to still export all these recipe components, because we're now only using them internally in the recipes module. We're using them either embedded into other components here, or by loading them through the recipes routing module. Both is part of this file. So there is no reason to export the recipe components anymore, because we're not using these recipe components in the app component or any child component of the app component. And therefore, as you can see, if we reload and rebuild everything, this app still works as before, even if I don't export all the recipe components anymore. So that was our first feature module, the recipes module. Now I want you to practice this a bit. Take the shopping list here and create a feature module for that as well. You learn everything you need for that, so definitely try it on your own. Here's your chance to pause the video. After the pause, we'll do it together. Were you successful? Let's do it together, and for that, in the shopping list folder, I'll create a shopping-list.module.ts file. Now in there, let's export this class shopping list module, and as before, let's add ngModule as a decorator there. Now ngModule needs to be imported from @AngularCore like this. And in ngModule, you now again have to declare what you're using in there, and you have to export what you're using elsewhere. Now let's have a look at our app module. What are we using that is related to the shopping list? Well, obviously, the shopping list and shopping edit components are used in the shopping list area. Therefore, let's grab these two components and remove them from the app module. Let's also remove their imports here. And let's instead move them here into our shopping list module. There, let's add declarations and add these two shopping list components. Now, just as before, make sure you also add the imports. Here, my IDE is unfortunately not helping me, so I'll do it manually. Import to the shopping list component, and also, of course, an import to the shopping edit component here. Like this. With that added, we could export this and import the shopping list module into the app module. Of course, we would also have to make sure we add all things the shopping list components need into the shopping list module. But I don't even want to export my shopping list related things in the shopping list component. I want to manage routing there as well. Now, if we have a look at the app routing module, we got one route related to the shopping list, and that is this shopping list route. Let's remove it from the app routing module and also get rid of that shopping list component import there. And now we could create a shopping list routing module, but since this is already a very small and tiny module, I will do it all in one file, though this is totally up to you, and you could create a separate routing module if you wanted to. There, I will import the routing, or will add the routing module, the router module, excuse me, from @AngularRouter. And there, I'll add for child, pass my routes array to it, and in there set up this single route that is related to the shopping list right now. We don't need to export router module here because we only did this when we had a separate routing module. Since it's now all included in the feature module, we already got it in the place where it should be. The router module is not the only module we need though. We also need the common module that should be imported from @Angular/common. This unlocks ng-for and ng-if when we're using these features here. And we also have to add the forms module because we are using the template-driven forms approach in the shopping list area, so we need to import this as well. And then, well, of course, the router module. Now, this should be a module that works. Let's now go to the app module and add the shopping list module to it. And of course, adding it in the imports array is not enough. You also need to add an import to it up here from /, not shared, but shopping list.module from that file. If you save everything, let's wait for the app to reload. And if I try to visit shopping list and I reload there, this all seems to work. So we now have a new feature module, this time for the shopping list area. We had a look at feature modules. Now let's dive into shared modules. Now what's a shared module? In this hypothetical app here, we got two feature modules. And of course, we would also have an app module, but it's not important for the shared module here. So we got two feature modules, products and sales. And as you can see, these two modules only differ in one component. The products module has the products component here on the left, and the sales module on the bottom right has a sales component. All the other components and directives they use are essentially the same. Now you can put such shared features, shared components, directives, and other modules even into a shared module, which you then import into both other modules. This again is a great step to avoid code duplication and have leaner modules. Now let's see this in practice in our application. In our application, we have no real shared features across our feature modules. If we have a look at the shopping list module and the recipes module, the only thing they have in common is the anti-common module, which unlocks ngIf. Now we could put this into a separate shared module, and we will actually, but this alone would not be worth it because then we just import our shared module, which exports the common module, instead of just importing the common module, so we wouldn't win much by that. But in theory in this application, we have more shared content. We have the alert, the loading spinner, and the placeholder, and the drop-down directive. The data storage service not, because services are special, as you will learn soon. So therefore, here in the shared folder, I'll create a shared.module.typescript file. And you can have multiple shared modules, and therefore they don't have to be named shared.module. If you only have one, it makes sense. Otherwise, you should give them a name that kind of summarizes which features you're grouping in there. Now here I'll name it just shared module and export a class shared module therefore. And just as before, this is a regular Angular module, and it therefore will receive the @ng_module decorator like this. Now the idea here is that you still now declare and import anything into this module that might be used by other modules, but since every module works standalone, to then also make these things available in other modules, you will also export all these things which you're importing. So therefore here, for example, we add a declaration to declare our alert component, to declare our loading spinner component, and make sure you also add the import paths at the top, to declare our placeholder directive and our drop-down directive, let's say. And again, make sure to add all these imports. And this would be it. And let's now also say we also want to share some services, like the common module, not services, excuse me, I mean modules, like the common module, which we import from @AngularCommon. So I add this import here too. And then, since we don't want to use these features in the shared module, but import the shared module into other modules, we can export this here. And we export the alert component, the loading spinner component, the placeholder directive, the drop-down directive, and also the common module. And now the idea is that wherever we import the shared module, we have access to all these features which we initialize here. So in other modules, where we want to use one or all of these features, we don't have to add them to their modules. We just import the shared module and we got access because we're exporting all these stuff. If we wouldn't export it, we would not have access. So let's now use the shared module. Let's go to our shopping list module, and there we can at least now replace the common module, although that alone would not be worth it, but to demonstrate it. And we replaced it with the shared module. Now, as I mentioned, and that's really important, it's not worth it here because the only thing we really need from the shared module in the shopping list module is the common module. And therefore, we replaced one module import with another. But if we would use the alert component here, or the placeholder directive, or the drop-down directive, then we would gain much more from that, because now we don't have to add all of that to declarations here. We just bring in the shared module, and we got access to all the things declared in the shared module and exported there. So in the recipes component, and recipes module, excuse me, we can do the same. We got the common module. Now we can remove that here, and instead simply bring in that shared module. Again, here not super useful, but to practice this. Of course, we can now remove the common module import here and just import the shared module. Now with that, if we try to save, that will face an issue though. As the app reloads, we get an error that the drop-down directive is part of the declaration of two modules. And that is now another super important concept you gotta understand about modules. You can only define or declare components, directives, and pipes once. You can't do that multiple times. You can import a module into multiple imports. So it is fine if we import the router module here in the recipes module and also in the shopping list module. Imports are okay. But declarations are not. If you declare the shopping list component here in the shopping list module, you must not declare it anywhere else. Even if you need it in another module, you must not declare it there. The solution then instead is to export it here and import that module into another module. And that's exactly what we're doing with the shared module. Here we are declaring and exporting stuff. So anywhere where we use one of these features, we now have to bring in the shared module, because double declarations, as we currently have them here in the app module, where I again declare the drop-down directive and so on, are not allowed. So instead here, we now have to remove the drop-down directive, the loading spinner component, and the placeholder directive and the alert component. We have to remove all of that here. And therefore, we also should remove these import statements here at the top, like this. All of that has to go. Also remove the alert component here. And now cut entry components and add this to the shared module. Now the app module is cleaned up. And now we just have to make sure that we import the shared module here, because we still need access to certain features. We need access to the drop-down directive because we are using it in the header component, which is part of the app module. So now we need to import the shared module here into the app module, because that now declares features like the drop-down directive. And with that, if we save that, now this is looking better. Now if we reload and so on, this seems to work. Now if I test my alert component again, this also works again, because this is also declared in the shared module. There we also have our entry component, which is still required. And since I export the alert component in the shared module, and I'm importing the shared module into the app module, which at the moment is the place where we define our auth component, which in turn is the component that uses the alert component, that all works. But only because we respect the rule of only declaring things once and then using export and imports to share them. Multiple declarations of the same thing are not allowed. Now that we had a look at feature modules and shared modules, let's have a look at the third important module type you can work with, and that would be the core module. And of course, let me highlight that all these modules are created in the same way with NgModule. Just the things we put in there and how we use them differs, and that is what I mean with different module types. So what's the core module? The core module is basically there to make the app module a bit leaner. Let's say in the app module we have the app component, and here we are providing two services. Well, then we can use a core module to move these services out of the app module into the core module, which then in turn is added back to the app module. The alternative to that would of course be to use provided in add injectable on the services, which means we don't have to add them to providers at all. But if you do add it to providers in the app module, well, then using a core module can be an idea to again keep your app module leaner. It's a pattern you see sometimes, not a pattern you absolutely have to follow, and indeed a pattern that you don't need to use or can't use if you are using provided in add injectable, which I would recommend using anyways. But if you do provide your services in providers of your app module, well, then this is a pattern you might want to use. Let's have a look at it. In our app module, if we have a look at the providers, I have the shopping list service and the recipe service there and my intersetter. Now, the idea behind the core module is that we simply provide all these application-wide services that are important right from the start of the application, that we provide them in a separate module, which we then simply import into the app module, really just to keep this leaner and to have a way or a place where we can quickly see all the core services of this application. Now, as I mentioned, this does only make sense, or is only a pattern you may use if you are providing a service like this by adding its type to the provider's array. If you are providing a service like we're doing it for the data storage service, where we pass this object to add injectable, where we set provided in root, then this service is also provided application-wide, and you can't and shouldn't add it to providers of the app module. And this is indeed the approach I would recommend taking. I would not provide services in the app module. I would instead provide them application-wide like this. The effect is the same, but it keeps the app module cleaner and leaner automatically. Still, for some things like the intersetters, you have no alternative. You have to add them to providers. And here, for demo purposes, I also added shopping list service and recipe service. Then we can add a core.module.ts file where we export the core module. And that, again, is just a regular module with ngModule like this. And ngModule, as before, now needs to be imported. So ngModule from @AngularCore. Now here in ngModule, you add providers, this providers array, and there you simply add the providers you had in your app module, like this. Now, of course, for this to work, you need to make sure you're importing all the things that you use in here. So I can grab these imports from the app module. We're in the end talking about the shopping list service, the recipe service, and the auth intersetter service. I'll cut them from the app module and move them here into the core module. Import path is the same because the core module file is right next to the app module file. And I also need the HTTP intersetters. I can cut them from here and instead use that here, add it here to the core module. Import HTTP intersetters from @Angular, Angular/common/HTTP. So now the core module here is prepared. You don't need to export your services because services work differently than declarations. Only declarations and other modules need to be exported. Services are automatically injected on a root level. You don't need to export them to make this happen. So services are simply an exception. And therefore now in the app module, the only thing we have to do is we have to import our core module, even though it's not exporting anything, but to still include it here into our build process. And we import it from our core.module file. With that set up, the application restarts, and you should still have the same functionality as before. I can fetch my recipes here. Let's try deleting a recipe, which will use the recipe service behind the scenes. Let's test something here for my shopping list. This all still works, so all these services still work, but now we have them in the core module, which is our go-to place to quickly see our root application services. And we have a leaner app module without a providers array. But as I mentioned, A, this is optional, and B, this is only required if you provide a service here instead of providing it through @injectable, which would be my recommendation to use whenever possible. So we already reorganized our code quite a bit. What's remaining here in the app module is the auth component. And we also got a couple of imports here, which we might not need in the app component anymore, because our app component already got pretty lean. Now, the forms module is still required because the auth component needs it, but we can definitely drop the reactive forms module. We need the HTTP client module because it turns out that this is a module that only sets up some global services, the injectable HTTP service, and we need that, so we will keep that. We need the app routing module. We need the recipes and the shopping list module and all these modules. But the reactive forms module could be dropped, and I also want to drop the forms module and get rid of the auth component here, because we can simply create a new feature module for that. I analyzed at the start of this module that this is our third feature area, and therefore creating a separate module would make sense. Again, definitely feel free to pause the video and try this on your own here. Outsource the auth component and its route into a separate feature module. Were you successful? To do it together, here in the auth folder, I'll add an auth module TypeScript file, and as before, export a class auth module, which receives our normal @ngModule decorator. Now, here we, as you learned, need to declare whatever we're using in this module. And then the auth module, that is the auth component. So let's cut the auth component from the app module and move it here into declarations of auth module. Now for that, of course, we also need to add the missing import. Now the auth component is using certain Angular features which we should import. We need the common module in case we're using ngIf or ngFor, and you need to add the import to that as well. We also need the forms module because we're using the template-driven forms approach here in the auth component. That allows us now in the app module to get rid of that forms module. Now we can also import, maybe here, our auth module and make sure to add that import path, of course. But I also wanted to outsource my routes. So in the app routing module, let's grab that auth route here, remove it from the app routing module, and go to the auth module. And in here, simply add router module, which you import from @AngularRouter. And as you learned it, for child, and add this route. And if you put this into a separate routing file, into a separate routing module, and import that separate routing module into the auth module, that would have been correct as well. So now I have my auth module that focuses on all the auth related stuff. The auth service still is provided like this, and if you would provide it in a module, you would still keep it in the app module to have it available application-wide. But other than that, this is looking good. Let's now save it all and see if that works. And I'm getting an error. The app loading spinner is missing in the auth component or in the auth module. Now, do you know what the issue is here? Well, the app loading spinner, the loading spinner component, is defined in our shared module. And as I mentioned, you only have access to what you declare in a module. So if we need the loading spinner component in the auth module, we could add it to declarations, but double declarations are not allowed. So declaring it here and in the shared module is not allowed. Therefore, the solution is to simply import the shared module to get access to its features. And now with that, everything seems to work. If I now log out and I test the login flow again, first of all with invalid credentials, that works. And now with valid credentials, that also works. So now we also outsourced the auth related things into their separate feature module. Now that we covered the important module types you can find in an Angular app, with the feature module being the most important one, let's dive into our first optimization concept. Because thus far, this entire code splitting of separating our modules into separate modules was only cosmetical. It makes our code in the individual modules leaner, and it can help us with maintaining that code, but it doesn't influence the performance of our application at all. This will change now because now we'll have a look at a concept called lazy loading. And using multiple modules, to be precise, using multiple feature modules, is a prerequisite for that. Now, what is lazy loading? Consider this application. We have 3 routes, our root route, /nothing, /products, and /admin. And of course, we have a user visiting this page. Now, every route is associated with a module, our app module, and then our different feature modules, where each module, of course, might have multiple components, multiple directives, pipes, and so on that belong to it. Now, when our user visits the root route, we, of course, load that first module, and we do the same when we visit the different other pages. Or do we? Well, actually, at the moment, when we're not using lazy loading, whenever we visit any page, we load everything. But wouldn't it make more sense to only load products and admin when we actually visit these pages, so that we only load the code that belongs to these areas of our application, that we only load the code that belongs to these areas when we really need it? That's the idea of lazy loading. With lazy loading, we initially only load our root route content, so only the app module code and the code of all the components that are registered there, and we don't load the other modules. And only when we visit another module, like the admin module, so the admin route here, we load the admin module code and the code of all the components that belongs to that module. And the effect or the advantage of this is that initially we download a smaller code bundle and we download more code when we need it, but initially our app is able to start faster because it has to download and parse less code on the first visit of a certain route. And that's the advantage. So let's now see how we do implement lazy loading in our app, and let's see its effect. For this is the app without lazy loading, so the app as we currently have it. And if you go to the Network tab and you reload the app here on this off page, unauthenticated, you see we download a bunch of files here. We have our, let me shrink this. We have our polyfills files, styles.js, vendor.js, main.js. These are 4 JavaScript files. And we're in development mode here, which is why they are extremely big. They will be smaller once we build the app for production, because this code is not optimized at all. It contains many debug features, so it will be way smaller later, and we'll see that later. But at the moment, you see we have pretty big files here. 4 megabytes, 100 kilobytes, almost a megabyte, 236 kilobytes. Now again, this will shrink significantly, but still, this is our current file size. With lazy loading, we should be able to decrease that. How do we add lazy loading though? Let's start with the recipes module. Because, for example here, when we're not authenticated, we certainly don't need to load the recipes module code because we can't even access anything from the recipes module here. It might also not make sense to load the shopping list module, even though we can access it, because unless we do, there is no need to download that code. So let's start with the recipes module nonetheless. There we have the recipes module, and we have its own routes here in the recipes routing module. Now, having the routes registered here is an important starting point. For lazy loading to work, your feature module needs to bring its own routes, as we're doing it here. It needs to bring its own route config. We're doing that here, and it needs to bring that with for child, which is also what we're doing here. Now, one thing we'll need to change though, that path, recipes here, I will change it to an empty path because now we need to add something to our app routing module for lazy loading to work. Here, I'll again add another route, and that will be the route for recipes, so the path I just removed from the recipes module. Now here, I'm in the app routing module, important. I add that path again here, but now I don't add a component which I want to load, but instead you add load children. That's a special property in a route config, which Angular understands as please only load the code content or the module I'm going to point you at when the user visits this path here. Now let me show you what this means. We can now add a string here, not a type, not a component type you pointed, but a string, which is a path to the module you want to load when this page here or when this path here is visited. And I, of course, want to load relatively from the app routing module my recipes folder, and there the recipes module, not the recipes routing module, but the recipes module. And now you also need to add something here. It's not just a path, but you also need to add the name of that module, because Angular can't know that, and it needs to know the class name, because technically it will go to that path and then try to dynamically import a specific object from that file, and theoretically that could be named anything. We are, of course, following that naming convention of naming this recipes module in this casing here, when the file name is named recipes.module. But no one is forcing us to follow that naming pattern. And therefore, we explicitly have to tell Angular what the name of the exported class in that file is. And you add that by adding a hashtag and then that name. So load children points at /recipes/recipes.module.ts and then hashtag and the name of that class. The effect of that will be that now the code is split at that point, and everything at this path here, so this entire module and everything that module uses, so all the declarations of that module, will be put into a separate code bundle, which is then downloaded and parsed on demand as soon as a user visits this page, but not sooner. And that is simply achieved by the Angular CLI essentially analyzing this when we build our app, and it will then analyze the recipes module at which we point here, and it will look at what we declare in here and so on, and will put the code of all these things we declare here into that separate bundle, which is now built separately, detached from our main bundle with which the app starts. Important for this to have a real effect and save code is that you have these import statements only in the recipes module, and you don't have any old import statements to, let's say, the recipes component in, let's say, the app module. Because ultimately, for the build process, it's important what you import here at the top. What you import here, like that forms module, which I should remove in the app module, what you import here is all bundled together into one code bundle. So in the recipes module, in the end, the build process will look at these imports, which are required for this to work, but it will look at these imports, and whatever is included here will be included in the same bundle. So if you have another, even unused import, add something like this lying around in your app module, then this part would be included into the app module code bundle, even though you're not using it there. So to have the biggest effect and save the most code, make sure your imports here at the top are correct. If they are, then you'll get the biggest possible effect from that code splitting. Now, in the recipes routing module, it's important that you have an empty path, because you have to keep in mind that we now changed the route config to include the path here in the app routing module, and it will load the recipes module whenever we visit /recipes, and therefore in the recipes module, we now already are at /recipes, and hence here in the recipes routing module, which is only kicking in once we do visit this module, we should start with /nothing, because again, we already are at /recipes. Now save all that and quit your build process and restart ngserve, because after adding lazy loading, you will need to restart that to ensure that it really has an effect and is taken into account. Now here I'm getting an error, and the issue is that here we should remove the .ts. Now, one note about this syntax: in newer versions of Angular, you have an alternative syntax, and this syntax might even fail in newer projects. So if you are getting an error like module cannot be found when trying this out, which we'll do in a second, or if you want to switch to that more modern different syntax for any other reason, here is that other syntax you could use. Instead of having this string here to identify the module which should be loaded, you can add a function here, an anonymous arrow function, and in the function body you call import, like a function. So you don't use import as we do it up there to import modules, but you call it dynamically as a function. To import, you then pass the path to the module, so /recipes module. And now you don't add a hashtag thereafter to identify the module, but instead import resolves a promise. So now you call then there, and in this promise or in this then block, you pass in a function which receives in the end the module which was loaded here, hence I named the argument m, and on this module object you can extract your modules, the recipes module in this case. So this here is in the end an alternative syntax you could use for loading routes lazily. Instead of using the string you see in the videos thereafter, you can use this function. Now generally it doesn't matter which of the two approaches you use, but this is the more modern one, and if you are getting errors with the approach I'm showing in the lectures, which is the string-based one, switch to this one instead. Let's restart ngserve thereafter. And this looks good. However, now when this reloads, you should get an error like this. And do you have an idea what might be causing that? Well, in the app module, I'm still importing the recipes module. Now, the recipes module is the module we're now trying to load lazily. So we should only have this part here, this route where we use load children. We must not import recipes module anymore. Otherwise, we're importing it both eagerly and lazily at the same time, and that will cause an error. Of course, also remove that import statement. Otherwise, it will technically work, but you won't save anything in code size. Now with that saved, you should be able to save this again and recompile. And now this looks good, no error. And now let's go to the network tab here and reload this page. Now, the vendor.js file is still pretty big because that's just Angular, but main.js actually shrank. Previously that was, I think, 117 kilobyte, so definitely above 100. Now it's 75, so this shrank. And we can see where it went if we clean that here and we do log in with valid credentials. And now we are redirected to recipes, and indeed here you now see that you have this recipes module.js file here. The naming might differ, but that has the 41 kilobytes by which our bundle effectively shrank roundabout. And that is that lazy loaded code snippet, that lazy loaded module. And we can interact with that just as we could before. So that is all working, but now we're lazy loading. And this shrinks our initial bundle size. Now, of course, the big bundle, the 4.1 megabyte bundle, did not shrink, but again, this will be optimized later. And the bigger your app grows, the bigger the features are you're lazy loading, the bigger the effect will be, of course. If you have a large app with an entire area in that app that the user might never visit, if you lazy load that, it might have a huge impact because you can save so much in that initial bundle. Now, of course, it makes most sense to lazy load parts of the app where there is at least a slight chance of the user never using it. For example, in this application, you could argue that lazy loading the off page doesn't make too much sense because the user will always see that. Though I guess that's also only correct if you assume that the user is already logged in. If the user is not logged in, we can visit the recipes page and therefore will never see the off page. And therefore even lazy loading the off page might make sense. But if you have some page which will always be visited or with a very high chance, then lazy loading that page or that module might not be worth it because you have to consider that lazy loading of course comes with the downside of that extra code bundle being downloaded later. And therefore, once it's needed, there might be a slight delay in your app since that code needs to be downloaded and parsed. So you're basically just postponing that. Though I'll also show an optimization technique with that in a second. Before we dive into optimizing lazy loading, let's add more lazy loading though. Let's make sure we also lazy load the shopping list and the off module. Of course, feel free to pause the video at this point and do it on your own. Thereafter, we'll do that together. Were you successful? In the end, we just replicate what we did for recipes. We add a new path, shopping list, and there we add load children and we point at the shopping list folder and there at the shopping list module without .ts and thereafter with shopping list module or whatever you named the class in that file. Now, important, if we have a look at that shopping list module here, whoops, this one. Again, make sure you're using the right name here in your route config. And of course, make sure that here you have a route setup where now you remove the path name and you have an empty path because the path name now went into this global route config where we set up lazy loading. Now let's replicate the same for off. Therefore, here the path should be off. And then we again use load children. We point at /off, then at the off module without .ts, and then here at off module. And again, in the off module file, make sure the path is now just an empty path. With all of that in place, again, restart ngserve to be certain that these changes are picked up. Sometimes they can get lost if you don't restart the build process. And therefore now, with that all reset, go back into the app module. And just as before, make sure you remove the off module and the shopping list module here so that you're not eagerly loading that. also remove the imports, save again to trigger a rebuild. And now let's wait for that to reload here in the application. This looks good. Now you see that here the off module was loaded for me, which has only 10 kilobytes. The main module shrank to 54 kilobytes, which is great. Even the vendor module shrank a bit because some parts we previously imported there are now only imported by modules. So some parts of the Angular framework, like the forms module, are now only imported when that component that uses it is imported. And therefore now, when we do log in here, we go to recipes. Now the recipes module is coming in. If you click on shopping list, now the shopping list module is imported here. You see these imports popping up on the right. And that is lazy loading in action. And even though the effect is not that large in this app, we can see it. And of course, it becomes bigger and bigger the bigger your application is. I mentioned a way of optimizing lazy loading, which itself, of course, is already an optimization. And with that, I mean how the lazy loaded code is then loaded. Right now, we load code whenever we need it. So as soon as we visit /recipes, for example, after logging in, we bring in the recipes module. Now, the downside of that, of course, is that this is downloaded and parsed just when we need it, leading to a very tiny delay in our application. We might not see that here because the module is small and the internet connection is fast. But the bigger the module and the slower the internet connection, or for example, if you temporarily have no internet connection, the longer that delay will be. And therefore, we can actually tell Angular to preload lazy loaded modules to avoid this delay. For this, we simply go to our root router module, so here where we configure our root routes, and you can pass a second argument to that. This is an object where you can configure that root router. And there you can set up a preloading strategy. And you can set this equal to preload all modules. The default is no preloading, you don't need to set this. But you can set this to preload all modules, which is simply and in the end a constant you need to import from @AngularRouter. Speaking of imports, you should remove the off component import, by the way, to optimize lazy loading as well. But with preload all modules imported and set here as a preloading strategy, you're telling Angular, well, generally, we're using lazy loading. So it will not put all that code into one bundle. It will split it as we saw it. But it will preload the bundles as soon as possible. So when we are on the off page, it will already preload recipes and shopping list so that these code bundles are already available when we need them. The advantage is that the initial download bundle still is kept small because there that code is not included, and therefore the initial loading phase is fast. But then when the user is browsing the page and therefore we have some idle time anyways, then we preload these additional code bundles to make sure that subsequent navigation requests are faster. So we're getting the best of both worlds, a fast initial load and thereafter fast subsequent loads. So with that preloading strategy set up, now if we reload this page here, you actually see something interesting. We of course see that, the main.js file and so on is loaded, but then we also see that here the recipes module is loaded and the shopping list module is loaded. And therefore now if I clear this all here, the network request output, you see no downloads of these modules here because they already were preloaded. Still, we had that smaller initial bundle, but we benefit from these code packages being there when we need them. And therefore, setting this preloading strategy is definitely worth a thought if you want to optimize lazy loading and you want to ensure that this goes as fast as possible. Now, you can even build your own preloading strategies here, where you could have more refined logic, for example, controlling that only certain routes should be preloaded, but that is beyond the scope of that course. Being aware of that preloading strategy is super important though, and that is how you could use it. Now that we learned about lazy loading, I can finally dive into what's special about services and modules. Because I mentioned that there is something special about that, But I could only explain it after diving into lazy loading because it's strongly related to that. I want to dive into where you can provide services and how that affects the instances of the services you're working with. Now, we can provide services in the app module. We can provide services in the app component or other components, if you remember the services section. There, you also could add a provider's key to the component decorator. We can also load services or add services to providers of any eager loaded module. So in the recipes module before we added lazy loading, for example. And we're also, of course, able to add services to providers of lazy loaded modules. Of course, we can also provide services by adding the provided in root configuration in the add injectable decorator. And that would be recommended for all services that you planned on providing an app module otherwise. Now, when you provide a service in the app module or with provided in root in add injectable, the service is available application-wide. And with the service, I also mean the same instance of that service is available application-wide. You're always working with the same singleton instance. If you provide a service in a component, no matter if that's the app component or another component, then that service is only available for dependency injection inside of that component tree. And then all these components will again share the same instance, but we're talking only about that component tree. And if you provide the service in multiple sibling components of your application, then all these sibling component trees have access to the service, but each component tree has access to its own service instance. And I mentioned this and showed this in the services module of this course already. Now, the interesting thing is, if you do add a service to providers of an eager loaded module, you might think that that service is only available inside of that module, and that every module where you add a service to its providers has its own instance of that service. But actually, that's not the case. If a module is eager loaded, everything is bundled together initially, and therefore any services you add to providers in an eager loaded module, let's say the recipes module would be not lazy loaded but still eagerly loaded by importing it into the app module, any service added there will be available application-wide with one and the same instance. So adding a service to providers of an eagerly loaded module has the exact same effect as adding a service to providers of the app module or as adding provided in root in add injectable has. A huge difference can be seen if you add a service to providers of a lazy loaded module though. There, the service is only available in that loaded module and it gets its own instance. If you do provide a service both in the app module and in a lazy loaded module, then the service is of course available application-wide, but the lazy loaded module will get a separate instance, not the same instance you use in the rest of the app. Sometimes this can be desirable, but in other cases it might lead to a strange behavior where you would have expected to work with one and the same instance when you didn't. The reason for that is that when you do provide in the app module or in add injectable, you use the so-called root injector, so the root dependency injection mechanism of Angular. When you do provide it in a component, you use the component-specific injector, which is not the root injector, and therefore not the entire application has access to that. In an eagerly loaded module, again, the root injector is used automatically. With a lazy loaded module, a separate child injector is created by Angular for that module, and therefore that module has its own instance of that service. Therefore, the default should be that you use the app module or, again, provided in root in add injectable. You, of course, might have scenarios where a component tree needs its own service. For example, if that component tree somehow has a service that only matters for these components and doesn't matter application-wide, then there is no need to provide the service application-wide. You can instead provide it in that component. Eagerly loaded modules should pretty much never provide services. You should avoid this because the effect is the same as in the app module, but it's kind of unexpected and it's harder to detect services there, and therefore other developers diving into your code might look for a certain service, might look for it in the app module, not find it there, and therefore be confused whether this service is now intended to be available to the entire app or only to that module. Now in a lazy loaded module, you can of course add a service to providers, but only do this if you deliberately want to have a separate instance of that service there. Otherwise, you can have strange bugs. So as a rule, generally you want to ensure that services are always available application-wide by using @injectable provided in root or by adding them to providers in the app module, unless you have a strong reason for adding them only in a component tree or in a lazy loaded module. Never add services in an eager loaded module. Now let's see that in practice. Back in the application, let's actually create a new dummy service to highlight what's going on. I'll name this logging.service.ts file, that's the file name, and I added next to the app module, though that doesn't really matter. There, let me export the logging service, and first of all, let's provide it by adding @injectable with that object passed to it, where we set provided into root. Now, as you learned, this will provide the same instance of the service to the entire application. Here, I'll add a last log property, which is a string, and initially it's undefined. And then I'll add a print log method here, where I get a message, which is a string. And first of all, I simply console log that message. But I also set this last log equal to the message, and prior to setting this equal, I do log the last log, so the old last log therefore. So we outlook the message and what was previously in the log, and then we overwrite what's previously in the log with the new message. Of course, this is really just a demo, not important to this application, but important for understanding the different service instance things. Now let's call this an app component in NgOnInit. There, let's simply inject the logging service, which is of type logging service. Make sure to add the import path here. And in NgOnInit, we can now call this logging service print log hello from app component NgOnInit. Now let's also add it in our shopping list component. There, in the shopping list component, we also have NgOnInit, so let's inject the logging service here as well. Again, make sure to add the right import path. And then NgOnInit, here let's simply set this logging service called print log, and there I print hello from shopping list component NgOnInit. Okay, so I got two places where I used that service. Now let's switch to the console in the DevTools and actually log out and reload the app. Okay, so now we see hello from app component NgOnInit, and then we see undefined. Undefined is simply stemming from that last log, which I'm printing here. Now let's navigate to shopping list. You see hello from shopping list NgOnInit, and you see hello from app component NgOnInit, because this is now our last log, which was stored, right? We do store it here. So we're printing this the second time print log is called. This kind of proves that we're using one and the same instance in the entire application, because we're using the service in two different components, and yet we're using the same object. Otherwise, last log would be undefined here as well. It isn't, and therefore we have proof that it's the same object as before. Let's change this by not using @injectable with provided in root here, but let's instead provide that service in the app module. There we can add providers, and we provide the logging service. Let me switch back to authenticate and reload. Same output as before. Let's go to shopping list, same output as before. Because providing in the app module has the same effect as using @injectable. Let's get rid of that as well. Let's now use an eagerly loaded module, the core module. That is eagerly loaded because we imported here into the app module. There, well, I already do provide services here, so I kind of think that proves the point. But let's now add the logging service here, add the import as well, save that, go to authenticate and reload, same output as before, go to shopping list, same output as before. Now let's change that. Let's remove logging service from the core module. And let's instead provided here in the app module as before, but let's now also provide it in the shopping list module. There I'll add providers and I'll provide the logging service as well. So now I'm providing it in a lazy loaded module, the shopping list module, and in an eagerly loaded module, my app module. Let's go to authenticate and reload. Same output as before. Let's go to shopping list. Oh, now the output is different because we're now using two different objects, two different instances of that same service. We're using a separate instance in our application in general for the service provided in app module. But since the shopping list module brings its own instance by providing the logging service again here, the shopping list module and all the components in there use a separate instance of that logging service. They don't use the application-wide available instance, they use their own instance created by that child injector. Now, if you need that behavior, definitely use it. Nothing wrong with that. This is not a bug, this is an intended feature. But in general, you should think twice before you provide a service in any other module than the app module, because often it's not the wanted behavior, and you then suddenly have strange bugs when you're using different instances in your application. So if you need that behavior, use it, but generally be aware that there are differences in the instances you get when you provide services in lazy loaded modules. This also includes modules that you import into lazy loaded modules. For example, if I comment this out in the shopping list module, and I comment this out in the app module, let's provide the service in the shared module. The shared module here in the shared folder, the shared module, of course, is also able to add providers. And let's provide the logging service here now. Now the shared module is imported by the app module, and therefore it is an eagerly loaded module, but it's also imported into the shopping list module. Now the shared module to the shopping list module is also eagerly loaded, but the shopping list module itself is lazy loaded, turning this here in this place, the shared module in this place, also into a lazy loaded module. So here the shared module is both. It's lazy loaded in the shopping list or through the shopping list module, and it's eagerly loaded into the app module. And the effect is that if we reload here, that works, and we see the output here on the app component, but we have the same issue, in quotation mark as before, because the shopping list module still uses its own instance because it imports the shared module into it. And that is the most problematic bug you often end up with when providing services in other modules. You might be providing a service in something like a shared module where you think, yeah, I'm going to put all my shared services into this. But you might still have shared services that should use the same instance across your entire application. Well, as soon as you're importing your shared module into a lazy loaded module, the services provided in the shared module will be recreated for the lazy loaded module. And all of a sudden, you might have a behavior you don't want. So whilst providing a service directly in the lazy loaded module might be something you control deliberately, providing it in a shared module is a common gotcha where you think you use the same service instance in the entire app when you don't. I know this can be difficult to wrap your head around, but this is a crucial thing and a common source of bugs. And therefore, the rule of thumb is that you provide services through @injectable or in the app module. If you do it differently, you should have a strong reason, and you should either be able to rule out that this module you're adding the service in is loaded lazily, or you deliberately want multiple instances. We're nearing the end of this module, and I want to conclude it by diving into one other optimization technique we can and should perform before we ship our app to production, so before we deploy our built Angular app onto a server. And that is ahead of time versus just-in-time compilation. Now, what's that? Well, in our Angular application, we're of course writing some code, our Angular code and our template code. And our templates, of course, include special Angular syntax, like ngIf, ngFor, and so on. Only Angular understands this. The templates we're creating, that's not a one-to-one snapshot that's going to get rendered into the real DOM. Instead, Angular will parse our templates and then update the real DOM based on the instructions we placed in our templates. So all our components and our directives are in the end translated to commands that will be used to alter the real DOM. JavaScript in the browser doesn't understand our templates. Angular does. So we write our templates for Angular because Angular understands all these features. So whilst we use the TypeScript compiler to compile the TypeScript code to JavaScript code, which of course is understood by the browser, we also have another compiler in that build process working behind the scenes as part of NgServe, which is the Angular compiler. That is included in the Angular framework. It's a crucial part of the Angular framework, and it's actually quite big. The Angular compiler itself is written in JavaScript, it's relatively large, and it's part of the Angular application you are seeing in the browser with NgServe. So that Angular compiler takes the compiled JavaScript code and your templates and actually translates all the logic there into concrete instructions that update the real DOM. This by default happens all in your browser because the Angular compiler is part of the Angular code you're shipping. This process is called just-in-time compilation because the Angular templates are compiled just in time when the rendering occurs in your browser. So the Angular compiler runs in the browser at runtime. The obvious downside of this is that this compilation process takes time. It's super fast, but still it's a small performance hit. And the Angular compiler, so the entire code that is just responsible for compiling your templates, is not that small. It's actually quite large, and it's part of your Angular application, even though it has no purpose, it has nothing to do with your business logic other than bringing it onto the screen, which arguably is important, but still a bit annoying that it has to be part of your application. The good thing is, it doesn't have to be part of your application. Since the Angular compiler is responsible for converting your template code and your template instructions into JavaScript commands the browser understands, we can do that during development as part of the build process. And that process is called ahead-of-time compilation because we compile the Angular templates ahead of the execution time. Then the Angular template compiler runs during the build process before the app is deployed and not in the browser. Now, the NgServe process, as of now, by default uses the just-in-time compiler because that's better for debugging and fast updating of the running application. And there's nothing wrong with that. During development, we have no problem with shipping a too big application where the compiler is part of the code. Because we're not optimizing the code size during development, we want to have a good development experience with rich error messages and so on. But as soon as we're preparing ourselves for production and for building our Angular app for production to then upload it on a server, we want to optimize our code as much as possible and shrink it to as small of a bundle as possible. And we do that with a command you'll also see in the deployment section. I quit NgServe here. We do that with ngBuild, but there you actually add --prod for production. This command takes your Angular application and now does not spin up a development server where you can see it, but it actually builds your entire app into a few files which you can then deploy. Now I'll show the deployment process in a separate module, but let's already execute this command because this automatically does an important optimization for you. It uses ahead-of-time compilation. You don't need to configure anything special. That's the great thing. It works out of the box, but it does it for you. And here we now get an error. Property control does not exist on type abstract control in the recipe added component. This error didn't occur earlier because the just-in-time compiler is a bit more forgiving than the ahead-of-time compiler. The ahead-of-time compiler does some extra checks, and here it found code it didn't understand. So let's have a look at the recipe component HTML file. There the problem is this part. This part works with the just-in-time compiler, but the ahead-of-time compiler basically does not understand that this part here, recipe form get ingredients, gives us back a form array that has a controls property. It doesn't know what we get back here. It knows we get back an abstract control. Form array is an abstract control, but basically an extended version with this extra controls property. Other controls don't have a controls property. And that is the problem the ahead-of-time compiler has. The solution is to remove that code from the template and move it into the TypeScript code. There we can add a new getter property, let's say here, with the get keyword, and then we name this ingredients controls. A getter property is like a function which you can use like a property in a template. You can't set a value to it though, you can only read it. That's achieved by using the get keyword here in front of the property name. The signature then looks like the function signature with the parentheses and the curly braces. And in there, we return this recipe form get ingredients. And now to inform TypeScript about the type of this and that we know that it will be a form array, we wrap this part here into an extra pair of parentheses and add as form array here. Form array needs to be imported from @AngularForms. This is a TypeScript instruction that tells TypeScript all is good. This term here, or this expression here, will resolve to a form array. And therefore, it does not complain about us using controls here. Now we're returning this, and therefore the only thing we did is we made this more type secure. Might seem redundant, but it is important for the ahead of time compiler to not fail anymore. Now we can use ingredient controls, this getter property here, in the place where we previously had that code snippet. And now if we save that and we rerun ng-build prod, now this will actually work. Let's wait for this to finish. And here it is. Now, before we have a look at what this generated, let's also rerun ngserve here to see whether that also works and to again have a look at the development file sizes, which were quite big if you remember. So let's wait for this to build. Here it is. Let's log in real quick here, go to the recipes module, fetch the recipes, and then maybe also edit one to see that the edit page really still works. That looks good. Let's create a new recipe where we add an ingredient. So this all works without errors. Now, that is good, of course. Let's now have a look at what this ng-build command generated. It generated a new dist folder. This folder contains a folder with your project name, and in there you got multiple files which basically contain the content of your application, so your code files. But now bundled and optimized and decreased in size as much as possible to be as small as possible. Let me actually inspect this here in my Finder or in the Windows Explorer to have a look at this. And there you see these files are much smaller. Remember that in development, we can see it here actually in the network tab. If I reload this page, we do have files which are 3.8 megabytes big and 1 megabyte. Now here, if we have a look at these files, they're way smaller. They shrank significantly in size because of all these optimizations. And ahead of time compilation is one important optimization because it removes the Angular compiler from the final bundle, which is super important and huge, of course. So definitely always build your application with ng-build-prod before you want to deploy it somewhere. But speaking of that, deployment is also something we'll focus on next in this course. This is it for this module. We had a thorough look at ng modules, what they do, which different types of modules we have, and when to use them. We also had a look at routing in these modules and at lazy loading to optimize our initial bundle size. You learned about services and modules and what's special about them, and that you can also set up preloading to optimize lazy loading even more. And now last but not least, we had a look at ahead of time compilation, which is another important optimization technique you want to use before shipping your app to a server. Now, speaking of that, in the next module, we'll do just that. We'll deploy our Angular app onto a server. So we learned so much about Angular throughout this course. And by the way, there still are some bonus modules to come after this module here, so definitely continue thereafter. But at this point of time, I now want to show you how you can take your application as you build it locally and deploy it onto a server so that your application does not just run on your machine, which is nice for development, but not that useful for your potential users, but that you instead really ship it onto a server that it has its own domain and people can visit it from anywhere in the web. Now for that, we'll first of all dive into the necessary preparations, and then I'll show you how you can host your Angular application in the web. So how should you prepare your Angular application for deployment? There are a couple of steps through which you should walk and through which I'll walk you now. And the first is that you should use and check environment variables. That's something we haven't done thus far, and I will show you what I mean with that point and how you can use environment variables, what that is, and why you might want to use that. Well, of course, you should also polish and test your code. And that is what we did throughout this course already. For example, in the optimizations and modules course section, I already showed you some important polishments or, well, code optimizations like lazy loading. So it's of course things like that which you should implement, and obviously you should test your application, run it, try out different things, try working with it as your users would work with it. Once you're done with all of that, you can build your application for production, and that means that you run a command that takes all your TypeScript code, compiles it to JavaScript, then bundles all your code together, translates it into Angular language, so to say, so that the Angular renderer can work with it in the browser, and bundle everything up and optimize it to be as small as possible. Because the application you're shipping has to be downloaded by every user using your website, and therefore it should be as small as possible so that your users have to download as little as possible. And you do all that with the ng-build --prod command. You already saw that in the optimizations module, because you also need to run this to implement ahead of time compilation, and that's just one of the many optimizations the Angular CLI does for you behind the scenes. Now, once you're done with that, once you build your app, you can deploy these build artifacts, these generated files, to a static host. And now, what is a static host? A static host is a web server that is capable of serving HTML, JavaScript, and CSS, but that's not capable of running any server-side language like PHP or Node.js. Why? Because you only need HTML, JavaScript, and CSS, because an Angular app is made up of just that. Of course, you can have some backend code. For example, we are using Firebase in this course. This could be your own backend, which you wrote with your own language, and you should definitely check out my mean course regarding that, because there I do show you how to build your own backend with Node.js as well. But if you're just working with Angular, if you're just building a single page application and you're not working on the backend on your own, then you in the end have just HTML, JavaScript, and CSS, and all you need for that is a web server that is capable of serving these files. So now let's walk through these steps together, most importantly the build and the deployment steps, of course, and let's see how that works. So here's the application we built, this project we worked on, the folder structure you already know, and let's assume that our code is already optimized and that we tested this thoroughly, and therefore the only thing that's missing is that we deploy this application. Now, before we do that, let me dive into that environment variable thing which you saw on the slides. And that is a feature that's actually built into every project you build with the Angular CLI. In the source folder, you have your app folder, but there you also have an environments folder. In that environments folder, you have two files, environment.ts and environment.prod.ts. Now, we're not using these files, but what you could do here you see you have an exported constant in the environment ts and in the environment.prod ts file. It's the same constant with the same name. You can add key value pairs to that constant. For example, if you were using an API that requires some API key, and actually we are using something like this, and hence I will show you how to use this environment variable in a second. If you are using something like this, then you can store that API key here. You can import that environment constant here into your files to use that API key. And what the CLI, the Angular CLI, does for you is that it will automatically swap these two files when you're building for production. So during development, this environment.ts file and the value you have in here will be used. And during production, this constant will be used instead. And this is swapped automatically. You don't need to write any special code for this behavior to occur. Now, why is this useful? Well, you might have certain values that differ from development to production. You might have some API keys that are meant to be used during development, and then you have different keys, which maybe are more restrictive, for production. Or any other value. You can store anything in here, any value which you need in your other files, and you have the option of using different values for production and development. Now, as I mentioned, we are using such an API key. We are using that in our auth service. In the auth service, we're sending requests to the Firebase backend APIs here to sign a new user up or to log a user in. And there I'm referring to that key thing here, right? We're using that Firebase API key here. Check the authentication section where I add this in case you haven't seen this code before. This key is the same here for signing users up and for signing users in. And therefore, we could, of course, manage it in a constant inside of this file. But especially if we were using that in other files as well, it's definitely worth moving that into this environment file in the environments folder. So here I'll name this Firebase API key. The name is totally up to you. And the value is then just that key value here. Now, with that stored in the environment TS file, we should also copy that into the environment.prod TS file, because this is the file that will be used when you build for production. And now with these keys added here, you can go back to the auth service, and there you now need to import these environment values. So here you can import environment, which is the name of that exported constant, from, and now you simply point at the environments folder, and there the environment file, not environment prod, but just environment. And again, this will be swapped automatically for you by the Angular CLI when you build for production. Now you can use that environment constant here, and in the places where we are using that key, here for example, you get rid of that key, and instead you add environment.firebase API key to that string, and therefore use that as a key value. The same, of course, here for signing users in. Remove it here and add this environment Firebase API key thing. Now that's a tiny thing, but the advantage here really is that you can swap values from development to production. Here we're not doing that, but of course that would be an option, and it's a powerful tool that can really help you with development. With the environment variables added, it's now time to build the project. And you already saw the command for that. It's ng build --prod. And this builds the entire Angular application for production, optimizes everything, and gives you an output which you can deploy onto a static server. Now again, let me highlight here that what this does is it compiles your TypeScript code to JavaScript. That's one important step. It also compiles all your templates to JavaScript instructions, so that in the end only JavaScript code is generated, JavaScript code that runs in the browser and contains all the logic for updating the DOM in the way you defined it in your multiple components and all the logic you added in your application. This is all done by the bundled up application, which takes advantage of the Angular framework that of course powers all of that. Now after running ng-build-prod, you get this dist folder, and in there you have a folder of your project name. And in that project name folder, Now you have a bunch of assets that you might have included, and you also got your main polyfill runtime file and a couple of other files. The exact names will differ for you, but you got a couple of JavaScript files which essentially contain your JavaScript code, your Angular app. This is how it looks like in the optimized form. Quite unreadable, right? But that is in the end all the logic of the Angular framework and of your code. And you will find some elements here which you have stored in your template files. So you can definitely also search these files for some snippets of your templates. But this is now the code. So everything in the project name folder, in the dist folder, all of that is the code which you need to deploy. It's the HTML file with a bunch of script imports, as you can see. And these script imports in the end make up all your app that starts. It's all these JavaScript files that make up your app and the style CSS file, which with some general styling, in this case with all the bootstrap styles. So now we just have to deploy this. How does this work? As I mentioned, you now need a static website host. And of course, there are many options for that. You can Google for static website hosts to find many articles and examples to learn where you can host such a static website. I particularly want to highlight AWS S3, which uses a special service of the AWS, so of the Amazon Web Services, that allows you to host static websites. That is definitely worth a look. You need an AWS account for that, but thereafter it's pretty straightforward to use, pretty powerful and pretty popular. And I also want to point you at Firebase hosting. Now you don't need to have the rest of your backend on Firebase to use that. It's a coincidence that here in this course we used Firebase for the authentication and for the database because it was easy to use and it is intended to be a all-in-one package. But even if you use your own backend or if you use a totally different API, you can always use Firebase hosting to host static websites. And indeed, it is what I want to use here because it's particularly easy to use. Now, here you can learn more about that in the official docs, and you see how you can get started with Firebase hosting. You need the Firebase CLI for that, which simply is a tool you have to install to automatically deploy your Firebase application. For that, you need to install the Firebase CLI first, for which you need Node.js and NPM, which we already got because the Angular CLI needed that as well. And therefore, you can dive right in and run this command to install the Firebase tools, which is the Firebase CLI in the end. So here, in a terminal, doesn't have to be your project terminal here, could be any terminal or command prompt on your machine. You simply run npm install -g firebase -tools. On Mac and Linux, you probably need to add a sudo in front of this to avoid permission errors. And now what this will do is it will install the Firebase CLI on your machine so that you can use it in every project, not just in this project, to deploy an application. So with that all run, you next have to run Firebase login to log into your Firebase account. Now I already am logged in here. If you aren't, you will be prompted for an email and password combination for your Firebase account. So you need a Firebase account for that. If you followed through that course, you probably already have one, or a Google account to be precise. If you followed through the course, you already have one because we used Firebase already. Otherwise, you have to create one or simply look into one of the other static hosts you can use. You find deployment instructions in the official docs of every host, of course. So here we'll continue with Firebase. We logged in. And the next step then is to run Firebase init to connect this project here with one of your Firebase projects. And for that, you now should be in your Angular project folder. So cd into it if you're not using the terminal built into your IDE. Firebase init now asks you what you want to use, so which Firebase feature you want to use, because you could use the Firebase CLI for other things too, not just for hosting. But I'm only interested in hosting, so let's tick that. Side note, we are of course using the database here as well, but we're not using it through the Firebase SDK, so we don't need to add that. As you see, it works without the CLI. For hosting, however, we need the CLI, so tick hosting here by hitting space next to it, and then hit enter. Now you need to choose a project to which you want to connect. And for me, that's this project. Simply choose the project you created for the recipe book. So here we need a Firebase project for the hosting. If you haven't created one yet, you need to create one now. Though, of course, the question then is, where did you store your recipes? But let's now choose this project. Now you're asked what your public directory is. And here you should not use the default, which would be public. But the public directory simply is the directory that contains all your files that you want to deploy. And in our case, that's in the dist folder, this ng complete guide update folder in my case, or whatever this folder name is in your case. So here we want to use dist/ng complete guide update, or whatever folder name you have in the dist folder. So your project name essentially. Now, you're asked whether you want to configure this as a single page app, and you should definitely choose Y for a yes here to ensure that all requests that are sent to that backend are always redirected to index.html, because that is a common gotcha indeed. You need to have a server configured such that it always serves the index.html, no matter which URL you entered into the browser. And the reason for that is that by default, the server always handles an incoming request first. And if it's a URL that's unknown to the server, you would normally get an error. Of course, we have the Angular router handling our different routes, but that, always keep in mind, runs on the client, so in the browser. And that only gets a chance to run if the server serves your app. So any requests have to reach the server first. There, they are all redirected to index.html, which in the end is our starting point for the single page application. And since any request, no matter which URL you entered, reaches that page, that HTML page, now the Angular app can take over for any incoming request with any URL on your server, and can then use the Angular router to load the correct content in your Angular app. That's why this redirection is important. So choose Y for a yes here. Now the existing HTML file should not be overwritten, so choose no here. And with that, you're done. And the next and last step then is that you run Firebase deploy. And this will now deploy the content of this folder onto Firebase. Now, this can take a couple of seconds, so let's wait for this to finish. And once it is done, it should give you a URL where you can find your application. So let's grab that URL and enter it in the browser. And there you should be on your application that should work just the way it worked locally, but now on a real server. We're still interacting with our backend API and everything, but now this is our deployed application. Welcome to this bonus module. Now, in this course, you already learned a lot about Angular. And actually, we already went through all the important fundamentals you gotta know. Now, this is a bonus module, and it is about a topic, NgRx, which is also maintained or developed by parts of the official Angular team, which can help you with state management in bigger Angular applications. So let's first of all have a look at which problem it tries to solve, and then we'll have a detailed look at how you use NgRx to manage your application state in a maybe more streamlined and elegant way. Of course, the obvious first question is, what is application state? Why do we need a state management solution? Doesn't Angular already have one? What is that state thing? Well, consider this simple Angular application. It's not the application we worked on in this course, but of course this could be just another application you have, where you have the welcome component, then a couple of training components here, because maybe you're building like a training application, something where people can do workouts and save them, and you have your training service. Now, in this application, the service would be there to manage the core data these different components need to work correctly. For example, you could be fetching exercises, or once the user is done with the exercise, you could store that exercise result here. Well, and all that data, which kind of is important for your application, because this data is in the end controlling what's visible on the screen, that is your application state. And this application state is lost whenever your application refreshes. So whenever you reload your Angular app, your website. Now, this simply is the case because this entire data here is managed in a service and in components, but all that together is just a JavaScript app in the end, right? Your entire Angular application is compiled into a JavaScript bundle in the end. So it's all in JavaScript, and therefore it's managed in memory by JavaScript, and therefore whenever your page is reloaded, the Angular app restarts and the other app is basically dumped, it's lost, and the memory is cleared. That's why it's refreshed, but that's not the problem NgRx helps you deal with, because that is not per se a problem, that's just how JavaScript works. And to solve that refreshing problem, we typically work with a backend. Like in this course, when we edit our recipes and we don't have a database on the backend where we store that data, well, then we would lose all our recipes and all the changes we made to them whenever our application reloads. And therefore, we typically also interact with such a backend where we store and fetch data too. This is so-called persistent state, and it's persistent because it survives our page refreshes as it is stored on the backend. So state, in a nutshell, could be translated with data that's important to your application and that influences what's visible on the screen. State is not just data like stored exercises or recipes. State could also be things like this app is currently waiting for some data to be fetched. So the app is in a loading state. It's showing a spinner maybe. So basically any data, any information that controls what should be visible on the screen, that is state. Okay, so that is state, and thus far in this course, we already managed such state. Typically in services, but tiny pieces of state are even getting managed inside of components. Let me show you examples. Here is our application as we built it. And if we have a look at the shopping list service, this would be an example of a service being used for managing state. Here, our ingredients, which we have here, which we can fetch, where we can add new ingredients, that's in the end data our application needs to work correctly, or at least parts of our application need that to work correctly. But that's not the only kind of state we have. If we have a look at our auth component here, there we also have some state. Here we have the isLoading property inside of that component, not stored in a service. And we use that isLoading component to change it once we are starting the sign up or the sign in process. And then we use it in the template to show a spinner, for example, here. Now that's also state, maybe not application state because it doesn't affect the entire application or larger parts of the application, but still it is state. You could call it local state. It's local to this component, but to this component it does matter. But again, it's data, it's information that controls what we see on the screen, and therefore this would also be state. Well, and if we have a look at the recipes service, there we also manage state, we manage our recipes, and we also store these recipes, not in the recipe service, but in the data storage service. We store the recipes on a server, and there we persist that data so that it doesn't get lost. This is how all these things work together, and that is how we already use state in our application. Now, what's the problem with this approach? Well, simpler apps, and that includes our course project, to be very honest, so I should maybe say smaller apps, typically are fine with how we already manage state by using components and services. And actually, you can get very far with this approach only. Even bigger apps can be managed with just services and components. But the bigger your app gets, and the more complex your state gets, so maybe an app like this, where we have a lot of components and service that interact with each other, if you have an app that becomes bigger and bigger and your state depends on many components at the same time and many components depend on a service and so on, then you could end up in a state management nightmare. So you could end up in an application where it's hard to maintain the app because it's hard for you to tell where exactly am I managing this piece of information. And maybe you're even changing a piece of information like the isLoading state of a component accidentally from another place in the application simply because your code is structured such that this is possible. Well, we already have a remedy to that, and that is RxJS, at least partly. RxJS already allows us to create a streamlined state management experience. With RxJS, and there specifically with subjects, we can react to user events in the user interface or to application events like some data fetching, finishing. We can react to such a state changing event, so to an event where we want to update some data or some information in our app, by using observables or, as I said, subjects. And we can emit or next a new data piece there and maybe use operators to even transform data in the way we want it, and then listen to such state changes in other parts of the application where we need it to then update the UI. And we're doing this already as well. If I dive back into the code and back into the recipes service, there indeed recipes are managed with the help of this recipes changed subject here. Now keep in mind that this subject in the end is used to emit a new copy of all recipes whenever the recipes did change. So for example, when we overwrote our existing recipes or whenever we added a recipe. And why does this matter? Because this then can be used in other components, like the recipe list component, where we set up a subscription to that recipes changed subject to update our recipes in that component and therefore indirectly update the user interface of that component whenever our recipes do change. So here we are already using a quite good pattern of managing our state by using subjects and using that push subscribe mechanism where we have a clear stream of data, a unidirectional data stream. It's, for example, not really possible or not easily possible to update our recipes outside of that predefined flow of using these methods in the recipe service where we then emit a new event where we then subscribe to. Yes, you can always hack your way around this, but of course, if you want to break your app, you can always do that. But what I want to say here is that this approach of managing state using RxJS and subjects is already pretty good and might be all you need, and that includes bigger apps. So even there in very large apps, you can definitely work with a setup that only uses services, components, and such subjects to manage the state. But that can, of course, be tricky because it really forces you to have an eye on providing a good structure and a clean setup and ensuring that really all services and all pieces of state are implemented in a good way. And that is where NgRx steps in. This RxJS-driven approach has some issues, as I outlined. To be precise, you could still have an app where state can be updated from anywhere because you maybe failed to set up a clear flow of data. Your state might also possibly be mutable, which means that whilst you might have only a couple of places where your state is intended to change, your code in there might not force you to state the old data by overriding it with new data. And that is what I would recommend doing though, because otherwise Angular sometimes doesn't pick up some changes to your state because of the reference type nature of objects and arrays in JavaScript, where if you only change a property of an object, the overall object didn't change, and therefore such a state change might not get picked up. And in addition, handling side effects, and that means things like HTTP requests. It's unclear where this should happen. Should you write the code for sending them in a component? Should you do it in a service? And yes, all these problems can of course be solved and you can have a clear route and a clear approach regarding all these things. But especially if you're working on a bigger app with a bigger team, it can be hard to enforce the best practices across all team members here. And therefore, enforcing a specific pattern might be hard because Angular by default doesn't enforce one. And that is where NgRx may help you, or to be precise, Redux may help you. Now, what is Redux? I just introduced NgRx. What is Redux? Well, if you have a React.js background, you might already know Redux. Otherwise, you will learn about it now. Redux is a state management pattern. It's also a library that helps you implement that pattern into any application. The idea behind Redux, so behind that approach for managing state, and always keep in mind, state is just data or information in your app. So the idea behind managing that state with Redux is that you have one central store in your entire application that holds your application state. So think of that as a large JavaScript object that contains all the data the different parts of your application need. Of course, kind of categorized in properties that might then hold nested objects, but in the end, that's the idea. Have one large data store. Your different parts of the application, services and components, can still interact with each other, but they receive their state from that store. So that store is the single source of truth that manages the entire application state. Now, of course, state is not just received. You sometimes also need to change the state. For example, when you add a new recipe. And for that, in the Redux world, you dispatch so-called actions. An action is in the end also just a JavaScript object with an identifier, basically identifying the kind of action you want to perform, and optionally a payload. So if that action needs some extra data to complete, for example, if you're creating a new recipe, you would need to attach that recipe data to the action, then you can have that data in the action that is supported by Redux. Now that action doesn't directly reach the store, instead it reaches a so-called reducer. Now a reducer is just a function, a JavaScript function that gets the current state, which is stored in the store, and the action as an input, passed in automatically by the Redux library if you use that. And then in the reducer, you can have a look at the action identifier, find out which kind of action it is, for example, add a recipe or delete a recipe, and then perform code on the state which you also got as an argument to update that state, however, in an immutable way. So by copying it and then changing the copy. Because ultimately, the reducer returns a new state. So it returns a copy of the old state that will have been changed according to the action. And that state, which is returned by the reducer, then is forwarded to the application store, where this reduced state, again, the state was edited immutably, so without touching the old state, instead copying it and then editing the copy. So where this reduced state is then overwriting the old state of the application. That is the Redux pattern. And as you can see, it enforces a pretty clean and clear flow of data. We only have one place in the app where we store our data, and we only edit it through actions and reducers, and we receive the state through so-called subscriptions, which we can set up. Now, if you're using Angular, you could also use the Redux library. It's not restricted to be used with React.js only, but NgRx is in the end just Angular's implementation of Redux. Now, it comes with some differences or Angular-specific things. For example, the left orange box here, it's deeply integrated into Angular. So it, for example, comes with injectable services so that you can easily access your application store in any part of your app by simply injecting it. It also embraces RxJS and observables. So all the state is managed as one large observable, you could say, and that also can yield certain advantages. For example, you can use all the observable operators to then edit the state you're fetching in the component where you need it, in the way you need it there. This will not change the store state, of course. And it, of course, also supports TypeScript. Now, in addition, there is one extra part of that state management library, which is about side effects. So NgRx also gives you a tool that makes working with side effects easier. And side effects, just to bring that back in memory, are things like sending HTTP requests. NgRx also helps with that. Traditionally in Redux, that was kind of an open question. It was unclear where you should send such side effects, where you should send such HTTP requests. So typically asynchronous code was always a problem, because reducers, I can say that already, only may execute synchronous code. So you must not and you can't send HTTP requests from inside a reducer function, for example. And therefore it always was kind of an open question in Redux where you should do such asynchronous tasks. NgRx ships with a built-in solution, and you will learn about that solution here too. So that was lots of theory. Time to finally get back to the code and start implementing that pattern and the package there step by step. So let's start implementing NgRx in our course project. And I chose the course project for that because I think you'll learn the most if you really see how it's implemented in a real application. Now, again, I stressed this on the slides already, but it is important to me. You could definitely leave the app as it is. It's not bad, not a bad practice or anything like that if you manage your state with services and with RxJS subjects. This is absolutely fine, and there is no reason to change this if you don't want to or if you see no advantage in NgRx. But my recommendation would be that you go through this module where we have a look at NgRx in great detail, and you then simply decide for yourself. Do you like that pattern? Do you maybe see its advantages in larger apps, and do you want to use it there? And then you will already have learned it. And that, of course, is what this module and this course is all about. So to get started, we first of all need to install NgRx because it is an extra package which you need to install through npm. As I mentioned, it is maintained by parts of the Angular team and also by the community. So you install it by running npm install in your project folder, --save to also add an entry to package.json, and then it's at ngrx/store. This is the first package we need. And I say first package because we'll later also need some other packages, but this is the core of NgRx, which you always need and which gives you the core features you need to get started. So let's now hit enter and let's wait for this installation to complete. With the installation finished, you can restart ngserve to bring your development server back up and this development process. And now we can get started adding NgRx. Now, if you recall that slide from earlier, you see that the core parts that we will probably need right now to get started are the store, the reducers, and the actions. Now, store and reducers are tightly coupled together. So let's get started by implementing a reducer. And for that, in that shopping list folder here, I will simply add a new file next to the shopping list service and so on, which I'll name shoppinglist.reducer.ts. So the shopping list reducer file here is the file I added. And in there, we have to provide such a reducer. Now, how does such a NgRx Redux reducer look like? As I said, it's just a function. So you should export a function here, which you can give any name you want, and I'll name mine shopping list reducer. And that function, and that's now important, receives two arguments automatically because we will soon add it such that it's automatically managed by the NgRx package, and this NgRx package will in the end be the part that calls this function, not right now, but soon, and the NgRx package will therefore pass these arguments into this function. So we can rely on two arguments being passed into this function. And that's the state, so the current state before it was changed. It's changed by the reducer, so obviously we get it before it was changed. And the second argument is the action, because keep in mind, it's the action that triggers the reducer and in the end a state update. So these two things are passed in by NgRx. Now inside of that function, we can now find out which kind of action it is and update the state. Now for this, we also can set up an initial state. Because if you have a look at your shopping list service, which of course is the thing we're trying to replace here, you would say the ingredients, that basically is our state, right? That is the data we're managing here. That also is initialized with a default value. We start with two ingredients. Now, of course, you don't have to do that, but here in this app we are. So this would be our current state and this would be our initial state. And therefore, it would make sense to have a similar initial state here when we switch to NgRx instead of using our own service. Hence, here in the shopping list reducer, we can create a new constant which you can name initial state. That name is totally up to you, just like this function name here, by the way. So here I'll name it initial state, and this should be a JavaScript object. Your state should be a JavaScript object. It actually doesn't necessarily need to be one, but for anything but very trivial apps or very specific cases, it probably will be a JavaScript object because that simply allows you to group more different data together. So here we have a shopping list service object, and in there, it would make sense to have an ingredients property. So let me copy that ingredients property, including the type and the 2 ingredients, and add this here to this newly added object. Now the ingredient type is missing here, so we have to add this import to this file, and I used my IDE to automatically add it. Now we need to edit this a little bit. Since we're in a JavaScript object, we don't assign values with an equal sign, but with a colon, like this. And TypeScript is able to infer the type automatically because this is an array of ingredients, and hence TypeScript automatically assumes that it, well, is an array of ingredients. So that is our initial state here. Now we can set that initial state by giving this first argument we're getting here in that function, initial state, as a default value. Now that's a TypeScript or next-gen JavaScript feature. You can assign default values to function arguments, which means if that function argument is not set or would be null otherwise, then this initial state is passed in instead. So the first time this reducer will run, it will receive that initial state for subsequent actions. So once the state has been initialized for the first time, and it will be initialized globally by NgRx, once it has been initialized, state will always be the previous state, only for the first time. So when NgRx is initializing the application state, it will be our initial state. So now we have the initial state, we have that function. What happens inside of the function then? I mentioned that we now have to find out which kind of action was dispatched so that we know how to edit our state. Again, don't get confused that we're not dispatching actions yet. We'll soon add the code to do so. Now, to check different kinds of possible actions, you could add multiple if statements and run different code depending on which action you have, or since you have multiple possible conditions, you can use a switch case statement. And then on the action, you have to check the type of that action. Now, to get better TypeScript support, you can add a type here to the argument, to the action argument, and the type would be action, where action is actually imported, not from this package, but where action is actually imported from @NgRx store. This exports an action interface, and this simply is an interface that forces any action to have a type property, which is why we can safely check it here. So now I'm switching on the action type, and now we can just register different cases. So different action types you want to handle. Now it's totally up to you as a developer of this application which action types your application has. And here we could start with a simple one. If we have a look at the shopping list service, getting doesn't really change the state, but maybe we start with adding an ingredient because that will change our ingredient's state. It will add a new one. So we could start with a simple state, which we now give an identifier, or type is the identifier, but the value of type is a string. So here we could name this add ingredient. Now it's absolutely up to you what the value here is, but the convention is to use an all uppercase text, which kind of is clear about what this action will do. So here, if I give this action an identifier, a type of add ingredient, it's pretty clear that, well, this action will probably add an ingredient. So add ingredient is the case here. And with that case registered, we now have to do what? If you recall what I said on the slide, we have to return a new state now. So we get the old state and we need to return a new state. Now what you could do is, you could take the state, which has the ingredients property, and then simply use push to add a new ingredient. And that would be totally wrong, because state changes with NgRx always have to be immutable, which means you must not edit the existing or the previous state. It's absolutely forbidden and a bad practice if you do so. So never touch the existing state. Instead, return a new object which will replace the old state, and to not lose all the old data, copy the old state with the spread operator. That is next generation JavaScript syntax, which is also supported by TypeScript. It essentially pulls out all the properties of the old state and adds these properties to this new object. Hence, we have a new object with the old data, and hence we have a copy of the old state. And if we now edit this copy, it's okay. So we copied all the old state, and now I want to override the ingredients. So I'll add the ingredients property, and now we can assign a new value to that. Now, correctly, you would say that the old state was just an object with the ingredients property. So if I copy the entire old state and I then change the ingredients, I essentially don't need to copy it. And indeed, you could omit this here because we're changing the only thing this state has. Still, it is a good practice to always copy the old state because later and in other apps, you will certainly have some states that consist of more than one property. And if you then only change one of the properties and you forget to copy the others, you overwrite the old state with the new state where you dumped all the properties you didn't change. And that's not something you want. So rule of thumb, always copy the old state, then overwrite what you want to change. Now, ingredients has to be an array, and of course here I don't want to lose my old ingredients. Therefore, in this ingredients array, I also again copy my old state ingredients now. So I access the previous state, which we still have here in the state argument, and there I access the ingredients property, which holds this array of ingredients, and the spread operator can also be used on arrays to pull out all the elements. And I then add all these elements I pulled out to this array here. So therefore now the ingredients array is a new array with the old elements in there. Now, side note, the elements themselves are also objects, and I didn't copy those. So here we technically still have the old objects in that array, but we don't change them, so that is fine. What I do change, however, is I do add a new element here. And that would, well, where do I find this? Well, it has to be part of the action somehow, but we don't know yet. So for now, let's just add the entire action object here, even though I can already tell you that this is not the final solution, because this is an object that, for example, has a type property. An ingredient doesn't have a type property, so adding the action is certainly wrong, but it's a first step. Let's next have a look at these actions and see how we actually create and dispatch actions. We added our first reducer, and thus far, NgRx is not doing anything for us, but we're getting there. The next step is that we also take care about the actions that we want to have, or about the one action which we support right now, adding an ingredient. We want to be able to dispatch this, and to dispatch this, and to there also reliably dispatch it in the same way by having the right identifier where we rule out typos, and by adding the right payload, ingredient that can be added here, we should also standardize this action creation process, or how such an action looks like. Because at the moment I'm just checking for this identifier here, but if I now would dispatch this action from anywhere in my code, I would have to make sure that I type this same identifier, and as you might imagine, if you're in a hurry, if your application is bigger, it's easy to forget a character, and then you have a bug that's super hard to spot, your app does not work correctly, and you waste hours looking for that stupid typo. To rule that out, NgRx also kind of at least pushes us into a direction where we have a clear pattern about creating and providing our actions as well. Now for that, I'll create a new file next to the shopping list reducer, and that is my shoppinglist.actions.ts file. Now, since the actions and the reducer kind of belong together and belong both to the NgRx setup, I'll add a new subfolder here in the shopping list folder, and I'll name it store because it's all related to the NgRx store. So let's move the reducer and the actions file into that store folder now. And now let's work on the shopping list actions file. Now in that file, I first of all want to export my identifiers, or my single identifier I have thus far, in a way that we can simply import it and we don't have to type it manually to rule out typos. So in the shopping list actions file, I'll therefore export a constant, which I also name add_ingredient, though that name is totally up to you. And then I assign a value of add_ingredient. Now this is a convention which I recommend following. You use a constant which's name is the same name as the one of your identifier, which in turn should be descriptive about what this action does. And you then simply store your string identifier in that constant. And by exporting it here in the actions file, we can import it into other files, like in our shopping list reducer file, where we need that action. And therefore, since we never have to type it again, and we just import it, and the IDE will yell at us if we mess up the import, it won't yell at us if we mess up a string. Therefore, for all these reasons, we now have a secure way where we rule out typos in the action identifiers. So now I will import add_ingredient from the shopping list actions file here. And instead of using the string like this down there, I just use add_ingredient like this. And this now refers to that string. Well, that's the first step. But of course, this step doesn't ensure that we, for example, have the right payload. The next step, therefore, is that we export another thing that describes our action. And our action, if we go back to reducer, is of course not that string. Keep in mind the action is an object which needs to have a type property. So the action actually is an object, not a string. It is of type action. And action is imported from NgRx store. So it probably doesn't hurt if we grab that action import and we import it here in the shopping list actions TS file as well. And then what we export here should be our action, and that should be a class therefore, since the action is an object and objects can be created based on classes. That should have a descriptive name, and I'll name it add_ingredient. Now, not all uppercase, because class names should be Pascal case, so using this convention, but it still is of course belonging to that action. I think that's pretty clear by the name. Now it's a class, and that class needs to implement the action interface we're importing from NgRx store. Action, as I mentioned earlier already, is an interface, not itself an object, and this interface being implemented into add_ingredient now forces us to structure the add_ingredient class in a certain way. To be precise, we need to have a type property in the add_ingredient class. And that type is the identifier of this action. Now this will always be an add_ingredient action, so type here should simply be add_ingredient, so our string from up there. And now an extra annotation which we should add here is read-only. That is a TypeScript feature which indicates to TypeScript that this must never be changed from outside. And if we ever try so from anywhere in our code, we'll get an error. And this simply enhances type safety and ensures that we don't mess up with our pattern. Now, as I mentioned, this action needs more than just a type though. It also needs the ingredient that should be added. And therefore, we can add more. We can add a second property, the payload, and that should be of type ingredient. And for that, you should also add an import to the ingredient model like this. Now with that, we finished our action definition. Now it still might be hard to see all these pieces come together, but we're almost there. Let's now use this action in the shopping list reducer. Let's extract the payload, and let's then finally work on registering the application store and also on selecting our state and dispatching actions. With the action added, back to the shopping list reducer. Here I'm already handling the add_ingredient case, which I'm importing from the shopping list actions. Now we can also rewrite this import, which is not a must, but kind of a convention you also see in a lot of demos and tutorials. Since we export more than just this constant here, we also export this class here, this add_ingredient class in the action file. We can import everything from that file with a star. And I don't just want to import it like this, but we always have to add an as keyword and give this an alias to group all the things that are imported from that file into one object under which we can access them in this file. And here I'll simply name this shopping list actions. So this is my shopping list actions object here. Of course, you could name this differently if you wanted to. And now we get an error here for add ingredient because I'm not directly importing this anymore. So here we can now just say shopping list actions dot add ingredient. This is the case we want to check for. This is the constant that holds this identifier. We also can be more specific about the action we're getting here now. The action here would be our add ingredient action. So we can set this equal to the type of shopping list actions dot add ingredient, and therefore we can get rid of that action import here in the reducer. So now we changed the type of the action. And now here, when we want to add a new ingredient, that's not just the action. Instead, our action now has a payload, and we get auto completion here in TypeScript support because we are pretty clear about the type of our action. It's not just the action interface NgRx forces, because that only requires us to have a type. We are more specific. We have an action which is of type add ingredient, which does not just have the type, but which also has a payload. And therefore we can access this here without TypeScript yelling at us. So now with that all done, how can we now use the reducer and our nice setup action to finally set up that application store, which it is all about, to then also use that? Because thus far we spent a lot of work on implementing something which has no effect. Well, that's about to change. To add our application store, let's go to our app module, and in there, I can remove the logging service by the way, but that does not matter too much. Let's import something from @NgRx store. And that something is the store module. That helps us with setting up that application-wide NgRx store. Now, store module, as the name suggests, is a, well, Angular module. And therefore, we should add it here. Maybe below the other Angular modules, we add the store module. We don't just add it like this, though. We also need to tell the store module, we need to tell NgRx what makes up our store, which reducers are involved. And for that, we call for root here. And to for root, we pass a so-called action reducer map. Now that sounds more complicated than it is. In the end, it's a JavaScript object where you can define any identifier of your choice. So maybe shopping list, and then the reducer that belongs to that identifier. And in my case, that's the shopping list reducer function, which needs to be imported from the shopping list folder, there the store folder, and there the shopping list reducer file. So that shopping list reducer function we worked on over the past lectures. This function is now assigned as a value to this shopping list key, and that key name is totally up to you. But of course, it should be descriptive about which feature of the app this reducer belongs to. And it is the reducer for our shopping list part of the app, therefore it makes sense to name this shopping list as well. With that, we told NgRx where to find our reducer, and therefore now when the app restarts, even though we don't see it yet, NgRx will take that reducer into account and set up an application store for us where it registers this reducer. So now any actions that are dispatched will reach that reducer. Well, and to see that initial application state, we can now start fetching some data from that state. With the store module registered here in app module and it being connected to our shopping list reducer, as I said in the last lecture, finally NgRx gets going. Time to use it. And I want to use it in my shopping list component. In the shopping list component, thus far we're injecting the shopping list service and the logging service. Now the logging service doesn't really matter. We can leave it here. We could remove it. It's not involved with our app state management. So I will leave it here, but I will inject something new. And that will be our application store. If you remember the earlier slides of this module, I mentioned that we're not using Redux but NgRx because it gives us some extra features and deeper integration into Angular. And for example, it gives us an injectable store that makes it easy for us to access our application state, which is stored in that store after all. Now the type here, which is important for the injection, is store. And store needs to be imported from @NgRx store. So this import needs to be added in the shopping list component. And therefore, we now have the store, but we still have an error here because store turns out to be a generic type. You need to describe how your application store looks like. And now that is the structure you set up in the app module. Here, it's this action reducer map which you set up here. This object where you have a key of your choice and then the reducer. This is in the end the structure of your store. Of course, in your application, you might, and in this module you will, have at some point a store that is made up of many different pieces. Later, for example, we'll have a shopping list area and a recipes area, and that's all merged together into one store. And therefore, our type is in the end a description of the different parts we have in the store. So back in the shopping list component, here the type would be a JavaScript object where we have a shopping list key. And now this has to be the name you chose here on the left as a key. And the type of the data stored in that shopping list area is now not your reducer function, but what this reducer function yields. And what does our shopping list reducer yield in the end? Well, a state of this type. It yields a state of a type object with an ingredients key, where this ingredients key holds an array of ingredients. That's the state data that this part of our global store holds. And therefore, back in the shopping list component, the value of the shopping list part of our application store is an object which will have an ingredients key. Again, this now has to be typed correctly. If it's ingredients in the shopping list reducer, which it is here, it has to be ingredients here as well. And the value, so the type of the values stored in this ingredients key is ingredient array, so an array of ingredients. So this is the final type of our store data. It's an object with a shopping list area, and in the shopping list area, our data will be stored in an object which has an ingredients key, which is holding a list of ingredients. Now with that store injected, we can use it. And thus far, we use our shopping list service to get our ingredients and to react to changes in our ingredients. Well, now I want to use my store here and get access to the ingredients stored in that store. And that will then, as it turns out, handle both these cases. Now on the store, which is this injected store service provided by NgRx, you have a select method. And that helps you select a slice of your state. Now that slice is identified as a string, and here I automatically get TypeScript support. It's shopping list. Now how did TypeScript know this? Well, because here we tell TypeScript that the type of data stored in our store is an object with a shopping list key. So here I'm selecting that shopping list part of my global store. Again, right now the shopping list part is the only thing I have in this store, but as this will change throughout the app, you of course need to tell NgRx into which part of the store you are interested in at this point. So here I select my shopping list, and this turns out to give us an observable. Now I actually want to store this observable in this ingredients, so I'll set this ingredients equal to this. But of course, TypeScript doesn't like this because ingredients is a property which is of type ingredient array. We need to change this. It should instead be an observable, and for that you should import observable from RxJS, so make sure to add this import. And now this is a generic type which will in the end yield an object with an ingredients array which will then hold an array of ingredients. Now, why do I know that we get data in this format? Because that is the data format of our store. In the shopping list part, which we are selecting here, we get an object with ingredients, which holds an array of ingredients. So this inner part, which is part of the shopping list stop part, which we select here, that is what we get on this observable. Now we can get rid, of these two parts here. We get rid of that. We can also get rid of that subscription, which we clear here. We don't need to manage the NgRx subscription here. We don't need to unsubscribe from this selection here. But now NgRx and Angular do that for us. Now ingredients is an observable and not an array of ingredients anymore. And that of course will break our template, because if we have a look at the shopping list component, we actually do a loop for all the ingredients, and that of course only works with an array and not with an observable. But Angular has us covered there. You might remember the async pipe from the pipes section. I can wrap ingredients with parentheses, and ingredients again is an observable, and add the async pipe like this. What this will do is that Angular will subscribe to ingredients for us, and therefore it will manage that subscription for us, and we don't need to do that on our own. And we'll resolve that, and in the end, therefore, we can access ingredients on that value that Angular will ultimately give us once it has resolved this and once it got a value from RxJS, from that observable. And then ingredients again is an array for which we can loop. So the async pipe provided by Angular is doing the magic here. It subscribes to that observable that we get here, that we store in ingredients. It subscribes to that observable and allows us to then access the ingredients, so the array of ingredients, once that observable has been resolved. And therefore, this code should indeed work correctly. If we now finally go back to our application, we log in real quick, and I go to the shopping list here, I get an error. Now we get this error not because our setup is wrong, but because one tiny piece is missing, and that's in the shopping list reducer. Now I did mention that at the first time when this application starts up and NgRx loads our reducer here, thanks to the store module, it would initialize our state with the initial state. Well, it does so, but not magically. To use that initial state and return it unchanged, we need to add a default case to our switch statement to handle any cases we're not explicitly handling. And we're only handling one explicit case here. And that's not the action NgRx will dispatch automatically when it starts. It kind of dispatches an initialization action, and we need to handle this, and we can handle it here with the default case. And there I simply want to return the unchanged state, and that will now be the initial state. This is how this will now work. And now if we come back, we indeed see our ingredients here. Now that was quite a lot of work for seeing some ingredients here. But now we got this general setup going. The last missing piece is now to dispatch an action. And thereafter we got the whole NgRx thing set up and we can dive deeper. So let's focus on dispatching actions next. We're able to get our state from the store with the help of the async pipe, but more importantly with the help of the injected store and the select method. And just to make this really clear, this is just an observable. So if you needed that state anywhere else but in the template, so in a place where you can't use the async pipe, you of course don't have to. The async pipe is just an option. You can also manually subscribe to your selected state. It's an observable, and therefore of course you can call subscribe. Now here, NgRx and Angular should also clear the subscription for you, but to be super safe, I would recommend storing this in a subscription property and try clear it manually as well, just to avoid memory leaks and bugs. Here, however, I don't need such a subscription, and therefore let's move on and let's dive into how we dispatch actions. Where do I want to dispatch actions? Well, if we're talking about the shopping list part of the app, that would be in the shopping edit component. In the shopping edit component, in the end, we got our code to dispatch actions whenever we're done. So whenever we're submitting our form to either update or add an ingredient. These are the two places where we change our ingredients that are displayed, and therefore the two places where we, change our shopping list state, and therefore should change the store. Now, how do we dispatch actions? Again, with the help of the store service. So now in the shopping edit component, let's again inject the store of type store, which you need to import from @NgRx store. So that hasn't changed. That import needs to be added. And with that injected, again, this is a generic type where you need to tell NgRx which type of data is stored in that store. And for the moment, we can simply copy that type from our shopping list component, though later we'll have a more elegant approach for that. But for the moment, let's just copy that over here. So this object with shopping list and then ingredients, which is of type ingredient array. And with the store injected, we use it in the places where we want to dispatch an action. We haven't set up an action for updating ingredients yet. So for the moment, let's simply take care about adding ingredients and let's dispatch an action there. For this, instead of calling add ingredient on the shopping list service, which we won't use anymore because we're also not getting our data from there anymore. Keep in mind that in the shopping list component, we are now fetching our ingredients from the store, from the NgRx store. So we have to change our data there as well. Changing it in the service won't do anything because that's not our data source anymore. So now here in the shopping edit component, we can access the injected store. And besides the select method, which we already used, there also is a dispatch method. And we use that to, you guessed it, dispatch actions. Now keep in mind that our actions for the shopping list area are defined here in the shopping list actions file. And thus far we only got one, which is the add ingredient action. It has a type and it has a payload. So now we can create a new type, a new object based on that action class here and dispatch it. For that, let me import everything as shopping list actions, again, because later we will have multiple actions from the store folder and there from the shopping list actions file. And on that shopping list actions object, which now bundles together all exports, there we can create a new object based on the add ingredient class that's based in that shopping list actions object, so which is based in that shopping list actions file. Add ingredient is just a class we have in here. Now this class has a type and a payload. Now it would be nice if we could pass the payload as an argument to the constructor, right? Because then we would have all in one place. And that, of course, is possible by simply editing the action class a little bit. Instead of adding payload just as a property like this, we can add a constructor function where we accept a payload argument. I add public in front of that to use that TypeScript trick where payload is then automatically converted into a public property with the same name as well. And the payload argument here, and you could name this differently, gets a value of type ingredient. That's my constructor. Now, this has to be public because, of course, I want to be able to access the payload from inside my reducer where I'm extracting it to store that ingredient in the ingredients array. In the shopping edit component, now we can pass the ingredient which we want to create here, or which we want to add here, to the add ingredient class constructor, which we're calling with the new keyword. So we simply pass new ingredient here, and we're now taking advantage of our action class. And this will dispatch this action to our store then. So what the flow will be then is that as soon as we add an ingredient, again, updating won't have an effect right now, but if we add an ingredient, we dispatch this action, which is clearly defined in the actions file, to that store, to that NgRx store. Keep in mind that we only have one such store in the entire application set up here in the app module. And that store is aware of the shopping list reducer because we have to create such a store with all the reducers that matter. And you will soon learn how to add multiple reducers. So then the action automatically reaches all the reducers that our store knows. So in this case, this one reducer here. And in that reducer, the action is therefore passed in as a second argument. And now we can check the different types of actions and react appropriately. That is what's happening here. And therefore, with all of that, we should be able to add sell it or anything else to our list here and automatically see an update. And whilst this looks exactly like the behavior we had before already, this is now entirely powered by NgRx because we're dispatching the action when we add something through NgRx, and we're also displaying the data based on our selection from NgRx. So we're using NgRx end-to-end for displaying and adding ingredients. Now it's of course time to make sure that we can also update and delete our ingredients, because these are the things our shopping list service also supported. And since we're basically replacing it with the store, we should of course make sure that we handle these cases with our reducer in our store as well. So let's continue working on this, and let's continue by having a look at how we can add multiple ingredients, because that's also a case we have. So not just one ingredient, but multiple ingredients at once. This is what gets triggered when we're working on a recipe and we then select the add to shopping list button here to shopping list. So that's this case. And we also have update and delete ingredient to handle. Let's start with add ingredients, because this probably is one of the easier cases to add. And for that, let's go back to the shopping list reducer and let's handle that second case. And for that, of course, we first of all have to go to the shopping list actions and add an appropriate action. So below the constant add ingredient, I'll export another constant, add ingredients, so plural. And here the identifier text is also add ingredients. By the way, in theory, you could of course deviate here. You could have a different string value than the constant name, but it is of course a good practice to keep those two in sync, since this makes it easier to match them mentally. Now, this is just the string identifier. An action, however, is an object, as you learned, and therefore we need a second class, which I'll also export. So I'll export another class. Add ingredients sounds like a fitting name, and just as add ingredient, this will implement an action. Now this class here, therefore, also has a read-only type, which here is add ingredients, so the plural form of that. And it will also get a constructor, and that constructor should now not take a single ingredient, but multiple. Still, I'll store the data we get in the payload property. And again, the name is up to you. This doesn't have to be payload, but payload is a typical name, and I would recommend following that convention. And the type here will of course not be a single ingredient, but actually an ingredient array, because we will add multiple ingredients at once. So now we export this class here back in the shopping list reducer. We can now handle that case. So we handle the case that our type is of type shopping list actions add ingredients here. And I'm getting a TypeScript error. Type add ingredients is not comparable to type add ingredient. Do you have any idea what could be causing this? Keep in mind that we tell TypeScript that the action type of the action we're getting in the reducer is shopping list actions add ingredient. Now that was true when we only had this action, but now we have two actions. And we can't tell whether the action that reaches this reducer is actually the add ingredient or the add ingredients action. Now what we could do is we could fall back to the more generic action interface, which we can import from NgRx store. That's the wrong import. Let's use NgRx store. We could do that, but then we get a problem with the payload, because that action interface doesn't know about the payload, so that won't work. So we need a different approach. Of course, we could simply use any, and that would work, but a bit more TypeScript support would be nice. And the solution is to export an additional type here. You can create your own types, so to say, with TypeScript, which you can name shopping list actions or anything like that. And that simply is a combination of all the types you want to include into your shopping list actions. So you create a union of the different action types you want to support in this part of your store. And the union here will consist of add ingredient and, separated by a pipe symbol, add ingredients. This is a TypeScript feature. This simply says the type of shopping list actions is add ingredient or add ingredients. So it's one of these two. And we export our own type to summarize this. This is a pure TypeScript thing, but during development, this will help us. And therefore now we say our action here is actually of type shopping list actions dot shopping list actions. Now, might look strange. The first shopping list actions here is simply the alias I'm using here for our bundled import, and you could name this differently. The dot shopping list actions then refers to this union type I have down there, which kind of combines add ingredient and add ingredients. And now TypeScript knows that our action is either of these two types, and therefore we get no error here. Now back to that case then, where we handle add ingredients. What do we want to do there? We always have to return a new state, so a new object here. And then you learned that I would recommend that you always copy the old state first, so all the properties of the old state. And then here, I again set ingredients equal to a new array where I copy all my old state ingredients, so all the existing ingredient elements in that ingredients array. And then I have to add the ingredients added by my action payload. Now action payload here should not be added like this, because what's my action payload if we add ingredients? Well, it will be an array of ingredients. So if we add it like this, then we add an array to an array, and hence we have a nested array. I want to add the elements of that payload array to the outer array. And therefore here, we should also use the spread operator to pull these elements in action payload out of this array and add them to this ingredients array. So now this reducer is updated. The actions here are updated. Let's now make sure we also use our new action and we dispatch it whenever we do add ingredients from a recipe. Because right now, if I, for example, add my recipes from that big fat burger here, go back to the shopping list, we don't see them here. The reason for that is that I don't get an error, but I do add these ingredients from inside the recipe service, and there I use the shopping list service to add the ingredients. Now that works, but keep in mind that the shopping list service is no longer our source of truth. We're not using the ingredients from the shopping list service anymore, and therefore adding them there doesn't do anything. Instead, here in the recipe service, instead of using the shopping list service, we should dispatch this add ingredients action to use our NgRx store instead. For that, in the constructor, we first of all have to inject our store, which is of type store, and that store still has to be imported from NgRx store, like in all other places of the app as well. And also, as in the other places, we have to be clear about what's inside this store. So you should actually grab the type definition as you have it in the shopping list component, for example. So this object with shopping list and then the nested object with ingredients, and use this in the recipe service here as well when you inject that store. So that TypeScript knows which store that is and what's inside of that store. Even if you don't select anything from it there, still you should provide it like this. Now the store is injected into the recipe service. And now here in add ingredients to shopping list, we're not using the shopping list service anymore, but instead the store where we dispatch a new action. And that new action should come from our shopping list actions file. And for that, again, let's import everything as shopping list actions. That name is up to you. From and now reach out to the shopping list area, to the store file, a store folder, and there to the shopping list actions file. We bundle all exports from that shopping list actions file into that shopping list actions object here. And with that bundled, when we dispatch an action, we use that, but not the bundled exports, but instead the add ingredients class that is set up inside of that shopping list actions file. Well, and this takes an array of ingredients, right? That is the kind of data this action expects. This is the add ingredients action. It expects a payload, which is an ingredient array. And therefore, in the recipe service, we have to forward such an array. Conveniently, we have one here in the ingredients argument. So let's send this with store dispatch. And now with that, if you go back to your application, this is our current shopping list with apple and tomatoes. If I now fetch my data again and I go to the big fat burger and I then execute to shopping list, if we go back to the shopping list, we have the two ingredients from that recipe here as well. And that works because we're now again using our global store. In our shopping list service, we had more than just adding a single ingredient and adding multiple ingredients. We also had functions to update an ingredient, and there we needed the index of the ingredient which we want to update and the new ingredient, and we had delete ingredient. Now let's implement these two features with the help of NgRx as well. For that, we can go back to the shopping list actions because first of all, obviously, we want to add some actions for that, right? We got two new constants that make sense. Update ingredient, which also holds update ingredient as an identifier here. And then also another constant, delete ingredient, which holds delete ingredient as an identifier here. As we learned, we also need classes because an action is actually an object based on such a class and not just a string identifier. So I'll export a class here, update ingredient, which will implement action and which therefore needs that read-only type that should be update ingredient here. And for updating an ingredient, we also need some data. So let's add a constructor, and the constructor here will get a payload again. And the payload here will actually be an object. So it's of type object, but not an empty object, but instead an object with two pieces of information. And we find these two pieces in the existing shopping list service. It's the index of the element which we want to update and the new ingredient. So therefore, here we expect to get the index, which should be a number, and the ingredient, which should be of type ingredient. Now that's one of the two classes we need. Deleting an ingredient is also an action. So let's also export the class delete ingredient here. That also implements action, therefore also has the read-only type, which is equal to delete ingredient. And we also need a constructor here because we require some data. And the data here, the payload, is simply a number because if we have a look at that shopping list service again, the information we need for deleting an ingredient is simply the index, which is a number. And therefore, the payload here will be the index of the thing we want to delete, so of the ingredient we want to delete, and therefore this is also just a number. Now we should add these actions here to our union type down there. So add update ingredient and add delete ingredient like this. Restructure this a bit to make it easier to read, written beneath each other. And with that, the shopping list actions file is prepared. But of course, the shopping list actions file is only one of the things we need. We also need to work on the reducer. We need to add logic there to update an ingredient and, unsurprisingly, to delete an ingredient. Now, how should that logic look like in the shopping list reducer? First of all, we got two new cases. That's the simple part. The first case is that in the shopping list actions, we encounter the update ingredient action. Whoops, update ingredient uppercase though, the string identifier. The second case which we need is the delete ingredient case. Now in both cases, we need to return a new object which will reflect our new state. So far, so simple. Now we need to update that state, and let's start with updating ingredients. As always, you should copy your existing state first, and then overwrite ingredients, because that is what we work with here, with a new array. And that new array will basically be the old ingredients array, where we edited one ingredient. So that requires a bit more logic. Let's write it here above the return statement. First of all, let's get that one ingredient that we want to edit. So I'll get it here. My ingredient is equal to state. That's my old state, right? That's the state I'm getting as an argument. So it's the previous state before we updated it now. So state, their ingredients, and then we can simply access the index because we get the index as part of our action payload, right? So action payload here will be index, or will have an index. So that's the ingredient I want to edit. But remember that we always have to edit data immutably here. So simply setting ingredient amount equal to action payload ingredient amount would be incorrect because that would edit the old states object or data stored in that old state object. And that is not allowed and absolutely not the pattern NgRx wants you to use. Instead, we should create a copy, and I'll name this updated ingredient, which is an object because ingredient is an object, where I copy the old ingredient. So I copy the name and the amount. And then I know that my action payload also has an ingredient, right? Because I set it up here when I define the types of data I get here. So I have an ingredient here as well. And therefore I can simply just copy action payload ingredient because that is an ingredient. And this ingredient I get here has of course the same properties as the ingredient I'm copying. So essentially I'm copying the old ingredient's properties to then override them here. Obviously we could therefore not copy this and simply just spread our incoming ingredient data into this new object. But for cases where, for example, you have an ID on that existing ingredient which you don't want to override, it would make sense to copy all the old data so that you keep things like an ID or anything else that doesn't need to be overwritten, and then you just override what needs to be overwritten. Here we actually override everything, but for demo purposes and to understand this general pattern, I still like copying it first and then changing what needs to be changed. Now that's the updated ingredient, but we need an array of, well, the old ingredients and then this updated ingredient being replaced. So for this, I'll add a new constant, updated ingredients, so plural, where I copy all my old state ingredients. So I copy the ingredient elements from my old state. So the array, the updated ingredients array, is now a new array. It's not the array in the old state, it's just a new array with the data of the old state's array. So updated ingredients is therefore an array I can safely edit. So updated ingredients can be edited by selecting the index where we want to update the ingredient with the help of action payload index, and then assigning a new element or overwriting the existing element at this index with a new element. And that new element is of course the updated ingredient. So I'm replacing the old element with that index in the copied updated ingredients array with the copied updated ingredient. And now updated ingredients is an array of ingredients where we overwrote one ingredient, and that was the ingredient that has to be edited. And therefore now the ingredients I set here in the state I return is simply my updated ingredients array. So that's the logic for updating an ingredient. Might look like a lot of work, but in the end this just enforces this immutable logic. And whilst this might look strange at first, it really is a good pattern that will prevent unexpected bugs where you accidentally added some old state too early and therefore your NgRx stored state gets out of sync with your rest of the application state that, well, doesn't expect such immutable mutations. So therefore always edit your data immutably, like we do it here, return a new state, and if you need to edit something inside of that state, copy it first and then edit the copy. Now, of course, we also delete ingredients, and there we also return a copy of the old state. And then we set ingredients equal to a new array. And just as before, this needs to be an array of ingredients where we basically have all the old ingredients, but we removed one. And this is relatively easy to do. You simply set ingredients equal to state ingredients filter. Now filter will always return a new array, so it will automatically give us a copy. And filter is a function built into JavaScript that will take an array, run a certain function which you pass in as an argument on every element in the array. And if your function, which you pass into filter, which we'll do in a second, if that function returns true, then the element for which it's executing this will be part of that new array filter returns. Otherwise, it will not. So the function we have to pass to filter is a function that runs on every element in the array you call filter on, so on every ingredient. And this function will automatically receive every element, therefore. Hence, we can name it ingredient here or just IG. And then I use an arrow function, and this is now my function body here. And in there, we have to return true or false deciding whether we want to keep that ingredient we're currently looking at. And again, this will run for every ingredient in that array or not. And I want to keep my ingredient if its index is not equal to the index we're looking for here, so which is part of our action payload. And the good thing is, the filter function, or the function we pass to filter, does not just give us every element for which it executes, but also the index of every element. So we also get the IG index, or whatever you want to call it. So we get 2 arguments by default. That is how filter works, how this built-in function works. It's not Angular, this is vanilla JavaScript. We get the element for which the function runs, so every element in the ingredients array, and then always the current index of the element we're looking at. And I want to return true for every element where the index is not equal to the index we're looking for. Because if I return true, then the element will be kept. If I return false, it will be filtered out. And I only want to filter out one element, and that is the element with the index we're trying to delete. So I return IG index not equal to action payload. And action payload already is the index for this action right here. It's already a number. So that is what I'm comparing. So if my action payload, if the index I'm getting is equal to the index I'm currently looking at, then this is the element I want to remove, and therefore I have to return false, which is what happens here, so that this is not included in the new array filter returns. So that was, again, a lot of talking. Let's now make sure that this also gets dispatched. For that, let's first of all go to the shopping edit component. We already dispatch our own action for adding an ingredient. Let's now also do the same for updating it. So now we can call this store dispatch new shopping list actions.update ingredient. And there we need to pass in an object which has an index property, which should be the index of the element we want to remove. And we get this here with this edited item index. And we also have to pass in the new ingredient which we want to use instead, and that is the new ingredient argument here. So this dispatches the update ingredient action. Now we can also delete ingredients, and there we currently call this shopping list service delete ingredient. Let's get rid of this as well, and let's use the store instead and dispatch a new shopping list actions delete ingredient action, where we now also need to include the index of the element we want to remove, and that is the this edited item index here. So let's dispatch this as well. Let's give this a try. If we go back to the application and I select tomatoes and I delete this, they're gone. So this looks pretty good. If I reload, they're of course back. This is how this works. I mentioned that your current state stored in your application would be lost if you refresh, and therefore our update of course also is lost. We didn't save this change to a server, but it works. Now, does updating work? If I change the amount to 10 here, looks pretty good. If I remove a S, also looks pretty good. Though I'm also back to 5 then, right? So let me show this again. I update this to 10. Now I lost the Apple S. If I update that again and remove the S, something is going wrong, because you might see that if I click on this, actually the old state is loaded. Apples and the amount. It's not loading the state we're seeing down there. So updating only partly works. Let's see what's wrong here. If we have a look at our shopping edit component here, we of course load data in ng-on-init from the shopping list service. To be precise, we actually manage our current editing state in the shopping list service as well. And we get our ingredient which we're editing here from the shopping list service. We're getting it with get ingredient, and then we're setting this on the form, so on the shopping list form. Hence, the values we enter into the shopping list form are not coming from our NgRx store, but still from the shopping list service. And in addition to that, we also use the shopping list service to control whether we currently are editing or not. Now we do have that subscription to started editing, which is managed in the shopping list service, because we do actually start the editing process from inside the shopping list component, not from inside the shopping list edit component. From inside the shopping list component, we have the onEditItem function where we can start editing. Now to translate this into the NgRx world, it would make more sense if we dispatch an action here in the shopping list component to start editing. Then the NgRx store will automatically kind of use a subject behind the scenes to inform our entire application about that. And then in the shopping edit component, we could simply listen to our store and see if we started editing. And if we did, we can kind of run the same logic as here. We would want to know which index, which item we are editing. So what I'm also passing around as information right now, I'm also sharing the index here. So we would want to manage this in NgRx. And then when we get our ingredient here, which we want to edit, then we also want to get this from our NgRx store. That would be the idea here. Hence, to implement this in an easy to use way, we can go to our shopping list reducer and change our state. For the first time, we haven't done this before, but now we need more than just the ingredients. Because now for our shopping list, to effectively update the different parts of our application that are involved here, I also want to store the edited ingredient here, which is of type ingredient, and also the edited ingredient index, which is of type number. So two new members, two new fields here in our initial state. Here, however, we don't need the types, we need values, because this is an object we're creating, not a type definition. So the ingredient with which I start will be null, and the number will be -1. It's not 0 because 0 would already be a valid index, -1 is not. Now we'll automatically have one issue before we've done anything else. We changed the structure of our state. And please remember that we have different places in our app, like the shopping list component, where we injected store. And in all these places, we do share a footprint, a definition of our store or of the data in our store. We define how the data in our store looks like, that it's having a shopping list part which holds our ingredients. Now, this is the part which won't really work anymore, because now it's not just ingredients, now we also have the edited ingredient and the edited ingredients index. And of course, we could now add this here, but that would be pretty cumbersome. We would have to add this everywhere in our application. And if we ever change the structure of our state, of our shopping list state again, we again have to edit it everywhere. And therefore, we can use a simpler pattern, which makes managing this a bit easier and more convenient. We can export an interface here to create our own type definition, which we can name state. And that describes how our state for this reducer looks like. That it has an ingredients property, which holds an array of ingredients. That it has an edited ingredient, which is a single ingredient, and that it has an edited ingredient index, which is a number. Now we know that this initial state will be of that type, so we can already add that type assignment here. So this is now of type state, of this state here. And the state we're getting here also will be of that type, just to be super clear. Now, with that state defined here, we can use that in the shopping list component and all the other components here instead of this state or type definition. But we can even take it a step further. This is just a state for the shopping list reducer. Now, right now, that's the only reducer we have. But in the future, we'll have multiple reducers. And then this shopping list part here is only a part of our global state. In the app module, we can see that the shopping list reducer is registered under the shopping list key. And indeed, in the places where we do inject our store, we do reference that shopping list key too. So since we're already merging states into our own objects, we can export another interface here, app state, to describe the application-wide state, not just the state for this reducer. And that would be shopping list, which then in turn holds a reference to this state. Maybe order it like this, though it doesn't matter, would have worked the other way around too. But now we're clear that our entire application state is about an object which has a shopping list area, where then in turn we have data of this type stored in. And now we can go to the different places where we inject store. Like here, the shopping list component, and reference this app state. And the convention for this, for the import, is that you import everything as from shopping list from the store folder, and there the shopping list reducer file. Now, why from shopping list? It's just a convention you also find in the official NgRx docs. You typically use that for describing an import to your reducer and or your state for a certain part of your application. And now, from our shopping list part of the NgRx state, so to say, we import something and we use that here. When we inject the store, our type is now from shopping list app state, because this is now describing our whole application state as it is seen from inside the shopping list reducer, and as it is relevant for when we use the shopping list reducer, to be precise. Our app state might have more than just that, but from the shopping list reducer's point of view, and in this file we're interested in the shopping list reducer in the end, the app state looks like this. Now we get other places where we injected the store. Shopping edit component, for example. There, I now also want to use that from shopping list import. So import as from shopping list from the store folder, and then the shopping list reducer file. And then it's just the same logic here. When we inject the store, we reference from shopping list app state. Now the same in the recipes service and the recipe service, where we also inject the store. Here I also want to import everything as from shopping list, from my shopping list part of the application, the store folder, the shopping list reducer file. And in the injection of the store, we now reference from shopping list app state. With that, I think I replaced all the places where we used that. Now we have a nicer type definition for our state that is more flexible, because now if we add something new, we only need to add it here in our state definition in the shopping list reducer file. And in all the places where we inject that store, TypeScript will then know what's inside of that store. But that was not the main problem we tried to solve. The main problem was that we want to manage the edited ingredient and its index here in NgRx. And we'll do that next. Now, to manage the edited ingredient here, we need new actions. To be precise, we need actions for starting the editing process and also for canceling or stopping it. Hence, I'll export new constants, start edit, which holds a value of start edit, and also exported constant stop edit, which holds stop edit as a value. Now, these are just the string types. As you learned, we need classes as actions or for our action objects. And I'll name the first class start edit, and of course it implements action. And then I'll copy that because obviously we also need a stop edit class. Now let's start with start edit. It needs that read-only type property, which of course is referring to start edit. And stop edit needs that as well, but of course here we refer to stop edit. Now stop edit actually can stay as it is. It needs no payload, because if we want to stop, I just want to reset the edited ingredient and the edited ingredient index to their initial values, so we don't need to change anything. Start edit, however, needs a payload. I need to know which ingredient we're editing. So I'll add a constructor with my public payload, and that payload can just be the number of the ingredient I want to edit. Again, stop edit doesn't require anything. Now, just as before, these new actions should be added to this union action type here at the bottom, so that TypeScript is aware of these actions as available actions inside of the shopping list reducer. So with the pipe symbol, let's add start edit, and let's also add stop edit here. Now that's the actions. Next on to the shopping list reducer. There we got two new cases to handle. We got start and stop edit. So the first case, which we get from shopping list actions, is start edit. Take the string, so all uppercase. And the other case is, of course, from the shopping list actions file, stop edit. Now in start edit and in stop edit, in both cases, we of course return a new object. And in start edit, I want to set my edited ingredient index to the index I'm getting as a payload, and the edited ingredient to the ingredient that belongs to that index. So if we go down to start edit here, first of all, I copy the existing state. And this is now where this is important, by the way. I mentioned all the time that I would recommend that you do this all the time. Now it's more important than ever, because now our state is more than just ingredients or than just the edited ingredient index. And for example, here, where we only edit the ingredients, if we don't copy the state first, we lose the edited ingredient and the edited ingredient index information. We don't want to lose that. Hence, copying the state is important. Now here I am copying the state, and now I want to store the edited ingredient index. Now that's part of my action. It's in the payload, because the payload for start edit is just a number, the index of the ingredient I want to edit. And of course, the edited ingredient itself should also be stored. Now that's not part of the payload, but we can get it from our state, because in this part of our application state, we're storing all our ingredients. So of course, we can also get our ingredient from there. And I get this edited ingredient by accessing my state, ingredients for the action payload, because that's the index of the ingredient I want to edit. However, if I would return the ingredient like this would not be that good. Why? Because this is a reference to the ingredient in my ingredients array. And objects and arrays are reference types. So if I now pass this on to, let's say, the shopping edit component, and I start changing properties on this ingredient, I do it right in my store, because this data is right from the store. I instead need to create a new object, which can then be edited without problems by using curly braces and the spread operator. And this now copies that ingredient which I'm getting from my ingredients array. This is then what I store here in edited ingredient. Now for stop edit, I again copy all existing state, and then the idea here simply is to reset edited ingredient to null and edited ingredient index to -1, so to the initial values we had before. All right, so now we got these two cases set up in the reducer. They should work correctly. Now, of course, we also need to take advantage of them by dispatching the right actions. So first of all, in the shopping list component, there in onEditItem, let's no longer use the shopping list service, but instead the store, which we already have injected here. And let's dispatch a new action. And for that, we need to import these actions first. So as shopping list actions from store shopping list actions. So there I access all my actions. I create a new action here based on my start edit class, and start edit takes the index, which I'm conveniently getting as an argument here. So now we're dispatching this action. In the shopping edit component, we can of course cancel editing here with onClear, and I want to let my store know about that. So besides resetting the form and resetting edit mode, I here also want to reach out to my store and dispatch a new action from shopping list actions. And that would be my stop edit action. And here we don't need to pass in any data because stop edit requires no payload. Now I'll also copy that and dispatch the same when we destroy our shopping edit component, so that if we get rid of that page whilst we are editing an ingredient, I also reset this. Otherwise we'll get strange behaviors the next time we revisit this shopping edit component. So the next time we try to edit an ingredient. So dispatch this here in ng-on-destroy as well, and also here on clear. And with that, the only missing thing is that we adjust how we fetch our data when we start editing up here in ng-on-init. There, instead of using the shopping list service and listening to started editing, we should use our store and select the shopping list slice. But now instead of using the async pipe in the template, I'll set up my own subscription, which I can, of course, because it is just an observable. Now what we get here is our state data for this part of our store. So the shopping list relevant state. To be precise, the state defined here. This is the type of data we get. Now in that subscription here, I then want to use this data. First of all, I want to check if in my state data, the edited ingredient index, and here I'm getting nice auto-completion because TypeScript understands this entire type setup. If this edited ingredient index is greater than -1, because if it's not, then I have some kind of weird setup. So in the else case, I haven't really selected anything, and therefore we should set the edit mode to false here. Now, if we do have a valid index, then the edit mode should be true. And I also want to set my edited item equal to my state data edited ingredient. Now, last but not least, then I also want to update my shopping list form as I did it down there in my old subscription, of which I now can get rid, by the way. So now we're initializing the shopping list form with data from that edited item, which we get from NgRx. So now the NgRx flow is complete. We dispatch the start and stop edit actions, and we now also get the data for editing from NgRx. And then once we're done, we also dispatch our update action back to NgRx. So now we got everything managed with NgRx. Now one remaining thing, the subscription here, I would recommend that you also manage this on your own. So store it in this subscription, which we used for the shopping list service subscription before. And therefore this is still managed here in ng-on-destroy and unsubscribed from when we don't need it anymore. With all of that, let me save that. Let me go back to the application and reload it. And now let's try editing the apple. It's not really reflecting my changes back to NgRx, so something is still wrong. The problem is that in the actions I'm dispatching here, for example, update ingredient, I'm referring to this edited item index. Now, I do have this property here, but I'm not setting it when we start editing. Now, two solutions. We could, of course, set this edited item index equal to state data, and then use the edited ingredient index we stored in there. And if we do that, deleting works, and updating works as well. And now our data also stays the way it is. So now this works. But of course, this is a bit redundant because we're extracting data from the store, which we then need in the store again to update our data, just to manage it in a component. So we could get rid of the edited item index here altogether and also remove it in the places where we pass that information. Because if you think about it, we already know which data we manage in the store, which data we're currently editing. We're already managing this in our NgRx store. We do have the edited ingredient index in there. So we don't need to receive this as arguments, and hence we can change our actions a little bit. For updating and deleting, I don't really need the index anymore. We could still get it, but we don't need it. Instead, we could say, well, for updating, our payload just is the ingredient because that's all we need. We already know which item we're editing. And for deleting, I need no data at all because I already know which item we're editing because we're starting the edit process with the help of NgRx. So with these changed actions in the reducer, we of course also need to change our logic. For updating, our payload now is the ingredient. So we don't access .ingredient, but just action payload. When we need the index, we just use the state edited ingredient index. The same down there. It's not part of our action anymore. It's already stored in the state. And the same for deleting. There, we also compare our index to the state edited ingredient index. Now, one tiny addition we should therefore also make here is when we do update or delete, we of course also stop the editing process, right? And hence, it would make sense to then also set edited ingredient index to -1 here and set edited ingredient to null. So to reset our ingredient or our edited ingredient data here for updating and for deleting, because these two actions also stop the editing process. Now in the shopping list component here, that also means that for updating, we just forward the new ingredient. It's not part of an object, not the value of some property in an object. Instead, update ingredient takes now just the ingredient as a payload. And with all of that, again, if I edit this, it works just fine, but now we update this correctly behind the scenes, and we have a little bit of a leaner code where we don't manage too much redundant data in our shopping edit component. So we started working with NgRx, and at this point, before we continue and we move more of the functionality we have in our application into the NgRx world, I want to sum up what we did thus far. And it's really important to follow along here so that it becomes clear which strengths and weaknesses NgRx has and why you might want to use it or might not want to use it. So we added NgRx to our application by including the store module and calling forRoot. ForRoot then needs a map, so basically an object, that tells NgRx which reducers we have in our application, because all these reducers and the state they generate make up the store of this application, make up the NgRx store. Now we add a feature for that with an identifier of our choice, and then the reducer for that feature. Now that reducer, as you learned here, is just a function. And now the important thing about that reducer function is that NgRx will automatically pass in the current state and an action it received. So it will execute this function whenever a new action is received, and then this function executes and gets both the current state and the action that was received. In the reducer, I then use a switch case statement, and this is a typical setup you see in the Redux and NgRx world, where we check the type of action we got, because action is actually a JavaScript object with a type property. And depending on the type which we have, we return a new state. And that is how a reducer function always works. Data in, data out. No asynchronous code. It's all synchronous. So we only have synchronous code in here, and we always return a new object which will be used to replace the old state for this part of the application. So for the shopping list here. And this return state is what NgRx will in the end register for this shopping list slice of the overall app state of the app store it manages here. So this is what we added. We added this reducer, and regarding the actions, we also added an actions file where we, for one, defined unique identifiers for all our actions. These are simply strings that identify each action. And then the action itself is not just this identifier, but it's a complete object based on classes we define in here. Each action needs to have a type property where we do store the string identifier for the action. But in addition, we might also have a payload, so a property which can be set to attach data to that action. And we needed that, for example, for adding an ingredient, though we also have an action, the delete action, which has no extra data because it doesn't need any. Now, this entire setup was really a lot of work. We have to be honest there. Adding the reducer, adding the actions, injecting the store, dispatching actions, that is a lot of overhead work. And using the normal shopping list service definitely was easier there. And therefore, using a service with subjects is a more than fine alternative to using NgRx. However, once you've gone through that first initial setup and you got NgRx going, you saw that it's pretty easy to add new actions, new state slices, and therefore it's really easy to grow our state and to manage everything in our app, or thus far in this app, in a part of our app, with NgRx. So it's mainly that initial setup that requires a lot of work. Once that is set up, it's actually quite fast to work with NgRx. Nonetheless, it's of course always up to you whether you want to add NgRx or whether you say, well, in this application, I'm fine with subjects and normal services. And as I mentioned multiple times, that would be fine. Now here, we're now managing everything for the shopping list with the help of NgRx though. And therefore, we can really get rid of our shopping list service here. So let's remove that shopping list service file. And hence, in the core module, get rid of the shopping list service we provide and of the import here. And now we got a couple of other places in the application as well, where I still injected the shopping list service, like here in the shopping list component. And we have to remove that as well as the import reference from all these places to avoid errors in our application. So also here in the shopping edit component, also remove the import, and also in the recipe service. There, I also injected the shopping list service. Well, it has to be removed from there as well. With all that removed, it compiles fine, and our application should also work just fine as it did before, now entirely powered by NgRx for that shopping list. So the rest of the application still uses services and will of course continue there as well and add NgRx in the other parts as well. Now that we worked on the shopping list, we could move on to the recipes, but that's something I want to save for later. For the moment, let's instead move on to the auth section here. And let's implement NgRx there as well. Now, for this, I'll add a new folder in the auth folder, and I'll name it store. And just as with the shopping list, I want to create a reducer and a file with the relevant actions for authenticating. Now, for authentication, you will also see that, of course, we interact with the web here in the auth service. We send requests for signing users up and signing users in. And that is something I'll also take care about later, because we can't send these requests from inside a reducer. But for the moment, we'll leave them in the service and we'll step by step move them into the NgRx world as well. So back to the store then. Let's add a auth.reducer.ts file. And in that auth reducer file, what do we need to export? Well, we definitely need our reducer function, right? Because, keep in mind, a reducer is a function in the end. So here I have my auth reducer function, and this again receives a state and an action. Now, for the moment, I'll just return state in there, but of course, we'll soon also add a switch case statement in there. Now, this auth state, of course, will have some initial state. So again, I'll create an initial state object here. And now let's have a look at what our authentication state actually is. At the moment, we're managing it in auth service. And if we take a closer look, in the end, it's just this user object here, which we manage through a behavior subject. The token expiration timer, that is only required for our auto logout timer. And we'll see how we handle this later, but it's not a core part of our auth state. We never use that from outside of the service, and we can't because it's a private property. So the only state that we use in other parts of the app is our user object here. And therefore, that has to be part of my initial state. I have a user, and initially that user will be null. Now, just as with the shopping list reducer here, I want to define an interface that describes my state, which will help us with injecting a store where we want to access that user or that authentication state slice. And therefore, let's export an interface, which we can also name state. We can name it state here, even though I also named it state in the shopping list reducer, because these are two different files, and therefore these names don't clash. And there I describe that my state for the auth part of my store will have the user key, and the type of that is user, using my user model, for which you of course have to add an import therefore. Now the initial state obviously is of type state, so let's add this type assignment. And here we want to initialize our state by setting it equal to the initial state, or that should be our default value for state to be precise, in case we don't have a state yet. So basically for when this store is created. Okay, so now we have that very basic auth reducer set up. Of course, we got no logic to set or remove our user here, so that's something we'll have to work on. Before we continue working on that, however, let's add our auth state slice, so this auth reducer and the state it produces, to our app module, so there to the store module. Here, to for root, I'll add auth, and you can name this however you want. I'll name it auth because it is about the auth part of my application. And there, I want to point at my auth reducer. So I can just call or set this equal to auth reducer, and of course add an import, importing auth reducers from the auth folder, the store folder, and there the auth reducer file. Now we initialize our global store, our NgRx store, and always keep in mind, even if we have different parts of the app where we manage the state with different reducers, we always have just one global store, and we're setting up this global store here by pointing at all these different parts that make up the overall store. So now we registered the auth reducer here, which is a great first step, but now I also want to make one other adjustment. If you take a look at the shopping list reducer, there we of course define how the state should look like for this shopping list part of the application. And we also define how our application state should look like with this app state interface here. Now, to be honest, that doesn't really belong into the shopping list reducer file, because the app state is more than just a shopping list reducer. Now, previously, before we added the auth reducer, we had only the shopping list, but now we have the shopping list and the auth part. And therefore, it's time for a new global store folder, which sits next to my shopping list, recipes, and so on folders. So it's in a root app folder. And in that store folder, I want to add a app.reducer.ts file. And the idea here is that it merges all my other reducers together. So in this app reducer file here, I want to import everything as from shopping list, following that naming connection, from my shopping list folder, there from the store and there from the shopping list reducer, and do just the same as from auth by importing from the auth folder and there from store and the auth reducer. Now why? First of all, because here I now want to create my interface, app state, which now has that shopping list key, where I refer to from shopping list and point at my state, not the app state. I will actually remove that app state interface here from the shopping list reducer, because again, this is the wrong place for defining a global application-wide state. It should only define the state for this part of the global state, so for the shopping list part. And then we'll have to fix some of the other imports and other files, but for now, let's go back to the app reducer, because there, besides my shopping list slice, I also will add auth and point at from auth state here. So now I'm importing these sub-states of parts of my global store, so of the shopping list and of the auth state, and I'll import these, so of the shopping list and the auth part of my NgRx state, and I merge them together into one app state interface. And of course, it's not just about merging these state definitions. I also want to create a new constant reducers, or app reducer maybe is a better name, and that will be of type action reducer map. And action reducer map is something you have to import from NgRx store. Now this type might be familiar to you because here in the app module, for root takes such an action reducer map. In the end, what I create here is such an action reducer map. And now instead of dynamically creating it in app module, I want to do that here in the app reducer, simply to structure this in a bit cleaner way. This, so to say, now is the one state, the one store we have in the entire app, and we create it by bringing together all these individual slices we have that make up this global state. Previously, we did this here in app module, but now since I also want to add my own type definition, my own interface for that, I rather do it in a separate file. So app reducer is of type action reducer map, and therefore it is basically a JavaScript object. Now important, this is a generic type, and we need to define which kind of overall state will be the result of that reducer map. And that will be my app state, of course. So the reducer map will have a shopping list and an off key. And that's therefore what we have to add here. Shopping list. And here we point at from shopping list and then at the shopping list reducer. And for off, we do the same. We point at from off and then at the off reducer. And now with this, we have our app reducer here in the app reducer file. And in app module, we now no longer create this object on the fly, so to say. Instead, we can now get rid of these two imports, so at the from at the shopping list and at the off reducer imports, and instead import everything as from app or from root or however you want to call it, from the store folder and there from the app reducer. And here to for root, we can now just pass from app reducer. That is now our merged reducer map. Might seem a bit redundant, but now is a really cleaner setup. Now, what does this mean for the different parts of the app where we injected a store and where we pointed at the app state that previously was exported from the shopping list file? Well, for example, here in the shopping list component, instead of using from shopping list app state, I now want to remove that import and instead import everything as from app from my root store. So in that root store folder from the app reducer. And then we simply replace from shopping list with from app. And this will do the trick because this now gives us access to our overall state where we still have a shopping list slice. But as you see, if you enter just quotes here, TypeScript should kick in and your IDE and give you auto-completion that you can either access the off or the shopping list part, because now we have two state slices in our overall state, not just one. And therefore it's the same in the shopping edit component. We can get rid of the from shopping list import and instead import everything as from app, from that root store and there the app reducer. And then instead of using from shopping list, we use from app state. And it's of course the same for the recipe service. There, if we remove from shopping list, we import everything as from app from our store folder here from the app reducer. And then again, for assigning this generic type, we use from app state. And with that, everything should compile and everything should still work as it did before. Let's quickly check this. Let's fetch recipes and add those ingredients to the shopping list. That all works, but now with this slightly different setup. So that was just some restructuring to have a cleaner code structure and have a store that works fine with multiple state slices, because now we have the shopping list and the off part. With that, let's continue working on that off part though. So let's work on our auth reducer. And for the moment, as I mentioned, we'll ignore any HTTP requests we send. So for example, this will stay here. But instead, my goal is to dispatch actions once we're done with the HTTP request. So once we got a response. So for example, here, where I tap in and I call this handle authentication. In handle authentication, we effectively create a new user object, and previously we used our subject to then emit this to our application. This is exactly what I need to store in my NgRx store now, and that is therefore where I want to step in and dispatch a new action. So here in handle authentication. The same, for example, in logout. There where we cleared our user. So basically whenever I called user next, in all these places, I want to step in and use NgRx and dispatch an action. For that we need actions. So let's go back here and add a authActions.ts file. And in that authActions.ts file, let's create a couple of constants again, a couple of identifiers for these different actions. And which actions do we have here? Well, we have login, for example, so when a user did log in. And we also, of course, have logout, when a user did log out and therefore should be removed. So when that user object should be cleared. Now, as you learned, actions are not just about their identifiers. Instead, an action is an object based on a class. So export a class here named login, and there, just as before, we'll implement action, which is imported. So let's import action from @NgRx store. That's important. Now this action interface, which we implement, forces us to add a read-only type. And that type here will be, well, login. That's the identifier for the login action. Now when logging in, we want to create and store a new user. And if we have a look at the auth service at handle authentication, we see that a user is in the end created here with email, user ID, token, and expiration date. Now we have two routes we can take. We can either create the user before we dispatch and then just attach the finished user object to the action as a payload, or we attach these four pieces of information as a payload and create the user in the reducer. Now ultimately that is up to you, but I'm a fan of moving more of that logic into the reducer, and therefore in my action here I'll add a constructor. Well, we would have needed that anyways, but here my payload will actually be a type or auth type object where we get these four pieces that make up a user: email, user ID, token, and expiration date. So an email, which is a string, a user ID, which is a string, a token, which is a string, and an expiration date, which is a date object. This is how a payload for the login action will look for me. But as I mentioned, you could also argue that a payload is just a user object and then you create that user object before you dispatch. Anyways, that's the login class I want to go with. Now we also need a logout class that implements action, and that's our logout action. This also has a read-only type, which is in this case logout. And does it need any payload, any data that is attached to it? No, it doesn't. It doesn't need any payload because if we log out, we just want to clear a user, but we need no extra data for that. We will just set user equal to null. Therefore, this looks like a good authActions file to me. Almost, at least. I, of course, want to export my union type, my authActions union type, just as we had in the shopping list actions file as well. There we had the shopping list actions where we united all these actions into one type. I want to do the same here, and therefore login or logout can all be used with that authActions summary or union type here. Back to the auth reducer. In the auth reducer, I now of course want to use my actions. And first of all, we can be clear about the type action will be here. It will be of type authActions. AuthActions is here imported from authActions, and we could definitely import it like this, but I will fall back to that star as authActions import syntax. Now authActions is an object with all the things exported by the authActions file, and therefore if I want to have the authActions type, we have to access it with .authActions. Now this double name might be confusing, but again, the first part here is just this container name of all the things that are exported by the file, and then with a dot we access the different exported things, like our string identifiers or this authActions union type. Now inside of the reducer, we can again switch on the action type and handle the different cases. And the first case on my authActions will be login, The second case will be log out. Whoops, not the class though, but the identifier with the uppercase characters. And we will also have a default case where we just return the state. This is extremely important for correctly initializing our overall store. Now let's start with the login off action. What's the idea here? What do we have to do? Well, if we have a look at the auth service, we in the end called handle authentication, where we in the end have to simply create such a user object with the data we're getting. That's all we have to do for now. So in the auth reducer, I will create a new user here by calling new user using the user model, which you therefore need to import into this file. We're already doing that here. And now to that user, we need to pass some data. And that's all data we're getting from our payload. So user here takes an email, for example. Well, we get that from our action payload, which has an email property. For the ID, it's the same. We have a payload which has a user ID property. For the token, it's again the same. We have a payload with our token property. And for the date, again, we have a payload with the expiration date property. So this creates a new user object. And now, of course, we don't need to emit this with a subject. We simply have to return this as part of our state for this part of the application store. So here we return a new object. And just as before, always copy the old state and then overwrite what you want to overwrite. And here I want to overwrite the user property and store my new user. So I said user equal to user, where the first user refers to my user property in that state slice, and the second user after the colon refers to this constant. Now the green wiggly lines here simply mean that I could shorten this to just this syntax, which is a TypeScript simplification that allows me to, well, if the variable name of the value and the property name are the same, we can shorten this, but to make it really clear what's happening, I'm deliberately using the longer syntax. Now for logging out, it's very simple. There I also want to copy the old state, and then I will set user to null here. It's as simple as that. Just want to clear it. Well, with that, the reducer is prepared. The actions are prepared. What's missing? We're never dispatching actions. And of course, we're also not using our store in any part of the application. Instead, we're still always using our subject here, our user subject from the shopping list service. Let's tackle that next. Let's start with dispatching. And for that, of course, for the moment, I want to dispatch from inside my auth service. Now, previously, with the shopping list, we mainly dispatched from inside components, though the recipe service and the add multiple ingredients case was an exception. In general, you can dispatch from wherever you want and need to. Now, that being said, we will restructure that service later to also handle these async HTTP requests with NgRx, but for the moment, since we do it in that service, I will dispatch from inside that service once we're done with the HTTP request. And therefore, let's inject our store here. I'll store it in a store property, and the type is, of course, store, where store is imported from NgRx store here. And with that store imported, this is a generic type, as you learned, and again, I want to get the type definition of my application store. So I will import everything as from app by pointing at from store app reducer, and then here we can use from app state. Now that's the store injected. Now with the store injected here, let's go to all the places where we call this user next, because that is where we currently update our state, because we emit a new value to the world. And that would be here in auto login, for example. So instead of using this user next, here I want to use this store dispatch, and I want to log in here, right? Because that's effectively what happened here. We have a loaded user with a token. Well, that simply means that we want to log that user in now. We want to treat that user as logged in. And therefore, we need access to our actions. Hence, let's scroll up and import everything as auth actions from store of actions here. And now back to that part where we just worked on. Let's dispatch a new action here. A new object has to be created because an action is an object. And let's refer to auth actions and then use the login class here. Now this requires a bunch of data. It requires an object with a couple of keys, with the email key, for example. We get that from the loaded user. So here we access the email. We also need to set the user ID, which we also get from the loaded user. There we have an ID. And the same for the token. We set this equal to loaded user token. Now for the date, it's a bit more tricky. We can get that from our user data though, with this code. So I can just copy that code. Of course, we could have also stored it in a separate constant to avoid copying it. And then simply set expiration date equal to new date of user data token expiration date. Now we dispatch, or we create an object which we then dispatch here in our auto login for logging a user in. Before we test this, let's handle all the other parts as well. For example, for logging out, we want to use the store and dispatch a new action, so a new auth action. And here it's the logout action, which does not require any additional data. So here we don't need to pass anything. And last but not least, if we scroll down to handle authentication, here where I call user next, just as before, I'll comment this out and instead call this store dispatch new auth actions log in. And again, we need to pass in data here. We need to pass in the email of the user. And here I already created a user object. This is of course redundant, so let's remove that. And let's instead forward the data we're getting as arguments here. So let's forward email. For the user ID, let's use user ID. For the token, let's use, well, the token argument we're getting. So I'm just passing on these arguments. And we're deriving the expiration date here. So let's forward this as well, like that. Now we're dispatching our new login action with all the data we're getting here inside of handle authentication. Now last but not least, here I'm storing a user object in local storage, and therefore it's not that good that I removed it. Until we handle that differently, I'll therefore will bring back my user creation, deleted it too early. Again, this is just temporary though. We will find a better solution for this later, but for now we need the user object here because we do access local storage, and that is something you should not do from inside your reducer. It's not asynchronous code, but it's a so-called side effect still. So it is something that is not directly connected to your state. It's something you do besides updating your app state, and therefore this should not go into a reducer. It wouldn't break the reducer, but it would be considered a bad practice. And I will show you how to handle such side effects with NgRx later. So for the moment, let's have this extra bit of redundancy here where we create a user, even though we then create it again in a login action or in the auth reducer to be precise. We will tackle this later. With all of that, we do dispatch all these actions, but now of course, we also need to make sure that we use our auth state. That's the next thing we'll take care of. At the moment, we're still using our user subject in our application. And let me simply comment this out so that we get errors that point us at the files which we now have to update to use our NgRx store instead. This is a nice trick to find all the places we now have to update. And that starts with the auth intersetter. In the auth intersetter, we're using the auth service and we're accessing our user. Now that is a good example for a place where we now want to use our NgRx store. So in there, let's inject our store of type store. As before, store needs to be imported from ngrx/store. And it still is a generic type, so again, we should import everything as from app from our root store folder, and there from the app reducer file. And then here the type will be from app state, describing how our state looks like in this application. Now here, where I refer to this auth service user, now we can instead just use this store select auth, And now, of course, I'm interested in getting my user out of that part of the global state. I don't want to take the entire auth state. This is an object with a user property. I'm just interested in the value of that user property. So in that concrete user we have here. Good thing is, select gives us an observable, so we can call pipe. And I only want to get one snapshot here, so take one still is correct. I want to have that here. But now we'll add an extra step before we continue with the user, because right now what we get here is not the user. Instead, it's an object with a user property. That's a difference though. So we'll add the map operator here, which you therefore have to import from RxJS operators. And with the map operator added, what we get here is our auth state in the end. So here, my goal then is to map this auth state into something new. Now this auth state here will have a user property, so I can access auth state user. And the IDE and TypeScript understand this automatically because I'm selecting the auth slice here, and I define in my app state setup, if we have a look at that app reducer real quick, I define that the app state has a shopping list and an auth part, and the auth part has the from auth state interface or structure. And therefore, this in turn comes from the auth reducer. It's this interface. And this all comes together in the auth intersetter, where I do select my auth slice here, and therefore, well, TypeScript is able to resolve which kind of data I'm getting here. I'm getting my auth state. Here I can then access the user property, and therefore this is now mapped into a new observable, which then reaches my next step, which takes just that user that's inside of that observable. So now this should work fine actually. With that, we have two more errors in the auth guard and in the header component. Let's move on to the auth guard first. Here again, I'm using my auth service user, and just as before, we can simply fix that by injecting the store here instead. Type store, again imported from @NgRx store, and again we need to import the description or the interface describing our app state. So import everything as from app from our root store app reducer. And then here, the generic type, when we inject store, is from app state. Again, this gives us the advantage that we're now able to use this store, select auth here. And again, we pipe. Don't know why it's coloring this in such a strange way, but this is the same code as before. We now pipe take one, which is good. But now, before mapping the user, well, actually what we get is not the user, but the auth state. So we need another map operator where we now get our auth state, and what we return here is auth state.user. And now this gets wrapped into a new observable, which then can be handled as before in here. And with that, let's move on to the header component. There, I'm also interested in my auth service and in my user. I subscribe to changes in my user, and therefore we should do the same here. Now by injecting the store, just as before, imported from @NgRx store, and also just as before, now we should import our app state from the app reducer in the store folder, so that we can assign this type here and get good auto completion and TypeScript support. And then here, we're not using this auth service user, but instead this store select auth. Then here I'm subscribing and I get my user. Again, this is not how it works. What select auth gives us is instead not our user, but it's an object where we have a user property. Hence, we can simply add pipe, add the map operator, which you need to import from RxJS operators. And with that added here, we can use that auth state. And now I'm using a quick inline statement because we only have one expression, which we instantly return. So here, this does exactly the same as we did before in the auth intersetter and the auth guard. I'm getting my auth state, I'm pulling out the user, and I'm returning that here in the map operator so that the next step in line really gets an observable that resolves to a user. And now all these parts should be fixed. It compiles fine. Let's see if it works as expected. Well, auto login seems to work. Let's see if we can fetch data and therefore if our intersetter works. That all seems to work. Let's fetch again. Yep. And logging out also works and the header is also updated correctly. Logging in is also looking good. So this all seems to work, and now we're managing this main authentication flow with NgRx as well. Before we tackle side effects and how we handle such effects with NgRx, two important things. First, let's have a look at our reducer real quick, and there at this default return state case. Thus far I mentioned that this is important for initializing the state. And that is true. When NgRx starts up, thanks to us initializing the store module in the app module, it essentially sends one initial action to all reducers. And since this action has an identifier we don't handle anywhere here, and we'll soon see which identifier this is, no worries. Since this is an identifier we don't explicitly handle, we make it into the default case, therefore we return the state, and since we have no prior state when this first action is emitted, we therefore take this initial state. So that's one important note. But another thing about what I just said is also important. This initial action, dispatched automatically, reaches all reducers. Well, that is not just the case for the initial action. Any action you dispatch, even your own ones, not just that initial one. So any action you dispatch by calling dispatch always reaches all reducers. It does not just reach the off reducer because you're dispatching it in the off service. How would NgRx know that this is your intention? It would be dangerous if that would be the result, because that means you could never reach another reducer with actions dispatched here in the off service. And there certainly are scenarios where you might want to reach another reducer. So therefore, any action you dispatch always reaches all reducers. This has an important implication. It's even more important that you always copy the old state here, and it's super important that you return this default state here, so the unchanged state, because if a shopping list related action is dispatched, it still reaches the off reducer. In there, of course, we have no case that would handle that action, hence all these code snippets here don't kick in, but therefore the default case kicks in and handles this. And there we absolutely have to return our current state, otherwise we would lose that or cause an error. And I can simply show that by adding a console log here, where I just print the state so that we can see what's inside there. And now let's go back to the application. Let's wait for it to reload. And please note, I added console log in the off reducer. Now let me do something related to the shopping list. Clear my console first, then I delete. You see, I get my user printed here from the off reducer. But what we see here is that this is our off state slice. Now this does not contain any information about the shopping list because the state slices, so these state objects, are managed on a per global state slice level. So the off reducer is only caring about its state, which has a user property. The shopping list reducer only cares about its state. But actions reach all reducers, and therefore it is important that we return our default state for this state slice here. Otherwise, if we wouldn't do that, if we would return null here or anything like that, we would basically drop our state here in the off reducer when something is dispatched in another part of the app. So that's the first important thing. The next important thing is that since our dispatched actions reach all reducers, you really have to ensure that your identifiers here are logged in across the entire application, because these off-related actions here are not just handled by the off reducer, they also reach the shopping list reducer. Now, of course, we in this application, we have identifiers that don't really interfere. Add ingredient and log in are quite different. But for bigger applications, it is of course possible that you have duplicate identifiers across different parts of your app. Now, since they have to be unique for the entire application, because actions reach the entire application, I would recommend a technique called prefixing. That means you added your identifiers here a little bit to have one extra piece of information that really makes them unique. In NgRx world, you typically use square brackets, and then you add the name of the feature you're dealing with. So in this case, that would be shopping list. And then you could still use the uppercase notation here, or you also use a normal text casing here, so to say. Now I will convert it like this. It's not a must do, but it is recommended especially for bigger apps to avoid clashes. Now of course any prefix that ensures uniqueness would be fine, but here I'll just implement a pattern you'll also find in the official NgRx docs. So here I'll always use the feature name in square brackets first, and then basically a plain English description of what it does. So let's quickly do that for all these actions here. It's especially interesting here for start and stop edit, because we could probably imagine that we have different parts in the app where we also start and stop editing. So that's my shopping list, actions file updated. And now let's also be consistent and do the same for the off actions, even though it's very unlikely that we use log in and log out anywhere else in the app, but still doesn't hurt. You don't need to change your constant name, so that stays uppercase log in and uppercase log out. It's really just about the values you store inside of these constants. And with that, we now enhance this a little bit more. Now let's focus on these side effects. First of all, let's understand what side effects are. And we can best see this in the auth service. Side effects are basically parts in your code where you run some logic that, of course, is important for your application, otherwise you wouldn't do it, but that's not so important for the immediate update of the current state. So for example here, this HTTP request. Of course, the result of that matters. It decides whether we did successfully create a new user or not. But for this process where we start the sign up process, this is not important. So we could basically split this up into two actions: start sign up and sign up success, for example, or even three actions: start sign up success, and sign up error. So the start sign up action would then be an action where the response here doesn't matter, and this is just a side effect for us. The sign up success action also is one where the response matters, but where we don't want to deal with sending this. So the request is kind of in between the different actions. Each action only cares about a part of that. This request, while it's on its way, is not really something our state cares about or our store cares about. We don't want to save that. It's just some side effect code we run. The same for local storage. This actually does not happen asynchronously. Accessing local storage happens synchronously, so it's done instantly, and we could therefore do it in the reducer. Only async code is forbidden there and will break it. Adding this line to a reducer wouldn't break the reducer, but it would be considered a bad practice. Because again, accessing the local storage and writing something to it or getting something from there is really just a side effect of the application. Of course, the result of that, especially when we're getting data, matters to us, but the process itself is not that interesting to us. So things like that are side effects. And whilst we could manage some of them, like local storage in the reducer, others, like async code and HTTP requests, can't even be managed there. And either of the two things would be a bad practice, even if we could technically handle HTTP requests in there. That's why there is a separate package, also provided and maintained by the NgRx team, that helps us with dealing such side effects while still staying in this NgRx world. And this package now has to be installed, of course. We do that with npm install -- save, and the name is @ngrx/effects. NgRx effects is a package that gives us tools for elegantly working with side effects between actions which we dispatch and receives, so that we can keep our reducers clean and still have a good place for managing these side effects. Now let's restart ngserve after installing this. It is important to me here to point out that, of course, you could also go for an approach where you still have a service for sending the HTTP request and for working with local storage. And then you have your reducer and NgRx for managing your current state. So basically the setup we already have here. You could also keep that. And as so much else with NgRx, it comes down to your personal preference and likings. But here, I think it is good, especially for learning about NgRx, if we move as much as possible into the NgRx world, and therefore if we use NgRx effects for managing our HTTP requests and local storage access. So let's start adding effects, and let's start by adding a login effect. And of course, we'll thereafter also add sign up and so on. For this, since it's auth related, in the auth store folder, let's add a new file auth.effects.ts. And in auth effects, we need to export a normal class. You organize your effects in classes. The name should be auth effects, matching the file name. And inside of auth effects, we now need to inject something, first of all. And that something is coming from the NgRx effects package. So from @NgRx effects, we have to import something, and that something is actions. Now we imported action from @NgRx store before for creating our actions. Actions here is something different. It's a different kind of object. It allows us to inject actions, and the convention here is to write this with a $sign at the end, but this is totally up to you. This entire name is up to you. And actions is of type actions. Now what is actions? Actions is one big observable that will give you access to all dispatched actions so that you can react to them. You just react differently than in the reducer, because in the reducer you of course also get access to all dispatched actions, as you learned. Here in the effect class, in the auth effects class, the idea now is that you don't change any state, but that you can execute any other code that should happen when such an action is dispatched, and that you then can simply dispatch a new action once that code, which also may be asynchronous, is done. So this is just a stream of dispatched actions, so to say. And again, using that $sign, I haven't done it before in this application. I got other observables injected where I don't add this. Some like to add a $sign after every observable so that it's clear that this is an observable. In a lot of the official docs, you will see that $sign especially for the actions. Hence, I leave it here, but it is up to you if you add it or not. It's not required. So the actions are injected here. With that injected, we can register our first effect. So our first action handler, so to say. You add such an effect as a normal property in your auth effects class. And I will name this auth login. The name is totally up to you though. You can choose any name here. It should kind of describe which kind of effect you're handling though. Now in here, in auth login, I now assign a value, and there I use my actions. So I'm referring to the injected actions property here. Whoops, like this. Now actions, as I mentioned, is just an observable, and therefore we can call pipe or subscribe. Now don't call subscribe here. NgRx effects will subscribe for you. Just call pipe instead. And what you need to pipe here is now a special RxJS operator, which is not part of RxJS, but which is provided by @NgRx effects. It's the auth type operator. Auth type simply allows you to define a filter for which types of effects you want to continue in this observable pipe you're creating, in this observable stream here. Because you can have multiple effects by adding multiple properties to your class here, and you can simply define different types of effects that you want to handle in each chain. So here, for example, we could handle the login effect, or to be precise, the login action, since we're basically reacting to all dispatched actions here, and this is a filter to allow us to define for which exact actions we want to continue in this chain. And now I need more actions. Thus far, we only had log in and log out. But now, since we actually want to send the HTTP request here from inside our auth effect, we need a new identifier, which could be login start. And the value here could be auth login start. Of course, you could name this login success, but I don't want to rename it everywhere where I used it. Hence, I will keep that named login. Login start, however, is basically the point where we want to start sending our request. So here in auth effects, we now import everything as auth actions from this auth actions file. And here in auth type, we can then refer to auth actions login start here. And what this says is only continue in this observable chain if the action that we're reacting to here is of type login start. All other actions will not trigger this effect here. Only login start will. And you could add multiple actions here, by the way, if you want to run the same code for different actions. So we're getting started with defining this effect. We're filtering for specific actions. But of course, the question is, what do we want to do with these actions then? Or with the action that we are reacting to. So in this case, to the login start action. Well, the login start action should yield us some specific information that we need for logging in. For that, we need to create a new action class here in the auth actions file. The login start class, which also implements action. That, of course, has our read-only type, login, which is login start. But it also needs a payload, because for logging in, we need what? Well, an email and a password. That is what we currently use in the auth service for login. Here, if you check login, we get email and a password. So in the auth actions, here I also expect to have a payload, which essentially is of type object, where we have an email key, which is a string, and a password key, which is a string. So this is how such an action should look like. With that defined here, we can go back to the auth effects and now add another RxJS operator as a second step. First step is that we're filtering. Next step now can be a switch map, which allows us, which is imported from RxJS operators, which allows us to create a new observable by taking another observable's data. So here we get our auth data, and we know, since we're filtering for the login start action, that the type of this will be auth actions login start, now referring to the class. So this is our type of data, and in switch map, we now can return a new observable. And the new observable I want to return here, of course, uses the Angular HTTP client to send our login request. So just what we previously did in the login function, our service. So we can actually copy this entire code snippet here from the login method here in the auth service and add it to auth effects in this switch map here. Now, important though, this of course requires us to inject the HTTP service. We also need to get access to the auth response data interface, to the environment constant for getting our Firebase API key, and we need to extract email and password. Now let's start with extracting email and password, because that is of course part of our auth data payload. So here we can just access auth data payload email and auth data payload password. Next, let's inject the Angular HTTP client. So let's go down to the constructor and call private or add private HTTP and refer to the HTTP client imported from @Angular comment HTTP. Let's also get access to the environment constant here, which we can find in our environments, one level up, in our environments folder and there in the environment file. And regarding the auth response data, that's an interface I'm defining in the auth service. Let's actually copy it from there, not remove it there right now because we still need it for signing up. We will remove it in the future. And let's move it over to auth effects as well. So now we have our auth effect for logging in, but this effect won't work for a couple of reasons actually. First of all, an effect by default always should return a new action at the end once it's done, because this effect itself doesn't change the state, right? It just executes some code. Nowhere do we touch our reducer or our NgRx state, and that's how it should be. But typically, once an effect is done, you want to edit the state. And that's the same here for logging in. Once we did log in, if we did succeed, I of course want to dispatch my login action so that the reducer can take over and create that user object. So therefore, we need to return a new action here at the end of our action of our effects chain here. And in addition, we also need to add a special decorator to this auth login property here to turn it into an effect NgRx effects is able to pick up later. That is the add effect decorator. And effect simply is imported from add ngrx/effects. This is required for NgRx effects to pick up this property as an effect. So basically, as an effect it wants to handle, it wants to subscribe to, and so on. And the next step, as I mentioned, is of course then also that we return a new action here at the end. And since we're in an observable chain, returning a new action simply means that we have to return a new observable. Now, of course, I only want to log the user in if we haven't gotten an error from this HTTP request, right? That's the same logic here in the auth service for logging in. There, we send this request, we catch errors to handle errors, and only if we get no error, we continue here, and then we handle the authentication. I want to do the same here with auth effects, but the logic has to be a bit different. It's important to understand that an observable completes whenever an error is thrown. Therefore, in the auth service, whenever this here yields an error, catch error kicks in, and this code never executes, and this entire observable dies, which is no problem because when we call login again, a new observable is created. Now, it's a bit differently for effects. Effects here, this is an ongoing observable stream. This must never die, at least not as long as our application is running. And therefore, if we would catch an error here by adding catch error here as a next step after switch map, which we could do because switch map returns an HTTP observable, and this could certainly throw an error. If we add the catch error like this, or even if we don't add it, if this throws an error, this entire observable stream will die, which means that trying to log in again will simply not work because this here will never react to another dispatched login start event because this entire observable is dead. And therefore, errors have to be handled on a different level. Here, we're creating a new observable, and with switch map, I'm returning that new observable here, right? We can call pipe on that inner observable too. Previously, we haven't done this, but now we need to do it here. This allows us to add operators on this inner observable, not on the overall observable chain. And here we can now pipe catch error, which you need to import, by the way, from RxJS operators, and also pipe map, which will execute if we have no error. And that also needs to be imported from RxJS operators. Now, catch error, of course, receives any error we might be getting. And now here we can run our error handling code. But most importantly, and that is super important to understand, here we have to return a non-error observable so that our overall stream doesn't die. And since switch map returns the result of this inner observable stream as a new observable to the outer chain here, returning a non-error observable in catch error is crucial so that this erroneous observable in here still yields a non-error observable, which is picked up by switch map, which is then returned to this overall stream, to this overall observable chain. So in here, I will therefore use auth, which is imported from RxJS, which is simply a utility function for creating a new observable without an error. I will call auth in here to return a new observable. Now, the same inside of map. This by default wouldn't have an error, but of course here we also must not create an error. We instead have to return a non-erroneous observable here as well. Now here inside of map, what do I expect? Let's have a look at the auth service. We should get our response data here. And therefore, let's go back to auth effects. We get response data. And ultimately here, I also want to use auth to create a new observable. The question now just is, what should be inside of these new observables we're creating here? So I hope it became clear why we must not return an error. Still, the question, of course, is we're creating new observables here in catch error in map. What should be inside of these observables? Well, keep in mind that I said that you typically want to dispatch a new action once you're done with the code in your effect. So what should be in here is your new action. You don't need to call dispatch because that's also partly done by add effect here. Your entire chain's result here will automatically be treated as an action by NgRx effects and therefore will be dispatched. So here you just need to return or add an action object and NgRx effects will automatically dispatch it for you. And that means that here we can of course create a new action. Now we have no action for the error case. So for now let's simply try avoid this and not create any errors until we add proper error handling. For now I'll just return an empty observable. Here in map, however, we can return a real observable. And of course here, I want to return an observable that holds my login action. So not the start, the login start action, but the login action. Because now at this point of time, I have a successfully logged in user, and I want to reflect this in my application by reaching that login reducer code. And for that, we need to dispatch that login action. Hence, here in auth effects, we're already importing auth actions. So down here, let's create a new auth actions login object. Now there we need to feed in an object with the email, password, and so on. In auth service, this is all data we forwarded here to handle authentication since we got it from REST data. And in handle authentication, we then did some additional things like calculating the expiration date. In the end, I'll just copy that calculation here, like this, go to the auth effects, and now do this here in map data. REST data holds all the data I need. For example, in REST data, I find the expires in key. TypeScript is just complaining here because map here will, by the way, also execute after catch error since we don't return an error anymore but a normal observable. Hence, we should switch order here. Then map will be skipped in case of an error and catch error will kick in. But when catch error executes, map will not run again. And now I also need to convert this to a number by adding a plus here to avoid errors. So now we're calculating the expiration date. And now here to log in, we pass in the email, which we get from REST data. There is an email property. We need to pass in the user ID, which we also get from REST data. There it's that local ID key. We need to pass in a token, which we also find in REST data. It's the ID token property. And expiration date is our expiration date constant we just worked on. So now I'm returning this new action here, and this, as I said, automatically gets dispatched by add NgRx effects. Okay, so that was a lot of talking. Let's ignore the error case for now and signing up and so on. Let's now make sure that we take advantage of our effect here for logging in. And for that, we have to wire everything up now. To wire our effects up, first of all, we have to go to auth effects here to our class and add injectable here, like this. Add injectable, or the injectable decorator, needs to be imported from add Angular core, and it is required here not to provide this in root, so don't add this. It will never be injected itself, so it doesn't need to be provided. But it needs add injectable so that things can be injected into this class. And we are injecting actions and the HTTP client. Otherwise, we would get errors. So add injectable is needed here so that things can be injected into auth effects. Now, for registering all the effects in this effects logic globally, we have to go back to the app module, where we also registered our store module. And after registering our store module, we now register, well, you probably can guess it, an effects module, which we get from add NgRx effects. Now that effects module here also has a for root method, like this. And to for root, you now have to pass an array of your root effects. That means of your effect classes. And here that is the auth effects class, which you therefore also need to import auth effects imported from the auth folder, from the store folder, and from the auth effects file. So we're registering this class here as a class that holds effects. We're forwarding it, or we're passing it to effects module, and NgRx effects does the rest and sets this all up. The missing piece for us now is to dispatch a login action. Now we have our login start action, we have it here in auth actions, and therefore all we have to do is we have to go to the place where we do call login on the auth service, and that is our auth component. Here in onSubmit, I have my observable for logging in or for signing up. And now here, when we do log in, I don't want to use the same logic as before. Instead here, I now want to use my store. So let's inject store of type store. As always, store is imported from @ngrx/store. It's a generic type, and therefore it needs information about how our app state looks like. So let's import everything as from app from our app reducer. And here we then have from app, app state. And now when we do log in here, let's comment out this old code, and let's instead use this store and call dispatch. And now we just need access to our auth actions as well. So time for another import. Import everything as from, and not as from, but as auth actions from the store folder in the auth folder, and there from the auth actions file. And with that imported, we dispatch a new auth action, which is login start here. Now that needs two pieces of information in an object. It needs the email, which we have as a constant here, and it needs the password, which we also have as a constant. So let's forward email and password here. And with that, this gets dispatched. Now, one important side note, dispatch here does not give us an observable, which is why I can't store this in auth ops. This also means we're not notified about once this is done, this login process, and hence resetting loading and navigating away won't work for the moment. We'll have to check the network tab for whether this whole login process in theory works correctly, and thereafter we'll have to find out how we get information like, are we still loading, out of our store. So for the moment, let's still test it like this though. Let's save everything, and let's go back to our application. Log out, and let's try logging in. Now, as I said, this here simply fails, and that is to be expected because we haven't updated all the code. But let's check the network tab here for requests that left our application. And there indeed we see verify password. We did send a request to this path, and that indeed is the login path, and we got a 200 response back. And indeed in the preview we see we got success data here. So the login request was sent, and it also looks like it generally succeeded. However, the rest of this application is not really working. It basically broke down. We have an error, and therefore it's now broken. Our app is broken. That, of course, simply is related to the fact that here in our auth component, we are trying to subscribe to auth ops, and that is simply not set in the login mode. It's still undefined here because here I'm not setting it anymore because dispatch doesn't return an observable to which I could set it. Instead, we'll have to find a different solution for being notified about whether we're currently waiting for a response or whether we were successful or if we have an error. The solution to the problem we're facing here is that we need to manage more of our authentication-related state, and also the state that only matters to this component here, in our NgRx store. To be precise, we should at least manage whether we succeeded or failed. Well, we are managing the success case here with the login action, which leads to the reducer creating a user object. We should also add a login fail action. Let's export a new constant, login fail. The value can be auth login fail here. And let's create a new class for that as well, export class login fail implements action. And here the type will be, the read-only type will be equal to login fail. We might also want to have an error message. So let's also add a constructor with a payload. And the payload here is just a string, could just be our error message. Of course, you could also use an object with more data here if you wanted to, whatever you want. With the login fail action added here, we also have to work on our reducer and what we manage in the state here. A potential login error should be managed here, since we also have that login error action. Hence, I will add a new property to my state here of error, which should just be a string here, just a message. And here in the initial state of error, therefore, could just be an empty string, but I will go with null. So initially we have no error. Now in the reducer, when we did log in successfully, I also want to set of error back to null in case it was something different. And I want to do the same when we start logging in. So it's time for a new case where we access our auth actions and use login start. Because whenever we start a new login process, I essentially want to copy my old state and I want to set auth error back to null because we have a new chance of logging in. Of course, we don't want to start with the error right away. Now to avoid this error which I'm getting here, I have to go back to the auth actions and add all these new actions to the union type down there so that they can be handled in the reducer without errors. So here we have login start, we have login fail. With that added here in auth reducer, we get no error anymore. We added login start. Now, of course, we also need to handle the fail case now. So the login fail case here. In that case, we also should return a new state based on the old state, where we probably want to set the user to null because logging in failed. So I see no scenario where we would have a user. And then set auth error equal to action payload like this, because payload already is a string. It already is the message I want to use. So now we're handling that in the reducer, this login fail case and the login start case. We have an auth error property in our state, therefore. Hence, now we can simply subscribe to that in the auth component to be informed about potential errors we're getting. For this, instead of subscribing to our auth observable here, I'll comment this out. Therefore, signing up will, for the moment, not work. But instead of doing that, I will select my auth part of the store and subscribe to that. And of course, here we get our auth state object. And we could use a map operator before that to extract the data we want. In that auth state object here, we get the current user, and we also get our error if we have any. Now, I will actually now revert a bit and actually manage the loading state here in the reducer or in the NgRx state as well. So loading is a Boolean here. And initially loading is false. And I'm managing it here now because this simply makes it easier and less error prone to update the UI correctly. And now the idea simply is that once we're done logging in, I'll set loading to false. So when we are done, I will also set loading to false if we are done with an error, because even then we're done. We have an error, but we're not loading anymore. And just when we started, I'll set loading to true. So now loading is also managed in the NgRx state. And that makes it now easier here in the auth component to update the user interface correctly. Because then we should not subscribe to our store here after we submitted the form, but instead in ng-on-init. So let's implement on-init, which needs to be imported from @AngularCore. So therefore, we now have to add the ng-on-init method here. And in there, I set up my subscription to the store. And now we can set up this is loading and set it equal to auth state loading, because in the auth state we'll always have the latest loading state. And an error can also be set based on the off state. So here we have our off error, and I store that in my error, which I then use in the user interface. Please note that, for example, isLogin mode would also be a state that affects the user interface that is not managed inside of NgRx because it doesn't affect any other part of the application. Logging in, of course, does, but whether we're in the login or sign up mode and which form to display, that really only matters to this component, so there is no sense in putting that into the NgRx store. You could do it, but you don't gain much by it. Managing this entire off flow in NgRx, however, is a different thing because that does impact the entire application in the end. And therefore, here, now we're updating the UI based on the current state we have in our NgRx store. We are dispatching our login start here. The missing piece is that we redirect once we are logged in, so once we do have a user. And where would we now do that? We could, of course, try redirecting whenever we have a user. So we check if off state user, if that is true-ish, and then we use this router navigate and we navigate away. But we could also end up in weird scenarios where we kind of visit the page with a user, even though that shouldn't really be possible, and we have a strange redirection. And you could, and that's more important, also see navigation as a side effect. Of course, it impacts your application, but it doesn't impact your state. The state of the application and what the user sees, yes, but your data state, so to say, that's not really impacted. So let's redirect with the help of NgRx effects as well. No worries, we're coming closer to having a working setup with NgRx effects for authentication. As always with NgRx, it's a bit more initial setup, but once it is set up, other pieces can easily be added. So now I want to redirect once we're done authenticating, once we're successfully done authenticating, from inside of effects, because, as I just explained, you could see such a navigation as a side effect. For this, in the auth effects, let's add a new property, auth success, which has a value of this actions pipe there at auth type, and I want to react only to my login action here, when I successfully did log in. Now this needs the add effect decorator, and as an additional step, after filtering for the type, I will add the tab operator, which therefore needs to be imported from RxJS operators. And in there, I simply want to execute a function where I use the Angular router to redirect. For that, we should inject the Angular router here. So inject router from @Angular router. With that injected, let's use it in here by calling this router navigate. And then here I'll go to the root route. Now, of course, you could argue that the route you want to go to differs, and you don't always want to go back to just /. Then you could, of course, accept that information as a payload on the action you're reacting to, for example. What's really important here, though, is that this is an effect which does not dispatch a new action at the end. I mentioned that typically your effects do that. They typically return an observable which holds a new effect which should be dispatched. This effect doesn't. And to let NgRx effects know about that and avoid errors, you have to pass an object to your addEffect decorator where you set dispatch to false. And this lets NgRx effects know that this is an effect which will actually not yield a dispatchable action at the end. And then you can do that just like this. Also note that I used the login action, which only fires on a successful login, not as soon as we start the login process. With all of that, let's try logging in again. We see the spinner, and we get an error. Auth effects auth login dispatched an invalid action. And that's indeed an error from my side. Whilst we need to create another observable with auth and catch error, inside of map automatically wraps what you return into an observable. So here, it actually returns a new observable with our auth created observable. And that's wrong. So here we just need to return our new action, not wrapped into auth, because otherwise we're creating a double observable, so to say. Tiny mistake on my side. Don't use auth here. With that out of the way though, now if we try logging in again, see the spinner, and we're there. Now let's log out, and let's try logging in with the incorrect password. And we're getting the error, but we're not really getting an error message here. So this is still not working correctly. We still have to implement that. The error case here can't work, because if we're catching an error for logging in, which we're doing, we're returning an empty observable. And hence, this does never dispatch anything that would, well, store our error. Now actually, we prepared everything we need. We got our login fail action, and in the reducer, we're reacting to it, and we're storing the payload of that action in the auth error, which we then in turn try to use in the auth component to hopefully show the error message. Now, there are two missing pieces. One is, in the auth component, actually for showing an error, we have to call show error alert to use our dynamic component, and not just set this error, but that's a tiny thing. In here, I simply check if this error is truish, and then if it is, I call this show error alert and forward this error. So that's one thing. The more important thing is that in the auth effects, we of course need to return our action here. Now here inside of auth, because catch error, unlike map, does not automatically wrap what you return into an observable. So here you need to create your own one. Still here, the goal is to create a new auth action, the login fail action, and this requires a payload which is the error message as a string, and that's not just error like this, but instead if we have a look at auth service, here you see in the past we called this handle error when catching an error, and in handle error we got the full error response, and from the error response we then extracted some data and generated our own error message. So essentially I want to copy that logic here from the auth service into auth effect like this. Error here is nothing else but our error response, so we can access error and so on there. Now what we must not do, however, is call throw error here, because as I explained earlier, your effects here should never return errors that break the observable. Instead here I also call auth, and I create a new auth action login fail with the dummy error message we have up there. Otherwise we get a more specific error message, and we pass that to login fail down here. Now we have better error handling code in place, and now let's try logging in with incorrect credentials, and I'm getting my modal here. We can try again, so our main observable is not dead, and therefore now if I try my different combinations, this all fails, but once I try the right credentials, I can log in. And now this was a lot of work, but now we're using NgRx for logging in. And again, as before, and as I mentioned it before, it is a lot of initial setup work, and it's definitely something to wrap your head around, but thereafter you have a clean flow here. We will be able to soon get a lot of the logic out of our auth service, and then again, we're entirely in the NgRx world, and as you will see, adding new effects will be now much faster than this first initial setup. With the login effect added, let's also add an effect for signing up, because that's of course the other big thing we can do in our application. And for that, in auth effects, let's add auth sign up, where we also use this actions pipe and add the add effect decorator. And now here in pipe, of course, I want to use auth type to filter for auth actions. What? Well, we haven't created the actions for this yet. So let's go back here into our auth actions file, and let's export a constant sign up start, which holds a value of auth sign up start. Then also a constant for sign up like this, for the success case, and then also for failing. Or do we need that? I would argue that we only need sign up start actually, because when we then succeed or we fail, we do essentially the same. We run the same error handling logic and we run the same login logic, which is why in the auth service, we had our handle error and handle authentication functions that we used for both signing up and logging in. So it's the same here in the effects, of course, in the actions, excuse me. Rather than double creating everything, I just want to have a sign up start action because that is a different kind of action. We send a request to a different URL, but login fail and login can be recycled for a sign up. And therefore, maybe we want to rename them to authenticate, success, and authenticate fail here, which means we need to adjust it in a couple of other files as well. But here, I also will adjust this class name here to authenticate success and give it that identifier. Whoops, and this of course should be authenticate success in Pascal case. And down there for login fail, that will be authenticate fail here, and then our uppercase identifier. And down there, it's now authenticate success and authenticate fail. And we also now need a new class here, sign up start, which implements action, which is a read-only, or which has a read-only type, which is sign up start. And then of course here we also have a constructor with a public payload that should in the end hold email and password. So we can copy that from login start. The payload is the same, just what we do is not the same. And therefore we can also add sign up start to our union type down there now. So these are the restructured actions. This of course has an impact on the rest of the application. When we refer to login, we now mean authenticate success. When we refer to login fail, we now mean authenticate fail. The same down there, of course. And here for auth actions login, well, we now are waiting for authenticate success. In the reducer, it's the same. We don't have login fail, we have authenticate fail instead. And we don't have login, we have authenticate success instead. And in the auth service, there we're not dispatching the login action, but authenticate success, and also the same down there, though we'll work on that service a bit more later anyways and clean that up. So with that restructured back in the auth effects, we can now listen to the sign up start action here, because that is the action where we now want to kick off the sign up process. So what happens as part of our sign up process? Well, it's not too different from the login process. We add a switch map so that we can return a new observable, and we know that we'll get a sign up action here in the end, which is of type auth actions sign up start, which holds that email and password we need. Then let's go to the auth service, and there in the sign up method, let's grab this code where we use the Angular HTTP client and use it here in auth effects. Let's extract email from the sign up, from the sign up action payload. And the same, of course, for the password. It's also coming from sign up action payload password. And with that, we're sending this request to create a new user. Now, just as for logging in, we now have to handle both the success and the error case. Now, for that, I'll copy that pipe method here and add it to that inner observable for the same reason as before, to not break the overall effects observable. So I copied that and added it to the sign up chain, because when we do log in, I want to do the same, and when we have an error, I want to do the same. Now, obviously, if we do the same, then duplicating that code is really not that smart. So instead, let's rather create our own helper functions again, stored in constants maybe, handle authentication, which is an arrow function that does something, and handle error, which is an arrow function that does something. Now this might look familiar to you. We did the same in the service because, well, it is the same logic. Now just a bit of a different logic, but in the end still the same for logging in and for signing up. So handle authentication should hold the code we have in here in map. Let's cut it and add it in there. And for this to work, we just need to get the expires in value, which should already be a number, the email, the user ID, and the token. And these should all be strings. So email is a string, user ID is a string, token is a string. So we're getting these inputs so that we can use them here, like this. Remove REST data. It's now user ID instead of local ID, and it's token instead of ID token. We're returning our new action here. We're getting all these inputs. That means now here, for map, we can just call handle authentication and forward all that data. So that would be REST data expires in with a plus in front of it to convert it to a number. REST data email, REST data local ID for the user ID, and REST data ID token. This is handle authentication. For the error, it's kind of similar. Let's grab this entire code here and move that into handle error here. All I need here is my error response, which I'll set to type any for now. Then we have the same logic as before in here. And in catch error, all we have to do is we have to call handle error and forward that error response. One important note though, we need to return observables, or here a value in map and here in catch error an observable. So we need to return the results of these function calls because inside of the functions we are returning an observable and an action. So let's return handle authentication and let's return handle error. And now we can copy that and use the exact same for logging in, saving a lot of duplicate code. So here I return handle authentication, and for the error I do the same. Remove all that code and just return handle error. That is the sign up process added. And now again we can see the advantage of NgRx kicking in. The rest should now work correctly automatically. In auth component, there's nothing we need to change. We can actually remove the auth observable now. Also, not set is loading to true here. And instead of assigning anything to auth observable, here we now instead call this store dispatch and dispatch a new sign up start action where we need to pass in an object with our email and with our password. So just like we're doing it for logging in. And that is it. We can remove this commented out part. Obviously, we still want to reset the form, so we leave that here. On handle error. That is something we should improve because right now I'm only resetting it here in the interface, not in the state. So in the NgRx state, I mean, would be better to do it in the NgRx state only. But that's a minor thing. Other than that, it's looking good. So some tweaks we still should do, but now let's save that and let's give that a try. Let's reload and let's try creating a new user which already exists. We get an error. That's good. Let's create a new user. That worked. Now, what you might have seen is that we're missing the loading spinner. And there also are a couple of other smaller things I want to tweak. So let's do that next. We're missing the loading spinner because in the auth reducer, I'm setting loading when we do start the login process, but I'm not setting it when we start the sign up process. Good thing is we can simply register a second case here, thanks to switch case statements falling through automatically. So we can group multiple cases and run the same code. And here we can also handle sign up start. So that should set loading to true. Another thing I'm not liking is that in auth component, we're setting this error to null when we handle the error. We call handle error when we click that button in the modal we open. Also, we have our subscription to our store, which we're not unsubscribing from. First of all, let's handle that subscription. The store sub, which is of type subscription. Let's set up the subscription here. This store sub is equal to, well, our subscription we create here. And then ng on destroy, if we have a store sub, which we should, so this check is kind of not required, we can unsubscribe here. So that's one thing. Now regarding the error handling, resetting the error here in the component and not doing it in the NgRx state is not really that great, because it means that our NgRx state is not in sync with the state in this component. NgRx should be the only source of truth, however, at least for all the state it manages. So kind of duplicating state management is something you should avoid. Therefore, let's add a new action, clear error or handle error, which also has that auth prefix, clear error, something like that. Let's create an object for that action. Clear error implements an action, has a read-only type, which is equal to clear error, so to this identifier. We need no constructor because no payload needs to be added, but I do want to add it here to this union type. And now we can handle it in the reducer. Here in the reducer, I add a new case, of actions clear error, in which case I want to return the old state, but set the auth error to null, so that we have no error here in the NgRx state. And now we can dispatch this from inside the auth component instead of setting this error here. So here I will instead call this store dispatch auth actions, a new auth actions clear error, like that. And this is now the cleaner approach for handling this, because now the NgRx state and the local state are in sync. So now if I try logging in with wrong credentials again, we get an error, and I can still handle it, and it works as before, but now it's a bit cleaner. With that, we're almost done with managing all effects that are related to NgRx. The remaining pieces are that I also want to redirect when I do log out. I do redirect, but I do that with the help of my auth service, and that's not how I want to do it anymore. Instead of redirecting here in the logout function, the auth service, I want to do that with the help of my effects. And then we'll also have to find a solution for all the local storage management here. So first of all, let's add an effect for logging out that redirects us. And actually, we already have an effect here that redirects us. Currently, it's called auth success, but we can rename this. We can name it auth redirect, because that is really what we do in this effect. Now, we do react to the authenticate success action, but as I mentioned, you can react to multiple actions here. So we can also react to auth actions logout and call redirect there as well. This allows me to remove that here from auth service logout. In addition, I'm currently dispatching logout here from inside logout. Well, that is not really what I want to do. Instead, let's dispatch this from inside the component where we do trigger logout, and that would be our header component. So here, instead of calling this auth service logout, let's use this store dispatch, and now dispatch a new auth action, for which we need to import it first of all. So import everything as auth actions from the auth folder, store auth actions. And with that all imported into the header, here we can create a new logout action. Now we don't use the service for that. This also means that since we now skip the service, we are not removing that from local storage. But we already have the problem that we're not setting anything in local storage, which is, if you watch closely, why we always restart in unauthenticated mode. If I do log in and I reload, we're back unauthenticated. because we're not storing anything in local storage, and therefore our auto login logic doesn't succeed. Because the parts where we would have accessed local storage, here in handle authentication, we're not calling this anymore. Handle authentication was called from inside login and from inside sign up, but we're not using these methods anymore. Indeed, we can actually remove these methods here, and our application will still work because we're not using them. Hence, now the goal will be to kind of transfer this existing logic for managing our user data in the local storage into the NgRx effects world as well. I want to manage my local storage and store the user data there and fetch it from there, from inside the NgRx effects as well, because I guess this would make sense. We have the rest in the effects as well. That means that we need a new action, and that's our auto login action. So I'll export a new constant here, auto login of auto login. And that, of course, also receives a new class now. So export a class, auto login, which implements action. And this needs no constructor, it has no payload, but it gets that auto login type here. And of course, I also want to add it here to my union type, auto login. Okay, so this is the first step. Now we have this action. Now we can react to that, but before we do anything with automatically logging in, let's first of all make sure we store user data in local storage with the help of our effects file. And for that, let's go back to the service. And you see that we did store data in local storage when we handled authentication. We cleared it when we logged out, and we read from it in auto login. Hence, here in the auth effects, we want to store data for logging in and for signing up. Now we do have that handle authentication function here, which we call as part of these effect chains. And therefore, we could write data to local storage here as well. So here we can now create a new user. For that, you need to import your user model here into the auth effects file. And that user takes, of course, the email, it takes the user ID, it takes the token, and it takes this expiration date we calculated. And then we can just call local storage, set item, and now let's see, what did I name it here? In the auth service, it was named user data. So essentially, we can just copy that line and move that into our effects. Now it's called in a function, but this function is part of our effects chain for both signing up and logging in. So this is part of the NgRx effects world now. I also want to clear that and remove that from local storage if we do log out. And for that, we can simply add a new effect here, auth logout, where we use this actions pipe and watch out for the auth actions logout type. And if that occurs, then I just want to tap and execute some code. So again, this will be an effect that doesn't dispatch anything. Hence, we add effect with that object, dispatch false, because I won't dispatch anything. And inside of the tab function here, we can access local storage and basically run the same code as we're doing it in the auth service. There, I'm removing the user data. Now, what about auto login? Well, we can essentially copy that entire code, and then we'll need to adjust it a little bit. Move it into auth effects here, and add a new effect, auto login. Where we filter out actions of type auto login. And then as a next step, if we have a look at the code I just copied, in the end what we do is we parse data from local storage, we create a user based on that, then we check if that user token is valid and so on, and if it is, we dispatch a new action to authenticate the user, otherwise we do nothing. Let's ignore the auto logout part for now. So in Auth Effects, we can add another tab call here, copy in that code, and let's go through it. We first of all retrieve data from local storage, we create a user based on that data, we check the validity of that token, and then here we're dispatching an action and we have that auto logout logic. Let's comment out the auto logout logic for the moment. And here, of course, I also don't want to dispatch. Instead, I want to return this as a new action, and then NgRx effects dispatches it for us. Hence, it's maybe better to not use tab, which will not return anything, but map instead. Map still allows us to parse all that data. And then here, I'm not calling this store dispatch, but I simply return this prepared action here. So that is all we need to do here. Now, to give this a try, of course, we have to make sure that auto login is actually dispatched. So let's go to our app component here, where I do call auto login on the auth service. And now instead of using the auth service here, I'm interested in using my store, which needs to be imported from NgRx store. And then I also need my app state. So from app, so from the root app reducer from the store folder, I get from app, which I then use here to assign this app state as a type for the store we're injecting. And here, instead of calling this auth service, we call this store dispatch. And then we need access to our auth actions. So import as from as auth actions from /auth store auth actions. Let's use a new auth actions auto login action here, and we should be good. Let's save that and let's wait for the app to reload. And I'm getting an error that I dispatched an invalid action undefined. That is stemming from auth effects. There in auto login, I am returning a new action, but only if we have a valid token. Otherwise, I don't. So let's return something outside of that if statement too. That can be an object which simply needs to have a type property because that qualifies a valid action. You don't need to create it based on a class. If you need a simple action, you can do it on the fly with the object literal with the type property and give it any dummy identifier, like dummy here, anything like that. Now this is a valid action which simply has no effect. And then we also need to do the same up here where I return nothing thus far, also return dummy here. And with that, if we go back, now this works. Now let's try logging in here. We can check the application tab and there, local storage to see if something was stored. That is looking good. Let's now reload the app and auto login also seems to work. Otherwise we wouldn't end up here. If I log out and I then reload, I'm back here. So then we really cleared that. So this is all working. The missing piece is that auto logout so that we clear the token from local storage automatically and that we log out the user once our token expired. We're almost done with the NgRx effects for authentication, which is quite complex because it involves many different things. And the missing piece now is the invalidation of the token. We're doing this with auto logout, which in the end just takes an expiration duration, and where we then set a timer to basically call logout once it's done. Now you could come up with setups where you do this all inside of NgRx effects. But I'm not actually the biggest fan of this, because in the end my goal here is just to dispatch the logout effect once a timer expired. So once we could certainly come up with some observable magic to yield that effect, I think it's easiest if we simply clean up our auth service quite a bit, remove auto login, remove logout, remove these injections, which we don't need anymore, leave the store injection, leave the token expiration timer, remove that, remove all these unused imports here. So all that stuff which we won't need anymore. Remove handle authentication and remove handle error, so that in there, it's really just a service that is about managing that logout timer. I have auto logout, and I will rename it to set logout timer, because that is what I ultimately want to do here. And in here, I want to simply call dispatch and dispatch a new auth action, the logout action, because that is handled through NgRx and NgRx effects. And I want to add a second method, clear logout timer. And there, all I do is I check if this token expiration timer is set. And if it is set, then I will call clear timeout for this token expiration timer. And then set this token expiration timer equal to null. Now that's a way leaner service here. And how can we use that service? We can use it from inside auth effects. There, I can now inject my auth service, just as you're used to it. Of course, make sure to add an import to auth service, therefore. Here it is. And now in all the places where you want to set a timer, you do it. That would be in handle authentication, but that is a function, not part of our class, hence we can't access the injected object here. We could turn it into a class method, but we can also simply go to our map method here, for example, where we handle authentication, add a tab operator first, which is imported from RxJS operator, where I also get my response data, but which does not change it, and then call this auth service in here and set the logout timer equal to response data expires in, add a plus here though, and we need it in milliseconds in the auth service. If you have a look, we set the expiration duration here. Set timeout takes the amount in milliseconds though. This, however, will be in seconds, so we need to multiply this with 1000. And I do just the same, add the exact same step here for signing up. So before we map, let's also set the logout timer here. Let's also set it when we logged in automatically. So here, where we know that we have a user and we do authenticate the user, we use the auth service and call set logout timer and simply forward our expiration duration, which we're calculating down there. So let's reactivate that code here. Like this, forward the expiration duration here to set that timer. And last but not least, when logging out here, of course, now I will call this auth service clear logout timer, like that. That should do the trick. And to see if it really does the trick, let's go to the login effect, this one here, and let's not multiply this with 1000 so that it should expire after 3.6 seconds effectively. And let's try logging in and let's see if we are logged out thereafter. So this works, and now let's wait for the 3.6 seconds. And it's a bit hard to see because we stayed on the same page here, but we were actually logged out, just the redirection didn't really work. The reason for that behavior is that we do have our redirection logic here, but actually we have kind of a race condition between our logout in the reducer, where we do clean up our data, which is important for the auth guard, which decides which page we ultimately see, and our effect. Now, the easiest solution to avoid this problem is to simply remove the logout action here from the filter for this general redirection, and instead go to our separate logout action, and then here add a new redirection where we specifically target /auth. And now with that, if we wait for this to reload and we log in again, now this should redirect us after 3.6 seconds. Logout was already working. So this now works, and with that, let's revert this little hack here. And let's multiply expires in with 1000 again to have the correct logout timer. And with that, finally, our effects setup for authentication is done. And now we have a really lean auth service which only manages our timer in the end, and all the rest is managed by NgRx. Obviously, this entire NgRx part was pretty extensive, was pretty much for authentication. But keep in mind that authentication also is pretty complex in this application because we manage the token lifetime and so on. Now it's basically all managed with NgRx. We are using effects for all the side effects like HTTP requests and local storage and redirection. We're using the reducer for our general state, like the authenticated user, if we have an error and if we're loading. And the auth component dispatches our different login or sign up actions and takes advantage of the error and the loading state. The auth service is used for managing our token timer then. We could move that into NgRx effects somehow, but we would need a lot of observable magic for this. And I think this is just the simpler and easy to understand approach. The auth intersetter and auth guard take advantage of our NgRx store. And therefore now, whilst it was a lot of work, now the entire authentication logic lives in NgRx. Again, it was a lot of work, but now whatever you add is added with relatively little effort. Still, of course, using this entire setup is optional. Now, what I want to do at this point is I want to do some cleanup work here. I want to look through my components and remove parts which I don't need anymore, or not from my components, but at the auth component. Remove the injected auth service and the router, for example. Remove that observable import, the router import, which I don't need anymore. The auth service imports here, that should all be good. Now, in the auth service, I don't need the auth response data interface anymore. I can remove the user model, therefore, the import, not the model itself. And overall, this is looking quite good. Looks like the application is working correctly. And now, we are taking advantage of NgRx. Let me log in here, fetch recipes. That all is working, now all powered through NgRx. Of course, the recipes area is missing, but before we tackle that, let's look into two other packages the NgRx team gives us. Our application is taking shape, or to be precise, it already had shape, but we're moving more and more of the logic into NgRx. With the auth and the shopping list area finished, only the recipes remain. And of course, we still have that data storage service. But let's focus on that in a second step. First of all, let's take a step back and let's work on our development experience a little bit. Thus far, we had a look at NgRx where we were using it, but wouldn't it be nice if you could sometimes look into it and have a nice log of the different actions that are being dispatched and which data they carry and how they change your global application store? Well, you can have a look at this with a special development tool which you can install. For this, search for Redux DevTools extension, and you should find this GitHub repository here, which is about the Redux DevTools extension, and NgRx is compatible with that. And you can follow that link to find a page with instructions on how to install it in Chrome or Firefox. So I'm using Chrome, so I will go to the Chrome Web Store on the page of that package. And I already have added it. If you haven't, simply click the installation link, which you should find here. Now, that is basically all you need to do then. You have installed it. You don't need to follow any other steps here. You just need to go to that Chrome store and install it from there. Once you have that installed, you can install a special package in your project with npm install and now -- save dev, because that will be a development only dependency. And there, this is at NgRx / store - DevTools. Now let's restart ngserve. And to use that part and use it together with the installed extension, you now have to go to the app module. And there, after creating your store module, you now can register a new module, which is unsurprisingly imported from that newly added package. So we just added NgRx / store DevTools. From that package, you can install, or you can import the store DevTools module. Now with that import added in the imports of your app module, store DevTools module, like this, and call instrument on it. Now instrument takes an object where you can configure this, and there is one configuration which I want to add, and that is log only, which I want to set to environment, and environment is now getting imported from our environments folder. So there, actually, let me navigate there manually. One level up, then into the environments folder, and then the environment file, not from the environment.prod file, but just from the environment file. In there, in that environment file, we have a production property in that constant, in that environment constant. And that is false during development, but in the prod file it is true. And as you learned, these two files are swapped automatically by the CLI once you build for production. So this environment constant has this production property, which is false during development, but true during production. And therefore, with log only, we're basically restricting the output to only some log messages when we're in production. With that added, you can save your application and now go back to it and maybe restart your browser after the installation of that Chrome extension or of that Firefox extension. And you should then find a Redux element here in your browser developer tools. And in there, that's pretty nice, you now have a detailed log of what's happening in your application. If I reload, for example, we see which actions are getting dispatched here. We see the auth auto login, dummy, and if you scroll up, by the way, you see there are some initialization actions being dispatched as well. And you might recall that I mentioned these initialization actions earlier in this module. This is important for your state getting initialized. So there we see what was getting dispatched. We see what the state looked like after that dispatch. You see which action that was, and you see more information about that action. For example, you can see more information once I do log in. Now you see login start was dispatched. This had a payload. That payload was the email and password. And we see that the state here was, at this point of time when it was dispatched, that the user was basically null. But then for login, once this is done, the user, that's the state after this action has been performed. But for login start, the user obviously still was null, but loading was true. And after login, the state was such that we had a user and loading was set back to false. So here you can now really dive into the different steps that are being executed in your application. You can learn more about what's going on. You can simply play around with that and get an overview of which actions were dispatched and how they affected the state, which state updates were made, and so on. And you can even go back in time and replay your application at different points of time and simply play around with that a bit to simulate different states and, most importantly, to get a feeling for what NgRx is doing behind the scenes. Now, with the store DevTools added, I can also show you another package that might come in handy in some application. And for that, I quit my ngserve process, and again, I will install it with npm install -- save, and then it's NgRx at NgRx /router store. Now that's also an official package, part of the NgRx suite, and that helps you with reacting to routing actions. It basically dispatches some actions automatically based on the Angular router, and that would allow you to then write code in your reducer or with NgRx effects that runs when such a routing action occurs. For that, let me restart ngserve and let me show you how to add this. Now for adding this NgRx router actions functionality, we will have to add another import, unsurprisingly, where you again import something from that newly added @ngrx router store package. And that something here is the store router connecting module. And you add that after your store module and so on. Here you add your store router connecting module for root, just like this. You don't need to pass any arguments to for root. And now with that added, if you save everything and you go back to your application, let it reload, now you see there are more actions being dispatched. We have the router store request, router store navigation, and if you have a look at these actions, you see they have a payload. For example, here for router store navigation, we get the router state, we get the URL we're trying to navigate to, and we get detailed information about our routing action, and also once this is done. Now we don't need this in our application, but of course if you're building an app, this could be convenient and could give you a quick and easy way of reacting to different routing events and different data attached to these events. Back to our application then. There is one area, the recipes, which we haven't migrated to NgRx yet. And that is what I want to do now. And for this, in the recipes folder, I'll start by adding a store folder. And in that store folder, I want to add a recipe reducer.ts file, a recipe.actions.ts file, and also already a recipes effects.ts file, because we will certainly need all three things. Now let's start with the recipe reducer. And in there, you learned it's basically a function, so we will have to export a function here, and that's the recipe reducer function, or whatever you want to call it. And just as before, it is a function which will receive a state and an action, and then you have to return a new state, a new state in there. Now also just as before, of course, we want to have an initial state, and I also want to define the structure of my state, so how the state will look like. For that, I'll export an interface, which is my state for this part of the application, so my recipe state, so to say. And now how does the state for recipes look like? Well, if we have a look at the recipes service, we see in the end, we're only interested in recipes. We managed that thus far through the recipes changed subject, which we use to emit a copy of our recipes. But therefore, in the end, this recipes array, that is our relevant state for the recipes. So in here, in my state for the recipes part of my NgRx store, it makes sense to have the recipes array, and this will be of type recipe array. So you need to import that recipe model here. Now that describes how the state will look like for this part of the app. Let's now set up the initial state, and that will be an object of that type, so of that state type we just defined. Hence we need a recipes array, and you could start with some recipes here, but I will initialize this to be an empty array initially. So that's the first step. Now obviously we also need some actions to deal with our recipes. And which actions would that be? Well, we have actions for setting multiple recipes at once. For getting is not an action, we do this with select. So we have actions for adding a recipe, and we also have actions for updating a recipe and deleting a recipe. We'll also need actions for fetching recipes from a server and for storing recipes on a server. So let's go to the recipe action file, and let's maybe start with the simple actions we have here. So the actions related to setting recipes, so that we can see something as quick as possible. So I will add set recipes here, and we'll give this prefix, recipes, that's the feature area, and then set recipes. Of course, the exact string value here is totally up to you. We'll also need to import that action interface from @NgRx store so that we can create our action classes. And for now, I will create one class here, the set recipes class, which will, of course, implement the action interface and which therefore requires a read-only type, which is just set recipes. Now, set recipes, as the name suggests, of course, will be responsible for, well, guess what, setting some recipes, and hence we will definitely need a payload here, which can now be stored through the constructor, and that payload here will just be that array of recipes, which I want to set. For that, of course, we need to import recipe here from the recipe model. Last but not least, let's create such a union type already so that we can conveniently add a type assignment to the action we're getting in our reducer. And that would be the recipes actions. Right now, simply set recipes. Whoops, and it's of course exported type. Okay, so that's the first action we need. Now in the recipe reducer here, we should add logic to set recipes. So later we will have multiple actions, hence a switch statement makes sense to switch on the action type. Side note, I also of course want to use my initial state here for initializing the state. And on the action, I also want to be clear about the type of the action. For that, we can import everything as recipes actions from the store, from the recipe actions file. And hence here, the type for the action we're getting in the reducer is recipes actions.recipes actions. Now in the switch statement, this is the action type we're checking. The first case I want to handle is recipes actions.set recipes. And of course, I will also add a default case where I just return my state unchanged. But back to the recipes set recipes case, there I also want to return an object, or we have to return an object. But again, the goal is here to first copy the existing state. And now with that being copied, override the recipes in there by taking the recipes we find in the action payload, because the action payload here, of course, has an array of recipes. So here I will just use the spread operator to get my action payload. This will pull out all the elements from the recipes array I'm getting and add these recipes here to this recipes array of the new state. So that's the reducer and action setup. As a next step, let's make sure we dispatch set recipes once we have our recipes. And of course, let's make sure that we select these recipes to show them on the user interface. Dispatching for now will be done in the data storage service. There we do fetch the recipes. And once we have them, right now we're calling recipes service set recipes. That's not what we'll do. Instead, now we can remove the auth service, by the way. We don't need it here anymore. Instead, now I want to inject my store here, like this, and this needs a generic type. NgRx store is, by the way, of course, the package from which you import it. And I can also clean up some other imports now that I have a look at it. But that's, of course, not the main goal here. Instead, the store needs to be imported. It's a generic type. And therefore, now we need to get our app state here, even though we're not selecting in this class. Now for this, we first of all should update our app reducer, because right now it only knows the shopping list and auth area. Well, that is about to change though. Let's import everything as from recipes from the recipes store recipe reducer. Now we should add recipes as a slice in our global state here and reference from recipes state. And of course, that means that in the app reducer here, I also will add recipes and then from recipes recipe reducer here. With that, the global application reducer is updated, and back in the data storage service, we can now import from that reducer. So import everything as from app from that global store app reducer, and then we have from app state here as the type, as the generic type our store will eventually resolve to. However, I only need the store here to, of course, dispatch. So here, once we got the recipes, we can call this store dispatch. And now we also need the recipes actions to dispatch such an action. So I import everything as recipes actions from, one level up, from the recipes folder, the store folder, and from there, the recipe actions file. With the recipes actions imported here in the data storage service, let's create a new recipes action, and that would be the set recipes action to which I pass the recipes we got from the server. So now we're dispatching this set recipes action. Now we need to change the places where we're interested in the recipes. And that is the case in the recipe list component. So in there, let's now also inject our store, which is of type store. And again, for that, I have to import store from @NgRx store. And now I want to add my app state by importing from app from the app reducer. Then here it's from app state like this. And now here, instead of subscribing to recipe changed on the recipe service, I rather use the store and select the recipes area. However, there I don't get a list of recipes. Instead, I get an object which has a recipes key. I get the state slice of my recipes area. But with pipe and map, we can easily transform this. Map is imported from RxJS operators, of course. So we can easily transform this now. We get our recipes state. And what I want to return here is in the end just my recipes. Well, we can simply add map like this. Pull out the recipes, return them to the next step in line. We could also get rid of that get recipes called here. Now with that change, we can also remove the injected recipe service here in the recipe list. Now let's give this a try. Let's save that. And here in our application, if I now fetch my recipes, they do show up here. However, I'm getting an error if I try to select one, which makes sense because keep in mind that the rest of the app still tries to access recipe data from the recipes service, but there our recipes are no longer loaded into because we're now loading them in our NgRx store. And hence at the moment, only those parts of the app will work where we do access our recipes from the store. So it's time to also adjust other parts of the application. So at the moment in our application, we can fetch recipes, but as soon as we try to visit one, we'll get an error because we're failing to load the ingredients here. But the bigger problem is that we're failing to load the overall recipe details. The reason for that is that if we have a look at our recipe detail component here, we are of course still fetching our recipe here with get recipe from our recipes service. But we now no longer load our recipes into the recipes service. We instead load them into NgRx because, not here, but because in the data storage service we dispatch the loaded recipes with set recipes, and that of course uses NgRx. Hence, the goal has to be that we also fetch our recipes on the detail and then also on the edit component from our store. And for that, we'll have to rewrite our logic there a little bit, because at the moment, our logic is such that we basically load our recipes, or we loaded our recipes in the service, in the recipes service, and then we stored them here in that recipes array in the service so that we thereafter could simply access the recipes from that array with get recipes or get recipe. That's not how NgRx works. There we always access the store and the data in it by using select, and we always get back an observable. So we have no synchronous call as we have it here to get back a recipe. We always get back an observable that might then give us a recipe depending on what we select. Even if that happens almost instantly, it's still technically an observable. So therefore, we first of all will have to inject our store here into the recipe detail component, and then we can see how we proceed regarding that. So I'll inject my store, import it from @NgRx store. We'll also need to get information about our app store, our app store structure by importing that information from the root store file and the app store folder and the app reducer file. And then here we can assign this generic from app state type as we did it before. Okay, so now we know more about our store. Now here we have a problem. Getting the route params already is done through an observable. So now we want to add yet another observable to then take these route params and get our recipe. Now, the first way of how we could do this would be that we create a new observable chain inside of that function we passed to subscribe of that outer chain, where we select our recipes part of the store. And then we can use pipe here on this inner observable, now on this selection observable, to transform the data we're getting with map. And for that, we need map from RxJS operators. And we need map because here we get our recipes state, and what we really want in the end, of course, is a single recipe for that given ID. So here we can then simply return recipes state recipes, and here, as I said, I want a single recipe. We can use find for that, and find takes a function where we get each recipe but also the index of each recipe, and we here want to find the recipe where the index of the element we're currently looking on at with that find method, where that index is equal to this ID. So this could be our logic for retrieving one recipe. Now here I'm just mapping this, so now we can subscribe, we can subscribe on that inner observable, so on that store selection observable. At this point, we will get a single recipe, and then we could say this recipe equals recipe. So now we're taking advantage of this store observable. Let's save this and let's see if it works, if this reloads. First of all, we now need to fetch data, and then here, that looks good. So this works. A more elegant way of handling this would be to convert this all into one big observable chain, even though you can also leave it like this and could use it like that. But if you wanted to convert it to one larger observable chain, then you would have to call pipe on that params observable here and add a map operator as your first operator. Here you then get this params object, which we previously got in subscribe. We will change our subscribe logic soon. And there I want to return plus params ID to get that ID. And in the next step, we would add a switch map to switch our observable from the route params observable to the store observable. Here we would get the ID, and we would return this store select recipes in the end to kick off that store observable for the recipe slice. And thereafter, in yet another next step, we would use map here. So let's cut that and remove that pipe method. Therefore, we would add map as yet another step in this main pipe here. However, here we get the recipe state, but this ID is now not set at this point here. To set it, we can set it here in the switch map. We can set this ID equal to ID because we're getting the ID here as an argument thanks to map. Now this ID is available here, and we can filter on our recipe state for that single recipe. And last but not least, now we have a subscribe function here with one too many closing parentheses. Now we have a subscribe function here where we get our single recipe. So now if we save that, we should have the same setup where we can now fetch recipes and still view the details with this observable chain. The same approach, or a relatively equal approach, can be used on the recipe edit page. There we also load a recipe when we initialize the form, and this now also has to be done with the help of our store observable. So just as on the detail page, let's start by injecting the store here, imported from @NgRx store, of course. And let's also import everything as from app from our store app reducer file to assign that generic type here from app state. And now down there where we previously selected our recipe like this, that won't work anymore. Instead here we now select the recipes on our store. And then again we can use pipe here and add the map operator, which you still need to import from RxJS operators, of course. And with the map operator added here, we again get our recipe state at this point. We're only interested in a single recipe though. Hence in here we can return recipe state.recipes and then find a single recipe. And then again here we get a recipe and the index passed in automatically into this function we passed to find. And we want to return true if the index matches this.id, so the ID we extracted from the route params in ng-on-init. Since we do call init form inside of our subscription here, this is fine and we can rely on the ID being set at this point of time. So now here we basically return a single recipe. In the next step, we can now use that recipe. And therefore, the next step is to subscribe. We get our recipe here. And now all that code that relies on the recipe, so all this code here, has to be moved into the subscription because only in there our recipe is available. Let's give this a try. Let's fetch our data. And let's try editing a recipe. And this looks quite good. Now, changing this or saving changes won't work yet because we're not handling this through NgRx at this point, but we can load the details, which is looking pretty good. Again, of course, changing anything here will not have any effect because we're not using NgRx for saves right now. Of course, we have a problem if I reload whilst I'm on such a detail page, though. There, we don't really load that data. So that will be the next step, that we can also reload these pages. And that is simply related to our resolver not working correctly. When we fetch our recipe, and I then load the details and we reload, you see that this doesn't work. And that is related to our recipes resolver. This is responsible for actually triggering the fetch recipes call when we try to visit one of these recipe detail pages. We can check our routing file for that. There you see that on the ID and the ID edit files, we normally use the resolver to resolve our data. But that simply fails here, and hence we can't successfully load these pages because we're still using the data storage service for fetching here. That is currently correct. We're also doing that from the header component. There, if you take a look, we also use the data storage service. And now the next goal will simply be that we manage this through effects. Now for that, let's go to our recipes effects file and let's export a class, recipe effects. And in that class, we need to inject something from @NgRx effects, if you remember. And that something is the actions observable. So from @NgRx effects, let's inject it here. Again, I will use actions with the $sign, but that is optional. The type is actions. Now with that added, we can add effects as properties in the recipes effects class here. Let's start with the fetch recipes effect. We need to add the effect decorator, which is also imported from @NgRx effects. And the value we store here is this actions and then pipe. And now, first of all, we need to filter for a specific action that should trigger this effect. And for that, let's add such an action. That would be, for example, fetch recipes. You can name this however you want. And the identifier could be recipes, fetch recipes. Let's export a class, fetch recipes, which implements action. And on that class here, we only need the read-only type because we need no extra payload for fetching recipes. So back in the effects file, now here I want to pipe of type, which also needs to be imported from @NgRx effects. And I'm looking for my actions. So I import everything as recipes actions from recipes actions file. And I'm looking for my recipes actions fetch recipes action, of course. When this action occurs, I want to kick off this effect here. So of type is the first step in our pipe here. The second step now is that we send our HTTP request to fetch the recipes. For that, let's use a switch map here, imported from RxJS operators. We did the same in the off section, if you remember. Here, for example. And let's go to the data storage service where we have the logic for sending this request. And we can simply copy this code here for sending a GET request. So let's, first of all, expect our fetch action data here. Though we don't really need that, so you could also use an empty argument list here because we, well, are not interested in any arguments. We're not getting a payload from that action anyways. And now since I want to use the HTTP client here, we need to inject this as well. So HTTP client is injected from @angular-common/HTTP. And we also need the recipe model here. So import recipe from the recipe model file. The URL here still should be correct. And with that, we have logic to send that request. But let's see what else we're doing in the data storage service. There, we're also mapping the response. And that is, of course, something I want to do in the effect too. So I'll just copy that map operator. And of course, therefore, also import it here from RxJS operators. And then in here, we still get our recipes. We map that, transform this as before. And once we're done with all of that, as before, the goal is to return a new action, which will then be dispatched automatically. We can use another map operator for this, where we get our recipes. And now what action should be returned here? Well, that would, of course, be our set recipes action. So a new recipes action set recipes object is required. And there we pass our recipes as a payload. And this, again, will then automatically be dispatched by NgRx effects. Now, for these effects to be considered, we need to register them in the app module. So there in the effects module, we have to add the recipes effects. And for that, of course, an import has to be added here. So import recipes effects from, and now let's go to /recipes store recipe effects. Am I not exporting it there? Recipe effects without an S. So it's recipe effects, which needs to be added here in the app module. And with that, NgRx effects will automatically load this effects class here and set up all these observable listeners. So with that, we have these listeners. Now we just have to dispatch fetch recipes to use them. And one additional note, I also need to add @injectable here to the recipe effects class, which is imported from @AngularCore to make sure that things can be injected into this class. So with that, let's dispatch fetch recipes. And there are two places where this needs to be done. The first place is the data storage service. Or to be precise, the place where we called the data storage service in the past. And that would be the header component. In there, I already inject the store, which is great. So in onFetchData, we can go right ahead and use the store to dispatch our action. All we need to do is import our recipe actions. So import everything as recipe actions from recipes store recipes actions. And with that imported here, we dispatch new recipes recipe actions dot fetch recipes like this. So let's give this a try first before we work on the resolver. The app reloaded, and if I click fetch data, that looks pretty good to me. Now this is handled through NgRx and not through our service anymore. Let's now work on the resolver, and this is a bit more tricky. In the resolver, we also called fetch recipes in the past. The thing just is the resolver actually expects an observable as a return value here on the resolve method, and it waits for this observable to complete before it loads the route for which you added this resolver. The problem is, when we dispatch an action, we don't get back an observable. Therefore, resolve would instantly resolve, and we would instantly load a route where the data is actually not there yet. Now, there are workarounds, and I want to explore one workaround with you here. First, we need to inject our store, and we won't need the data storage service anymore. So let's inject the store here instead, import it from @NgRx store, of course. And let's also import everything as from app from our root app reducer here, so that we can inject this and assign this generic type like this. And of course, we also need actions, so let's import everything as recipes actions or recipe actions. I think I named them in a different file. You can, of course, name them whatever you want. From the recipes area, the store there, and there the recipe actions file. Now here, instead of returning this fetch recipes call, I will call this store dispatch, and now create a new action based on my recipes actions for fetch recipes. Now again, the thing is I can't return this because this does not yield an observable. Instead, we want to wait for the effect that is triggered by that action to complete. And there is a neat little way of doing that. Keep in mind that in recipe effects, in the end, we filter for specific actions and then we run logic. Now, it turns out that you can use this filtering logic and this actions observable provided by NgRx effects in any class, not just in such a effects class, and also without the effect decorator. That just is all required for NgRx effects to do other useful things for you, like automatic unsubscribing and so on. But we can also abuse these features in a different class. And here, indeed, in my resolver, I want to import actions and of type from @NgRx effects. Now, what does this allow me to do? We can inject our actions here, just as we do it in the effects class. And now here, we can return this actions pipe of type and now listen to a specific action to occur to complete this observable, basically, or to trigger this observable. And that specific action I'm interested in is simply my set recipes action. When that is called, I know that recipes are there, and therefore this is the action I want to listen for. So here I will use my recipes actions set recipe action as a trigger. Now we also need to add the take operator from RxJS operators here to take only one value, so that we then complete and unsubscribe from the subscription, have no ongoing subscription. We're only interested in this event once. And we're good. And now the resolver dispatches this, but then also waits for recipes to be set. Now let's give this a try. If we now fetch our data, we go here to the ingredient page, that works. And if I reload this page, I still end up on /recipes. Well, let's fix this in a second. First of all, let me show you that our logic works though. If we use the Redux DevTools here, if I fetch my data, we see fetch recipes, set recipes here. If I now click on the ingredients, we see that triggered again. So here's the first set when I manually loaded that, and here is when I visit a detail page. So our resolver kicks in and does its job, which is great. We fetch the latest information. However, when I reload, we are redirected, and that's actually not directly related to the resolver. Instead, it's related to the auth effects, where I redirect whenever we logged in here. When we have an authentication success, which is also the case after an auto login, I navigate. Now, we probably want to tweak this a little bit. We should only do that if we have an authentication success outside of the auto login mechanism. Or, to handle it differently, in auth actions, for authenticate success, we can add a new item here to the payload, and that could be redirect, which is a Boolean. Now we can go to the effects, and when we auto log in, we can set redirect to false. I don't want to redirect to that default page. I only want to do this up here in the normal handle authentication function for manual login and sign up. There we can set redirect to true. Now what's the advantage of this? Now we can go to our off redirect effect here, where we redirect after a successful login. And actually what we do get here is our off success action. So here we can then simply check if off success action, and I should set a type here to get better auto completion. The type here will be off actions authenticate success. If my payload here includes redirect, or it will include that, but if it is true, only if it is true, I will call navigate. Otherwise, we won't. With that, let's first of all log in manually. That works as before. And now if I fetch data and I reload here on the detail page, you see that now also works. We stay on that page and the data here is loaded without any errors. We're almost done. Time to add the rest of the recipe feature set here to the NgRx world. And for that, why don't we start by making sure that we can also edit and delete recipes. Thus far, that still happens in the recipes service. Here we have add and update and delete recipe. And these three things now should also be handled with NgRx. So let's go to the recipe actions. Let's export some new identifiers here. Add recipe, where our string is add recipe. Then also update recipe here, and also delete recipe, like this. These are the identifiers. Now, of course, we need the classes that meet them. So we have add recipe, which implements action, and there the read-only type will be add recipe, of course. Now there we also need a constructor with a payload, because obviously when we add a recipe, we need to know which recipe to add. And if we have a look at the recipe service, we see that we expect a recipe here. So let's do the same in our action. We just assume that the payload is the recipe that should be added. We also have our update recipe class that implements action. And there the read-only type is update recipe. And now, just as before, here we also need a constructor. Let's check the recipe service. There we expected the index of the recipe to be updated and the new recipe. Let's expect the same here on this action. So our public payload here would be an object with the index, which is a number, and with the new recipe, which is a recipe. And we also, of course, have our delete recipe action, which implements action. And there we also have the read-only type set to delete recipe. And we also need some data here, because for deleting, we also need to know which recipe to delete. And therefore, our payload is just a number, the index of the recipe that should be deleted. And that, again, is in line with the recipe service, where we also get that index. Now let's add all these newly added classes to that union type. We can also add fetch recipes there, and then it's add recipe, update recipe, and delete recipe, like that. This is now all added here to the actions. The next step is to work on the reducer. Because all these actions we just added result in synchronous state updates. None of those actions requires us to send a HTTP request or perform any side effect. And therefore, we can simply add a couple of new cases here in our reducer, for example, for adding a recipe. In there, we'll return a new state, which is based on the old state, and where we basically have an updated list of recipes, which is our old list of recipes plus the new recipe. We can easily add this by first of all copying all the old recipes and then simply adding action payload as a new element, because the payload for add recipe, so for this action here, is just a recipe that should be added. So that's the first new thing we added, the first new case. Now let's of course also handle the case that we update a recipe. In this scenario here, we first of all have to find the recipe we want to update, then copy it, then change it, then copy the list of recipes, and then replace the updated recipe in that copied list with the updated recipe, and then use that copied and changed list as a new list of recipes. So here, first of all, we copy the old state, and then we need to do all the things I just described, which sounds more complicated than it is. Let's first of all fetch the updated recipe by reaching out to our state recipes, and there we use the action payload index to get the recipe with the index we want to change. Now, of course, that would just be a pointer at the original object. So let's wrap this in curly braces instead and use the spread operator to pull out all the properties of that recipe. So now we created a copy of that old recipe. And thereafter, let me split this into two lines. Thereafter, I want to override some properties. And basically, I want to use my action payload new recipe, and with the spread operator, I extract all the properties from that new recipe and basically merge them into this object, which is my copy of the old recipe. Hence, this will override all the values of the old recipe with the updated values. So that's the updated recipe. Now we just need the updated recipes, so the entire list. For that, I first of all copy my old recipe list so that we have a new list. And then on the updated recipes, let's select the right recipe through the index here and set this equal to the updated recipe to override that element at this index in the copied list. And now we can use that copied list down there, updated recipes, like that. Now, last but not least, the delete case. For that, we have recipes actions delete recipe. We also return a new state object here where I copy my old state, and then recipes here will be my old recipes, but without the recipe I want to remove. We can easily do that by referring to state recipes filter. Filter will always return a new list, so we don't mutate the old list. And filter takes a function which gives us access to each element and the index of that element. And the index is important for us because we want to return index not equal to action payload. Now why? Because the action payload here is the index of the element we want to remove. And if that's not equal to the index we're currently looking at, and this function runs for every element in the recipes list, if these do not match, then we're not looking at the element with the index we want to remove. Therefore, we will return true here, and that means we keep it. Only if these do match, then we return false, thanks to our not equal comparison, and then we will remove the matching element. That's the reducer. These are the actions. The missing thing, of course, is to dispatch these actions. For that, let's go to the recipe edit component, and in there, on submit, we emit update and add recipe. Let's no longer use the recipe service for that, but the store instead to dispatch a new recipes action. And for that, we need to import these actions first. So import as recipes actions from store recipes actions. And with that imported, here I can use recipes actions. And here we're editing an action, hence I want to dispatch a new update recipe action. And this requires this ID, which is the index of the to be updated recipe. Whoops, wrapped in an object though. So we set index equal to this ID, and we set the new recipe equal to this recipe form value. So now we're dispatching the update action Let's do the same for adding a recipe. For this, I'll dispatch a new recipes action, add recipe like that. And here we now need to forward this recipe form value. Let's also make sure we can delete recipes. That happens in the recipe detail component. There we have on delete recipe. I no longer will use the recipe service for that. Instead, we use the store, dispatch a new recipes action. For that, again, we need to import everything as recipes actions from this store folder and there from the recipe actions file. And with that imported, here we also use recipes actions, delete recipe, dispatch this, and of course add the information which index which index the recipe has we want to remove. And with all of that added, let's reload our application and let's give this a try. Let's edit this, change the title. Now the change title is not reflected because if we inspect Redux again, what happens is that we do call update recipe here, and indeed, if we have a look at the differences, we see that one recipe was changed and got the new title, but thereafter we navigated and that kicked off the resolver again, which simply loaded new recipes from the server, and that overrides our change here. To fix that, we can go back to our resolver, and in here we simply select our recipes from the store and add pipe. Now first of all, I add a map operator here, which is imported from RxJS operators, of course. And here we get our recipes state, and I return recipes state recipes. This now either is an empty array if we haven't fetched any recipes yet, or it is a filled array. And therefore in the next operator I add to this observable chain here, I'll add switch map, where I get my recipes. And now if recipes length is equal to 0, then I know I have no recipes. In this case, I'll dispatch this. And in this case, I'll return this observable with its own pipe. Otherwise, we still need to return an observable, but otherwise I just return auth using the auth operator imported from RxJS. And I simply return my recipes in here. So this means I don't send any request if we already have recipes. Now this overall observable here is returned. Now I also, first of all, want to add take one here to ensure we don't do this multiple times. With that, if we reload here, our data is fetched. And now if I edit this, this also persists because now we're not refetching data because I already do have data in my storage. Now let's also test the other things. Deleting. Here we get an error, cannot read property name of undefined in the recipe edit component. This error occurs if I go into edit mode and then I cancel and then I delete this recipe. Reason for that is that in the recipe edit component here, I never clean up my subscription for selecting data from the store. And we should do that here. So let's add a private store sub, which is of type subscription, which needs to be imported from RxJS. Like this. And now let's go to the place where we set up this subscription, which is here. Like this. And an NgOnDestroy, which I now also want to add, and hence we should add the onDestroy interface here and implement this, imported from @AngularCore. Now we add NgOnDestroy, maybe here. And in there, I call this store sub unsubscribe. And if we do that, and I now fetch data again, if I go into edit mode, and then I cancel, and then I delete, now this works, because now we don't have any old subscription that tries to fetch data which isn't there anymore. Now in the recipe detail page, we don't need to do that. So if I delete here without editing first, we get no error, because in the recipe detail page, we set this subscription up as part of our route params subscription, and there Angular takes responsibility for us and unsubscribes for us. And hence we don't have any ongoing old subscription here. Let me reload and fetch again. Let's now also try adding a new recipe. Test. Some image. This is a test. And add an ingredient like buns 1. Save this. And here we also get an error. Cannot read property unsubscribe of undefined. Now the problem here is, stemming from that unsubscribe we just added, in the recipe edit page, if we never were in edit mode, in init form here, then we never set up this subscription, and hence when we try to unsubscribe, we fail. So we should check if this store sub even exists, and we can only unsubscribe if it does. So that's an improvement we have to make here. And with that, let's try creating a new recipe again. Test, add an ingredient, buns 1, and hit save. And now this looks way better, and we can view it here as well. We can fetch our data, which will overwrite that existing ingredient, but that all looks pretty good now. So these core mechanisms now all seem to work. Now let's also dive into the remaining piece, and that is of course storing recipes on a server. And for that, I want to add a new effect, store recipes, which also gets the add effect decorator. And here we again listen to our actions observable stream and use of type to react only to certain types of actions. And we need to add a new action for this, and that will be our store recipes action, which gets this identifier here, store recipes, like this. Let's export a class here as well, store recipes, which implements action. This has a read-only type of store recipes. And we don't need to pass the recipes along because they're already part of our NgRx store. And I'll add this to the union type, even though we're not going to use this action in a reducer, but we are going to use it here in recipe effects. So here, let's now wait for recipes, actions, store recipes. And thereafter, I'll add a good old switch map here, as we did before too. Not interested in any data about my action because it doesn't have a payload, which I would need. Indeed, what I want to do here, though, is I want to run the code which we currently run in here, in store recipes in the data storage service. Let's grab that and add it here to switch map, return this here, and run our put request here. Now the thing is, of course, there I now need my recipes, which are in my store. That is the question. How do we get the recipes from the store? Well, the good thing is, it's relatively easy. We can use a special operator with latest from, which is also imported from RxJS operators. And that allows us to merge a value from another observable into this observable stream here. And there I now want to access my store, which means I have to inject it here. So my store is injected. For that, I want to import the structure of the store from my root reducer. So from app, from store app reducer, and assign that generic type down there from app state like this. And now with the store injected, we also need to import it. Import wasn't added automatically here, so let's do it manually. Let's import store from @NgRx store. So now with the store injected successfully, here on with latest from, we can use this store, select the recipes slice, and in switch map, we now actually get an array as an argument. Automatically, RxJS gives us this array, which holds the data provided by of type, which is our action data, which I'm not interested about, but also the data from with latest from, and that will be our recipes state. Now that gets passed into our function here. Now I'm using a syntax called array destructuring here, in case you're wondering. This simply means that I use square brackets here in the argument list, and I store the two elements that this array will have in variables that I can now use inside of switch map. Of course, you could also accept one argument because you get one argument after all, but that argument is an array where the second element is the data from with latest from, and the first element is your action. And I'm just using array destructuring. With that, I have access to my recipes state, and on my recipes state, I can access the recipes, of course. That should already be it. This allows us to send that request. Here, I'm also not really interested in dispatching anything thereafter because I don't need to know once this is done in this application. So we can set dispatch to false here so that NgRx effects knows that this won't dispatch anything. And now we can go to the header component again. And in the header component, in onSaveData, we can now use this store dispatch new recipe actions. And there I have my store recipes action. With that, we can also remove the data storage and the auth service from this file, remove their imports here, and remove the entire data storage service file. We don't need that anymore. Let's save all files now. And let's give this a try. The app reloads. Let's go to recipes here. Let's maybe edit this recipe, and let's edit the schnitzel as well, adding a couple of exclamation marks each, and then hit save data. And now let's try reloading, and the changes are still there, which means they were saved on the backend. And that is it. That now means that our entire logic was restructured such that we indeed use NgRx only in this application. With all these changes made, we can now also get rid of the recipe service here. And that means that in the app module, in the core module, we no longer need and can be provided. So we can clean that up as well. And I'm getting an error about my recipe detail component. The recipe detail component still imports it and still injects it, and still uses it here in add to shopping list. And that is now the remaining thing where I don't want to use the recipe service anymore because I deleted it anyways. Instead, the idea is now to import my shopping list actions as shopping list actions from. And now I go to the shopping list area of this application, to the store there, and then to the shopping list actions file. Because there we do have an action for adding all ingredients, right? So in here, we can now use the store, dispatch, and dispatch a new shopping list action, and that would be the add ingredients action, which takes the ingredients as a payload, and that would be the this recipe ingredients data which I want to add. And with that, we fixed that. Now in the recipe edit component, there I'm also still importing the recipe service because I'm still injecting it, but we don't need it there anymore. So here we can just remove it. With that, everything compiled successfully. And if we reload, that looks good. Let's try adding these items to the shopping list. This also works. And now we did some cleanup work and we're entirely in the NgRx world. This was a super large module, and we had a thorough look at NgRx. Now, as you can tell, NgRx can be complex. Setting it up can be quite a lot of work. But as you hopefully also saw, as soon as it's set up, adding more actions, handling them with effects and so on, is really streamlined, and you have a clear plan on how you handle things. Asynchronous code and any side effects in the effects file. State changes in the reducer file. And you hopefully also see how all these pieces come together and give you one global store in your application that you can use anywhere to access any data and dispatch any event. Now again, if you prefer services and subjects, that is absolutely fine. You don't have to use NgRx if you don't want to. But it can be a decent alternative to services and subjects in bigger applications. The bigger your app grows and the more people are working on it, a streamlined approach like this can be really helpful. Now, I also want to point you at ngrx.io, which is the official webpage of the NgRx project. And there in the documentation, you can learn way more about NgRx and also about advanced features of NgRx, because we actually only scratched the surface here. Also search for GitHub NgRx and check out that ngrx/platform repository. And in there, you'll find a projects folder with example apps. And this example app here combines a lot of the advanced and best practice features and patterns you can find for NgRx. So checking out this application also is a great next step if you want to learn more about NgRx. Well, and with that, you got all the tools to build powerful Angular applications, either with services and subjects, or with NgRx for a streamlined, highly structured state management solution. In this module, we'll dive into Angular Universal, which is an addition to Angular, you could say. Now, as you know, Angular allows you to build frontends, user interfaces that run in the browser. Your entire Angular app runs in the browser. Angular Universal now allows you to pre-render your Angular app on the server. So it's not a server-side framework like Express.js or anything like that. You won't use it to write server-side code, but it allows you to, on the fly, pre-render pages your users visit, so that when the users load the page, they get that finished page served back, and that initial rendering doesn't need to happen in the browser, and only subsequent actions by the user are then handled as always in the browser only. Let me show you what exactly I mean. Here's the recipe book we built. Now if we right click here and we view the page source, then what you see here is that you don't see much. We got the app root element here and then a bunch of script imports. And this is how a normal Angular app looks like. These script imports here are in the end our Angular application. So the Angular framework and the code we wrote, compiled, optimized, and bundled together. And app root here simply marks the place where our code in the end will start rendering the Angular app. That we see this on the screen is simply the case because the Angular app, so all these scripts, do their job and they change the page we're seeing after it has been loaded by the browser. Now this happens so fast that we don't see that, but this is what's happening. Now this approach generally is fine, but in some situations it might have downsides. Imagine that your users are on slower networks. In such cases, the JavaScript download might take a time, and until the JavaScript code has been downloaded, your users will see nothing. Or take search engines. A search engine, so the crawler of that search engine, looks at different websites to index them. And the search engine only sees what's initially downloaded by the server. It doesn't necessarily wait for all your scripts to be done with rendering what the user sees. So a search engine might not see what the user sees in the end. Instead, it might see, well, this. And as you can imagine, this is not so great for getting a good index score because, well, you don't see much, right? And that's what the search engine sees. For such reasons, it would be good if that initial first request, so when you first visit the page, when you first load it, would be pre-rendered on the server so that we get a real HTML page served back. That page will still contain all the script imports because it will be converted into an Angular app after it has been loaded, so that subsequent clicks are again handled in the browser only to be fast and reactive, but that first load is handled on the server. That fixes the search engine problem and also fixes the issue with slower connections. And Angular Universal helps us with that. So here's our code. And to add Angular Universal here, you only have to run one command. You run ngadd at ngUniversal /express-engine. Make sure to get this right. Then blank space, and then -- client project, written like this. And now take the identifier you find in your Angular JSON file. This identifier here, this name under projects. Enter this after a blank, after this client project thing here. With that, your project will be transformed such that it still works as before, and you can still run it as a normal Angular app if you wish, but you now also have the option of running it on a server and getting that pre-rendering stuff. Now this will take a while, because it will do a couple of installations and transformations, will do quite a complex setup, and as a short side note, until a few months ago you had to do all of that manually, and actually later down in the module I still have the older version of this module where I do it all manually. That still works, and I will leave it in here so that you can also have a look at the manual approach and get a better idea of what's happening behind the scenes in case you're interested. So now this is done here, and now with that being done, there are two important things you need to do before you can take advantage of this. The first important thing is that you should head over to your app server module, and in there make sure you have that module map loader module imported. Now if that hasn't been set up for you, simply add this by going to the terminal and by running npm install -- save and then add ngUniversal /module map ngFactory loader. Now, that's obviously a very weird name. In the end, this is a crucial package which provides this module map loader thing here, which is an Angular module, which we have to add to imports in the app server module, not in the app module, but in the app server module, to enable lazy loading with Angular Universal. Without that, your app would fail if you use lazy loading, because the lazily loaded routes wouldn't be able to be rendered in the end. So let's wait for this installation to finish here. And with it finished, make sure you add this import and then add the imported module map loader module package, or module as it is, here to imports in the ng module in the app server module file. Now that's one thing. There is another important thing you have to understand though. Your code here now is first rendered and executed on the server, not in the browser. So the first page, the first load, is rendered on the server. And only after that first page has been rendered on a server and returned to the user, only then a normal single page application starts to run in the browser of the user. That has one important implication. It means that certain browser-only APIs are not available. Namely, in our project here, local storage. If you search for local storage, we're setting data in local storage, and we're also reading data from local storage. I'm extracting user data from local storage down there in my auto login effect. This would fail on a server because local storage is a browser-only API. It's not available in Node.js. It's not available on the server, therefore. Now, to fix this, you should therefore go to your app component TypeScript file where we are dispatching this auto login action, and make sure you don't dispatch it when this gets rendered on the server. Now, for that to work, or to avoid doing this on the server, you need to find out whether you're running on the server or not. And that can be done by injecting something special here into the app component. You can inject an identifier provided by Angular that tells you on which platform you're running, basically. So let's store this injected value in a property, and I'll name it platform ID because that's what we'll inject in the end. And now you don't inject by assigning a type here, as we always did it before, but instead now you use a special decorator, which we haven't used thus far because you rarely need it. You use the inject decorator. Normally, dependency injection works such that you define the type here and Angular looks for this type. Now we're not injecting a class though, or an object based on a class, and therefore we don't use the type of a class, but we inject a hard-coded value, so to say. And this value has an identifier defined by Angular, which we can also import from Angular core, and that's the platform ID identifier. That's a constant provided by Angular. And you use it here with add inject in front of this argument now, in front of this argument the constructor receives, and there you pass that identifier, platform ID. And this tells Angular, please look for the globally provided value with this identifier and inject the value which is globally provided by Angular into this class and store it in this platform ID property. That's what's happening here. Therefore, we don't need to assign a type here. So now with this injected, we can use this here in ng-on-init to check if, and now we need one more thing from Angular, and now that's coming from the Angular common module. That's a method, a function, which Angular provides, the is platform browser or server, whatever you want function. I'll go with is platform browser. And this allows us to check whether the platform is a browser, the platform this code is running on. So we can run is platform browser. And this function requires such a platform ID, and that's why we injected it. So as an argument to the function, we pass this platform ID. And with that, Angular is able to find out where our code is running. And I only want to dispatch the auto login here if we're running on the browser, not in the server. Now here I have this log in my app component, hello from app component ng-on-init, and I only have that in here to prove that this still runs in the browser. So it's not just running in the server, because then it would be bad, because there we won't try auto logging in. It will also run in the browser. So in the browser, this will be repeated. So the page will be pre-rendered on the server, but once it's served, this code will run again on the browser. And therefore, auto login will work in the browser, but not in the server. And that's good, because auto login relies on local storage, which is not available on the server. With all of that, we're now done setting up Angular Universal for this app. And this workaround here is always needed when you are working with some browser-only API. And now, with that, if we have a look at package.json, we see there is this new build SSR command which we can now run, npm run build:/SSR, which will now build our app for Angular Universal. To be precise, it builds it with the ng build command in production mode, and then also creates a universal, a server-side build, so to say. And that's then allowing us to serve this app. So let's wait for this to finish. And a few words about serving this app then. You will need a Node.js server, so a host, a web host capable of executing Node.js to serve your Angular Universal app. A static host, like in the deployment module of this course, will no longer do, because you no longer have a static site. It's now no longer HTML, JavaScript, and CSS. Now you have code that runs on the server, and hence you need a server that is capable of running that code. So if you now deploy your Angular Universal app, you need a server that is able to run Node.js. And on that server, you can then run a command, which I'll show you in a second, or which I can show you right now already. It's this serve SSR command. You would take your entire folder here in the end, upload that on your Node server, and then run npm run serve SSR on your Node server to get that server up and running and serve Angular Universal, so that when requests hit that server, they are pre-rendered and users then have the pre-rendered thereafter normal Angular Universal application. So now it is finished executing, and now I'm running the command which you also would run on the server you deployed your app to. It's npm run serve:/SSR. This will now serve this through Node.js, and on this host, localhost 4000, you can now visit this app. So here it is, and if I open the developer tools, you also see hello from app component here in the browser log, which means this code also ran on the browser or in the browser and not just on the server. There it also executed, you see it here, but there, thanks to our check, we didn't execute the code which accesses local storage. And now back here, if I now inspect the page source, we see here we got some real content in there. What we see on the screen really was returned back by the server, and that is of course how it should be. This is how it should work, because this ensures that our page is loaded and presented as it should look like, and that search engines see our page the way they should see it. So this is how you can enable Angular Universal. Now, as I mentioned, you had to do a lot of that manually only a few months ago, and therefore later down in this module you find that full manual approach, just in case you're interested in seeing what happened behind the scenes. Basically what we do manually there has been done automatically by that ng add script we used earlier. Now, I'll go back one step and restart this. So we haven't added universal rendering yet, let's say. We still have that app that only renders in the browser. There is another way of adding universal rendering using Nest.js. Nest.js is a server-side framework for Node.js. It's not an Angular library, not an Angular framework. It's a server-side framework. And I have a video on YouTube which you can check out where I thoroughly explain what Nest.js is. I attached a link to that here on this lecture. So Nest.js is a server-side framework, but it borrowed a lot of ideas from Angular. It is basically like Angular for the server-side in quotes because it fills a totally different role being a server-side framework. So Nest.js is pretty exciting. It also uses TypeScript and, as I said, borrows some ideas from Angular. And the team behind Nest.js really likes Angular. Therefore, they also added a command which we can use with ngadd. We can use ngadd at nestjs/ng-universal. You can run this in any Angular application, and this will now also set up universal rendering, but with a Nest.js application attached to it. Now, the difference to the approach before is that before we had a simple server that simply pre-renders our Angular pages when we visit the page. Now here, that will work differently. Let me quickly enter the name of the application before we continue. We get it here in the Angular JSON file. It's this name here, so let's use that. And now back to what Nest.js does differently, or what's special about Nest.js. What Nest.js does now is it also sets up universal rendering, but in addition, it gives you a full Nest.js application to go with. And Nest.js is a server-side framework which you could use to build an API. So with that, you would have a simple approach of getting a full-stack Angular app where you don't just have the browser frontend, but where you actually also have everything you need to build a server-side API to which your Angular app then could talk. You don't need to use Nest.js, of course. You could build an API with NodeExpress, with PHP, with Java, with Python, or you use a service like Firebase, or you maybe have an application that doesn't need an API at all. But if you want to build a full-stack app where you also write your own server-side code and build your own API to which your Angular app can talk, then this is an easy way of getting started. So now that this is done, what we have actually is our app here. But we now also have a server folder, and in there we have a very simple setup for a Nest.js application. Again, in that YouTube video I mentioned, I will thoroughly introduce you to Nest.js, so if you want to dive into writing your own API with that video should be helpful. Here, this is already set up to simply render our app, pre-render our app on the fly. So right now it's only doing what we did with the approach before as well, but now with the possibility of easily turning this into a complete full-stack application by adding server-side code here. Now, one important note though, just as before, you should make sure that in your normal Angular code in the source folder, in your app server module, which still was added, you have that module map loader module added to imports. So make sure you have that here. If it wasn't added automatically, I show you how to add this in the last lecture. You basically install this package at nguniversal/module-map-ngfactory-loader. Once this is installed as a dependency, you import this module and add it to imports. And then there's one other thing which we also did in the last lecture, which you need to do for this approach as well. You need to make sure that in your app component, this code, the auto login code, doesn't run on the server. And you can avoid that this happens by checking whether you're executing this code on the server side or on the client side. And I explained all about this in the last lecture. So here I'll just quickly add the fix by importing something from @AngularCommon. And that something is the isPlatform browser function. And I also explained that you need to inject something with the inject decorator. You need to inject the platform ID global, which Angular exposes. You do so in the app component by going to the constructor there, and then you simply add @inject platform ID, store that in a private property, for example, platform ID seems to be a fitting name, and then here in ng-on-init you check if is platform browser, you pass this platform ID as a value, and only if that is true, so only if the code runs in the browser, this should get executed. And now you run this just as you run a non-Nest.js universal app by running npm run build :ssr and then followed by npm run serve :ssr. And you need to deploy this application if you want to deploy it on a Node.js server, just as you do it for a non-Nest.js universal app. So that does not change. So let's wait for this to finish. And now with this finished, we can again run npm run serve :ssr, and this will now, well, serve this app still in a similar way as before, but now using Nest.js and taking our Nest.js server into account. If you would want to deploy this, however, you would still deploy the dist folder and the package.json file, deploy this onto a server, and then there install the dependencies and run the serve ssr command here, which also just uses Node to, well, run the server file. So now this is up and running. It's running on the same port as before, therefore we can simply reload this page here. And you can ignore this error, which is just related to live reloading. What does matter is that this application works here and that we are able to use it and to work with it. Welcome to this module. In this module, we'll dive into Angular Universal, which is a tool provided by the Angular team basically and strongly built into the CLI, which allows you to pre-render your Angular application on the fly on the server. Now, why is that interesting? Here's our recipe book. And if we inspect the page source here, we see that there actually is not that much to be found, right? We got a bunch of script imports, some information in our head section, but then mainly we got nothing. We got our app root and that is it. Now the reason for this is that Angular, of course, is a client-side framework and all our content is rendered in the browser after this app has been bootstrapped, which is done by these script files. Now there's nothing wrong with that in general, but of course the user sees that. But search engines see that. And therefore, it might be worth exploring a different way of rendering our Angular app. And Angular Universal is a tool which basically provides a nice bridge from the awesomeness we have with Angular in the browser, this high reactivity, to the pre-rendering of pages so that the HTML we get back from the server actually is a pre-rendered snapshot of the page. And once it then runs in the client, so in the browser, it's a single page application again. So we want to get the best of both worlds, and Angular Universal can help us with that. Getting started with Angular Universal is pretty simple if you're using the Angular CLI, which you should and which we are doing in this course. On the GitHub page of the Angular CLI, you can dive into their official documentation. And in that documentation here, that's basically a link to that wiki. There you find some link to stories on the right here, and then to universal rendering. That's the article we're interested in. Here you can learn more about how to enable that universal rendering, and it's just named universal because your Angular app then runs on both the client and the server. So here you learn how to integrate that into an Angular CLI project. And thankfully it's pretty simple. It all starts by adding additional dependencies. So we'll go through that and all the other steps step by step in this module. And just one important note, I will be using Visual Studio Code in this module, simply because I'm recording this at a later point of time. This was recorded after the rest of the course was recorded, and I switched the IDE. Now it's still the same code, it's still the recipe book, it's still the same project, just an Angular 6 project, that's important, with a different IDE. And with that, let's continue and let's dive into all these steps and enable server-side rendering with Angular Universal. So let's get started. And let's get started by installing some additional dependencies. Let's just copy that command here, go back to the project, and let's quit the ngserve process and instead run that npm install command. This will install additional packages which we need for the server-side rendering to work. The packages we do install are mainly the platform server package provided by the Angular framework and then some helper utilities we need to write the server-side code, which will do the pre-rendering. Let's go back to our step-by-step guide then. The first step is to adjust our app module. Well, there, in our source folder, we have the browser module, and we should now call with server transition on that module. Pass a JavaScript object to that and set an app ID here. That can be any string of your choice, like my-app, for example. This will be used by Angular Universal to basically correctly transition from the server side to the client side. And with transition, I mean things like continuing the app in the state you got it from the server. So if, for example, on the server, you already fetched some recipes from a database, then you of course want to continue with that state on the client. And therefore, this makes sure that we keep that state and that the transition is done correctly. Okay, so that's the first step. We call with server transition. Now we need to create a new module, a new ng module for the server side, because there we start the app a bit differently than we do on the client side. You can copy that code you find here, and I will walk you through it step by step. So let's copy it, and let's create a new module next to the app module. Here, I will create the app.server.module.ts file and paste in that code we just copied. Now, what do we find in this file? We do import the server module from @Angular platform server, and we add that to imports. This is a crucial module which is required by Angular Universal to render your Angular app on the server. You can also see that we import the base app module, which we also use on a client, too. We import it from our app module file and we add it to imports. Last but not least, we have that module map loader module here, which has a very complex name, but does just one important thing. It ensures that our lazy loaded routes also work on the server. And with that, our module here is finished. Now we just need to make sure that we also have an entry file for our server-side code, a main.ts file for the server, and therefore named main.server.ts. Let's add it next to our client-side main.ts file here. Let's add main.server.ts, and in there we just have to do one thing. We'll export something. We'll export our app server module, which we of course find in the app folder and there in the app server module file. This allows us to point at this file and then indirectly automatically point at that file. And that is all we need to do. We just need to pass on that reference to the app server module, so to say. With that, we're done regarding our module setup. In the next videos, we'll tweak our TypeScript compilation configuration because we need to compile TypeScript code a bit differently for it to run on the server. And then we'll actually set up that simple Node.js server, which will do the pre-rendering and already see that in action. So let's continue. Let's continue by adjusting the TypeScript configuration. We need to adjust it because our default TypeScript config, which is responsible for compiling our TypeScript code to JavaScript code, that won't work for the server side. There we of course want to execute our Angular code, so we want to execute our Angular app there, but we need to compile it into code that does not run on the browser, but on the server. And for example, Node.js, which is the server-side language you have to use for that pre-rendering, uses a different import-export syntax. So we need to compile our TypeScript code differently. And to add this compilation, we can take the tsconfig.app.json file and duplicate it, and let's rename it to tsconfig.server.json file. Now in there, you need to switch the module from ES 2015 to common.js. You can also find this here. Now the other settings are okay, but we need to add one extra setting. We need to add some Angular compiler options. You can of course also just copy the entire snippet here. Now I will just add these options, and they will configure that Angular compiler, which is not the TypeScript compiler, but an additional compiler, which compiles the Angular templates, so your HTML code with all your directives and so on, to native JavaScript code. This compiler needs to know what your starting module is. And here I'm pointing at the app server module file without the extension, hashtag, and then the class name we find in that file. And if you didn't change anything about that app server module, then this default setting should work for you. Now we can compile our Angular app, which is written in TypeScript of course, into a version that can be run on the server. For that, we just need to tweak our AngularJS file a bit. There, we need to add a new build command, the server command, and I'll just copy the entire command. Let's go to the AngularJS file then, and let's search for the architect node. There we have the build command, which builds it for the client. And below that, I will add my server command. Now you could add it anywhere in that architect node, by the way. I will add it here. And that server command will allow us to run the CLI or run the build process through the CLI to take our TypeScript configuration automatically and then build our app for the server, optimize it, and do all the heavy lifting for us. For that, it will take a specialized builder, a build tool, which is shipping with the CLI, or as a dependency of the CLI to be precise, which is suited for server-side packages. And we set some options. And now here is an important option. This is where we want to build our app to. And I will name this dist recipe-book. Now, just a side note, for the normal build process, the output path is just set to dist. Let's change this to dist/browser. And now go back to our server-side build and maybe change this to dist server, so that this is really clear that this is the server-side build. Now, we also define the entry point, which is this newly added main.server.ts file, and which TypeScript configuration to use. Now with that, we set up the build workflow and we can already test it. To run our new server command here, we simply run ngrun, not npm run, ngrun, then the name of your project, which you find in the AngularJS file here under projects. In my case, it's n5 complete guide. Then a colon, and then the command you want to run. So anything from that architect node. Build, for example, or in our case, server. Let's add it here and hit enter. And this will now run our build command here, which we just added with our TypeScript configuration. And it should spit out a folder, dist server, which holds a main.js file, which is the built Angular bundle for the server side, or at least some part of it which is required to do that server-side pre-rendering. Now, that is the build process which we need to adjust. As a next step, let's add a simple Node.js server which is capable of running that pre-rendering process and serving our Angular app. So let's see what our next steps are. The next step is to actually add a simple Node Express server, which allows us to run our application. So for that, we can scroll down a bit. We will create a new server.ts file directly in our root project folder. You can just copy that entire file here, but again, I will explain what we're doing here. No worries. So let's copy it. Let's create it next to the AngularJS file, the server.ts file. Yes, we'll write this in TypeScript, and paste in the content. Now for this to run, we need to install some additional dependencies. So let's run npm install --save. And one dependency is the Express.js package, which you install with just Express, not Express.js, just Express. This is a framework for Node.js, which we use in that file to conveniently handle incoming requests and send back responses. Because with Node.js, we are writing our own server, which is doing all the request response handling. And we need Node.js because it uses JavaScript, and it's therefore capable of running our Angular app. So that Angular universal thing, for now, can really only be used with Node.js. We then also have a couple of other imports here, which are default Node.js packages, so that will work since you have Node.js installed. Just as a side note, check nodejs.org and feel free to download the latest Node.js version there if you encounter any issues throughout this module, because you will need a fairly recent version of Node.js for that all to work. But back to our dependencies. We'll install the Express.js framework, and that is actually all which we need to add for now. So let's hit enter to download this and also store an entry in package.json. And let me then walk you through this file. Now in this file, we first of all import some things. The first two imports are needed by Angular to be correctly set up on the server. We also do import them in the client-side bundle, and we need to load them early on the server side for everything to work. Then we're importing something from platform server, which will allow us to bootstrap our Angular app on the server. We import enable prod mode, which we then call here to basically turn our app or set our app to production mode to put some optimizations into place. Then we import the Express package, that Node.js framework. We import the join method from a default Node.js package, which allows us to join multiple path segments and file names into a long absolute path on the operating system. And we import read file sync from the file system package Node.js offers, which will allow us to work with files. And we will need that to load our index.html file, which we want to parse and pre-render, so populate with real content in this server-side code. We're then creating our Express app. That is a must-have to be able to use the Express features. We then set up the port number where we want to serve this during development, 4000. And we store the path to our dist folder in constant here. And this is just constructed with the help of this join method, where we take the current working directory and then add the dist folder. So this constructs an absolute path to the dist folder. Now it becomes interesting. We read in that index.html file from the browser subfolder in that dist folder, and that doesn't exist yet. Let's create it by running the normal client-side build with ng build -- prod. This will now build the package for the client side, as you're used to. Now this will do lazy loading, ahead of time compilation. It'll include all these things. It's a normal build. And it will build it into that browser subfolder in the dist folder, because that is what we changed in the AngularJSON file. There I changed the output folder to dist browser. Therefore, once this is done, in the dist folder, we will have the second, it's not done yet, we'll have a second folder, the browser folder. Now it is done, here it is. From that browser folder, we're pulling in that index.html file, we're importing that into our server.ts file with this line. And, important, we're converting it to a string, so to text. That is our template. We then import other features from our compiled main file, and here there actually is an error. Our file is stored in dist server, and it's just named main, not main bundle. So remove the .bundle here. These are features which were created when we built our app for the server side, and they are required to make that connection between server side and client side and pre-build the app on the server. We then import provide module map from this package to make lazy loading work, and then here we're putting it all together. Express.js knows so-called template engines. These are basically tools which enable Express to pre-render HTML files on the server, not just with Angular, but typically with other server-side rendering engines like Pug, EJS, or Handlebars. It can run JavaScript code there too, and now we use it with the Angular server engine. We create that engine by telling Express that we want to use it on HTML files, and that we then want to basically set up a renderer which should use our template as a preset, the template based on the file we pulled in, with some default options which we won't override. The defaults are fine, where we provide that module map, which is required to internally enable lazy loading, because it will basically give or pass on the information about which extra chunks we have. And then that's it. It'll then call this callback here where it passes on the pre-rendered HTML. So that will be our pre-rendered HTML page for whichever route we requested. This registers this view engine, or this configures it, I should say. With this line, we're then registering it as our HTML view engine. We're basically saying, hey, please add a view engine to the Express app for HTML, and we defined the HTML view engine here. We then also have to inform Express where to find our views. And there we're saying you find them in the dist folder in the browser folder. Now, views is a big word. We only have one index.html file, but that's still an important piece of information. Where is this located? We're then setting up Express to always return all files from within the browser folder statically, so that when our app does run in the client and we want to get the JavaScript file or some CSS file, that this can be downloaded. And then we're saying all routes which we don't know, so basically all routes because we have a wildcard, will be handled by rendering back a new page, and we're pointing at the specific template we want to use here, the index.html file in our browser folder in the dist folder. Since this is registered as a views folder, the view engine will kick in, and since it's a HTML file, this HTML view engine will do its job. And that will therefore pre-render that file. It will take the index.html file and fill it with live. This is our server-side code. Now, we can't execute it just yet because it's written in TypeScript. For Node.js to work, we need to compile it to JavaScript because Node doesn't natively work with TypeScript. So let's write some compilation logic in the next lecture before we can finally see this in action. Back in the instruction page here, we can see what we have to add to compile our server.ts file to JavaScript. We will use Webpack, the build tool, which is also used to compile the client-side TypeScript code. We can just copy that configuration. Let's copy it and add it directly in the root folder. There, I will add a webpack.server.config.js, not ts, js file, and paste in that code. Now, Webpack is a build tool, and I will not go in great detail through that. We're basically saying, take the server.ts file, build it for Node.js, be aware of Node modules and so on, and include any dependencies we need in that server.ts file, and then output it into the dist folder and keep the original file name, which is server in our case. We then add a so-called module loader to add extra features. And here we add the TS loader, which we installed earlier, which will basically do the TypeScript to JavaScript compilation. We then have some plugins, which are basically extra tools running over the compiled code, which will do some adjustments which are required right now to fix something. Chances are they will not be required in the future. With that, we can run our build process. And to run it, copy that Webpack server line you find here at the bottom and add it to your package.json file to the scripts section. I add a new script here, which is this Webpack server script. And that is a script which will use Webpack, the build tool, which is available because it's used by the CLI anyways. And it will take our Webpack server config file, which then will compile the server.ts file. We can run the script by running npm run, not ng, but npm run, webpack:/server. And this should compile our server.ts file to a server.js file. Now, when you run this the first time, it asks us whether we want to install the Webpack CLI. Enter yes here, because you need that tool to be able to run that Webpack build process. So let it install that. And once it is installed, it'll start with the compilation. Now, you may ignore the warning here, and you should now find a server.js file in your dist folder. We can now test this file by running node. This command is available since you have Node.js installed on your machine. dist/server.js. Now make sure you have both the browser and the server subfolders there with their build packages and hit enter. Now we got a Node server listening on localhost 4000. So let's grab that link and let's open it in a new tab. Enter that URL and hit enter. And I get an error here. I get an error which is telling me that something failed regarding the static injector. Now you might not be getting that error when you're watching this. Right now this is an error you'll always get, and you can fix it by going to that webpack server config file and by setting the mode here, mode, a new property you have to add, to none. Hit enter and run that npm run webpack server command again to rebuild it again. And once it is done again, rerun node dist server and revisit this localhost 4000 page. And now you should see the recipe book here. If you now go to recipes and you reload, you should see that if you inspect the page source, it actually contains the real content and not just your app root node. So this now is the content of your page pre-rendered on the server. And it should work just as it works on the client, but now everything is pre-rendered on the fly by the Node.js server. And this is Angular Universal in action. So we added this Angular Universal pre-rendering. How would you now deploy this application with that added? You would basically still deploy the dist folder, but now you need to deploy it to a server which is capable of running a Node.js server, because your hosting service where you deploy server.js to needs to execute that server.js file. It needs to run that on the server. That's really important to understand. This file needs to be run on the server, and therefore you can't use AWS S3 anymore, for example. You need some server where you can start that file and run it. With such a server though, you just ship the content of the dist folder to it and then configure it to run the server.js file, and you're done. This is how you would deploy it. Still deploy the content of dist, but now to a server which is not a static server, but one running Node.js. That's it for Angular Universal. I hope this is helpful. You can always dive much deeper into this, by the way. This is a basic introduction. This is how it works in a nutshell. This is what it does on the fly pre-rendering. Always keep in mind, you have a single page application again once it runs on the client. And if you want to dive deeper, you can visit universal.angular.io to find further resources and the GitHub page of that project, where you can also learn more, post questions or open issues to be precise, and dive deeper into that. So with that, let's move on. Welcome to a new module. In this course, we had a look at a lot of functionalities Angular 2 offers us, which allow us to create awesome single-page applications. Now, one functionality we haven't covered yet, and where I also want to give you a basic introduction to it at least, are animations. Angular 2 ships with its own animation system, which we can use to, for example, render the addition of items to a list or the conditional attaching or detaching of elements to the DOM. So all these things which are kind of hard to handle with normal CSS transitions or animations, because if you add something to the DOM which isn't there before, it's hard to handle this with a CSS transition style. Therefore, in this module, we'll have a look at the tools Angular 2 offers us to turn this application here, which isn't too awesome, but which has a list at least, well, to turn this into a nicer application where we play around with a couple of animations and see how the animation system in Angular 2 works. In this application you're seeing here, I get two buttons, animate and shrink, and they don't do anything. I'll come back to these buttons in a second. And then we got two lists, and I can add items to the list with the add button list or with the add item button here. I can add it to both lists actually. I do have twice the same list because I want to show different animations later on. Let's start with the two buttons up here and the basics of animations. As a side note, this project is of course attached to this lecture. So how do we start with that? How does the animation system in Angular 2 generally work? Well, if we have a look at the source code behind this template here, we see that here we get the two buttons and then we get this empty div. Now that's the div I want to animate and on which I want to show how animations in Angular 2 generally work. Angular 2 animations, which we use in a component since we want to use them in a template, are set up in the add component decorator. Here we have the animations array, and in that array we define the animations this template should be aware of. Animations are generally TypeScript code as we write it here in our TypeScript file, but it's very easy to understand how we manipulate certain styles of elements, since there we will use the same names as we use with normal CSS styles. But you'll see what I mean. So how does an Angular 2 animation look like? How is it defined? Each animation has a trigger. So we need to add trigger, and trigger needs to be imported from @AngularCore. Now I will split this over multiple lines because I will import a couple of other methods as well. With a trigger, which is a function, we tell Angular 2 that we want to define a certain name, which we can place in our DOM, in our template, which should then, if it is placed there, trigger a certain animation. So let's give it any name. I'll choose div state since I want to manipulate the state of this div element. This name is totally up to you. So that is the trigger. That alone won't do anything though. I want to attach some animations or something what this trigger shall do. So the second argument to the trigger function defines the animation this trigger should toggle. Now animation is of type animation metadata, as you can see here, and this actually simply is an array. So we pass an array as the second argument. Now with that trigger set up, and even though I have no animation added yet, I can already go back to the template and add this trigger to this div. I do this by using squared brackets, like when using property binding, but then add, and now the name of the trigger, which would be div state. So this trigger configured here in the TypeScript code is now used here, and this attaches it to that div. Now we need to bind that to something because the animation I'm going to define in a second should run all the time. So here we need to kind of, bind the condition which then controls which part of that animation we're going to set up should run. I'm going to bind this to a simple property named state, which doesn't exist yet, which I'll create in my component, a normal property in that component, state, which I will set to normal initially. That is up to you. That could also be a number, whatever you like. That is totally unrelated to your animation or to the Angular 2 animations in general, but we will use this state property and the different values it can have in our trigger up here now. How does it work? Well, let's say we wanna define two states, normal, which it is set to by default, and then we wanna give it another state. Let's say highlighted. Let's say we want to have animation between two states, and that is important how Angular 2 animations work. You transition from state 1 to state 2. You work with states. You don't have to name the property which controls your state as I do, but it makes sense here since we're talking about different states of that animation. So we define such a new state in our animation array simply by passing state and importing that from @AngularCore2. That's also animation related method. Now, as I said, we will at least have two states here to have something to transition from and to. Side note, I will show you a different setup in one of the next videos. And then we set up each state. Now we give it a name, normal, and this state here of course should match the state down there, because I want to use a state I actually use in my template or in the TypeScript code. So I'll use normal here, and here let's say highlighted. Both names are up to you, just make sure that you actually use them, like I do here, and therefore then also in a template where I bind to state. So how should the normal state look like? That is the second argument of the state method. Here we pass a style object or a style method, also imported from @AngularCore. So that's yet another method, but in this method we now define the style of the state. So we pass a JavaScript object, and here it's almost like writing CSS code, but don't use any dashes, so no background color like this. So how do we want to set up state here? Well, actually I want to set the background color, and I can do this by enclosing it in single quotes, or alternatively by using the camel case syntax like this. So I'll choose the first syntax with the single quotes here, and then I set background color to red, let's say. This is my initial state, that the background color is red. I also want to give it, or want to transform it to set translate x to 0, to have it at its default position and not move it anywhere to the left or right. So this is normal CSS styling here. Be aware that we don't see the div as of now though, because, well, it is a normal div here, and it only has our state, and even though if we were in the normal state, we only set background color and the position, but not the width and height. So in the template, let's quickly go to that div and add a normal style, totally unrelated to Angular 2, and set the width to 100 pixels and the height to 100 pixels, so that we can see it. Back to the TypeScript code. We set our normal state. Now we want to do the same for the highlighted state. Here I also pass a JavaScript object, and if we highlight it, let's say we want to set the background color, now I'm deliberately using the other syntax, to blue. We also want to transform it and move it, and we want to move it 100 pixels to the right, let's say. This is the highlighted state. Now if I save this with ngserve running to see the application, if this reloads, we see the red rectangle or square here already. We see a square because we set width and height here, but the red color clearly stems from our normal state, which we set up here in the state property, which we bind to our div state, which again is the trigger we're setting up here as animation. So we don't have an animation yet, but an animation is always just a movement or a journey from one state to the other, and at least we're at the beginning state now. In the next video, we'll have a look at how we could get to highlighted and how we can animate the transition between the two states. Right now in our application, we are at the place that we are able to display one state, normal here, or of course if I were to change this to highlighted and let it recompile, this should get blue and move to the right, like this. But now we want to animate the transition between both states. Now with that set back to normal, right now we have no way to move or change the state from our code. But we do have this animate button, and we try to execute the onAnimate method there. So let's hook up the onAnimate method here, onAnimate. And what do we want to do in this onAnimate method? I simply want to switch the state. So here I want to check if this state equals normal, then I want to set this state equal to highlighted. Otherwise, I want to set this state to normal. Now with this in place, if I save this, let the application reload, now you see it's gone. Well, that's simply a bug because I'm using background color as a string and then like this here. We actually have to use the very same, and I think this should get fixed, to be honest. Just wanted to bring this to your awareness. If you're mixing the way you're setting up your properties, even though it should theoretically work, it doesn't. Make sure to use the same type of property name. But if I switch this and I now have the function to change my state, you can now see I can switch between both states and toggle between them. But now we want to animate the transition so that we not instantly switch the state, as we already are able to do with that, but now that we animate this. Otherwise we wouldn't need this animation trigger here at all, because just appending different styles, well, that's something we'll learn throughout the course. So in the next video, let's have a look at implementing this transition. So we're able to hard switch between states. Now let's animate it. In our animations trigger, on the same level as the state method, implement the transition method. This also needs to be imported from @Angular core. Now transition is a very intuitive method. It allows us to describe how the transition from one state to another state should look like or should work, how it should be animated. Therefore, transition as a first argument expects the starting state, then an arrow pointing or indicating the direction, and then highlighted here. So this means from normal to highlighted. Well, now in the second argument, we specify what to do. We specify animate, which also needs to be imported from @Angular core. So now for this direction from normal to highlighted, we now set up how to animate this. And the easiest way is to simply pass a number here, the number of milliseconds it should simply take. I'll also come to more advanced use cases where we can also have some in-between styles during the animation. Well, before coming to so advanced topics, let me also copy it. And let's change the timing so that we can see a difference for the other way around. So highlighted to normal, like this. And if we now save this, we see that now it moves and it moves slower back. And this is now our first animation using the Angular 2 animation framework or helpers here with that trigger the different states and then the transitions between these states. Now let's dive a little bit deeper at this and see how we can fine-tune this to our needs in the next videos. Well, the first thing you can do, and for that I'm animating this, or excuse me, I'm commenting this out. If you wanted to use the same timing, you don't have to duplicate this and simply write highlighted to normal here. Instead, you can use one line and simply make an arrow point in both directions. Now this means back and forth, use the same animate function. So in this case, use the 300 milliseconds, which now means we have the same timing. That's one thing. But also you might have a more complex animation where you want to control the styling this has during the movement. So not the beginning and not the end state, only during the transition. You might have some extra styles at this place or at this point of time too. Well, to simulate this, let me copy this trigger here so that we keep the simple one too. And I will name it wild state because it's getting more wild now. So the wild state should now be applied to a new div I'm copying here too, which is now bound to that new wild state. It still uses my state property, don't get me wrong, but here it now uses the wild state. Now with that, I'm binding it to the wild state animation trigger. I also want to set up a new property. I'll name it wild state. And therefore here in my component, I'll duplicate normal and set this to wild state so that I have two different divs where we can see two different things. Now, how does wild state work, or how do I want to control this? Well, I still want to have my normal and my highlighted style, and I will leave the styling I have here. But I want to set up a third state. This is the shrunken state, let's say. So I'm able to shrink this square. The background color, let's say, should then be green. And we transform it such that we want to translate it 100 pixels, but we want to scale it to 0.5, let's say. And no, let's actually translate it 0 pixels, so at the starting point. Therefore, in the other two states, we want to scale it to 1. So that's again normal CSS setup here. And with that, we set up the different states. Now, I want to go back to where the two directions, highlighted to normal and normal to highlighted, have different durations, like we had it before. So like this. Yeah, I could have just commented this out. Anyways. Now, I also want to adjust this and also hook up this onShrink method here, this shrink button. So onShrink shall now assign this wild state to be shrunken. That is that third state I set up here, shrunken. In onAnimate, I therefore also want to set this wild state equal to, or first compare it if it's equal to normal, and if not, well, I basically want to do the same as here. So let me quickly copy this and replace this. So here I'm not using the shrunken state, that's something I'm only setting here. Now with this setup, I can of course reload my application. And once it does reload, we should see a new square below the first one. And maybe let's introduce a little divider here, like a line break, so that we can clearly see the difference. And now if I click animate, they both move with different speeds, of course, because I changed this. But shrinking still happens instantly. So shrinking is not really animated, and that is something I want to change. So back in the app component, we basically need a third transition because we're only targeting normal and highlighted, and we're not using shrunken now. To do that, I can use the following transition where I transition from and to shrunken and now from anywhere. So I don't care if I have normal or highlighted. No matter which of the both states it is, I want to play the same animation. And for that I can use the wildcard character, which means any state. So shrunken to any state and shrunken from any state should play the same animation here. For now, I'll animate it over 500 milliseconds so that we can see something before I then fine-tune this. So after reloading this, if I now shrink it, you see it shrink down, and if I animate, you now see it switch and animate correctly. So now we are animating this, and the wildcard character here is the key to give us the flexibility that we don't manually have to specify any possible state, and in your application where you maybe derive the state dynamically, you might really not know which states it could have, and there the wildcard character is what you need. Now in the next video I want to dive in how to manipulate this animate function and have some in-between styles during the animation. Thus far, we only had starting and ending state. Now let's play around with the animate function. We actually can not only pass the timing, we can control the whole animation and define styles the animation should take during the animation. For that, I will pass a second argument here, which is the style method again. We're already importing that. And as I can define the style in a state, I can also define a style during the animation. So here I also pass a JavaScript object, and that in-between style will now be taken during the installation. So here, let's say I want to give this a border radius of 50 pixels. Now let's see how that looks. If I save this with this extra style during the animation, if I hit shrink, you see it now looks kind of ugly because now we let these border radius, or we let it, well, get round, but once it finishes, it instantly jumps to the end state. So this is not really what we want. We want to smoothly have this in between our animation and not animate the changing of the border radius and then instantly jump to the end state. To cater for such needs, we would replace this animate function here, like this, with an array. Now we can pass an array as the second argument to transition, and here we can also define starting and in-between states during this transition. So we could pass a style here and say background color shall be orange. That would be one thing. Thereafter, the second element in this array would be an animate function, which takes, let's say, 1 second, where I want to animate my border radius as before, border radius, 50 pixels. And now to avoid this ugly jump at the end, I add another animate function of half a second, which will be executed after the border radius has been changed. Now with that, we should instantly see a change to the background color to orange. Thereafter, we should see the border radius developing over 1 second, and thereafter we should see the animation of, well, half a second, where we remove the border radius again, shrink the object, and turn it from orange back to our end state, which is green, for example, if we do shrink it. Well, let's see this. If I shrink it, we do indeed see it turn orange, see the border radius, and thereafter see it shrink and the border radius being removed. And the same is true if I animate back. So with that, I got a more complex animation where I chain multiple styles. And while all this nesting here might look difficult, it actually isn't. It only is an array passed to the transition, which allows us to define different phases in that transition. Starting phase, if no animate method is used, then it is instantly applied. Then if we do add animate, we do apply a style but over some time. And if we have animate without a style, this means basically now transition to the end state. And this is how we can set up our animation. Of course, we could have multiple in-between styles. The important thing is that you do end with animate 500 or whatever timing you have to get smoothly to the end state. Otherwise, you will see what we had before, that it instantly snaps back to your end state. Probably not what you want. This is a more complex transition with the in-between steps, but I think still manageable if you really think about what's happening here with these different phases. So that's all nice. We're able to animate these divs here. But what if we actually do want to animate the addition of an item to the list? Or if I click on it, the removement of such an item. How can we animate this? We'll have a look at this now. Thus far, we only animated the div. Well, now it's time to add a new trigger to our application. So I'll copy the first trigger in this overall animations array here, this one here, and add it. Make sure to pick the right level where you add it. Should be on the same level as the other triggers, of course. Now, I'm going to name this list1. And there I only want to have one state actually, the in state, so that the element is on the DOM, is added to the state, it's in the DOM. The other state would be that we don't have the element because we just removed it or we just added it, so it kind of should appear. And that is a state handled by Angular 2, as you will learn. So the in state is, how should it look like once it finally is there? Well, I wanted to have translate x of 0 to be at the position I actually place it here in my HTML code. And I wanted to have, let's say, an opacity of 1 so that it is fully visible, not transparent. That is the one state I have here. Now I need transitions. The first transition, which is interesting for me, is when it comes in, so when I add it to the DOM. Here the end state is in, but what is the beginning state? Well, we could use the wildcard character, but there is a specific state for this case that an element hasn't been added yet. That's a void. So void is a reserved state name. You can't use it, you shouldn't override it. Void is provided by Angular 2 for cases where you do have an element in an end state which wasn't added to the DOM at the beginning. Or of course you could also add void as the transition to state. So if you remove an element, for example. With this, it should slowly appear. And we can see this in action by going to our app component, to our HTML file. And there on the list item specifically, we want to add a trigger as before, square brackets and then add, and then list1. And we don't need to bind it to anything because I will actually set up void to anything because I don't care what the specific state is. In is just a dummy here. You could use any name. I only have in here. We could have some logic in the code which changes the state of our list items, but here for the entering animation, when we add a new item, I don't care what the initial state is. And actually I never set it in this application. I never apply a state of in to this. I don't have a property managing my list element states. I do have it for the above examples, but here I don't care. I want to animate from not existent to any state. This is the animation I want to execute, and if I save this and we see this in action, let's add test here. And well, that is certainly not working as intended. So what's going wrong here? Well, the issue is clearly we have no starting state. Now it doesn't work such that we now set up void like this. Before we defined our states like this, but since void is kind of a built-in state, it now works differently. Instead, here in our transition, we now want to change this. We will use an array here where animate is placed in, but before executing animate, I will have another style method where I set an initial style, and this style will now be applied by Angular 2 right at the beginning. So when we add a new list item, it is appended to the DOM and it will instantly get this style by Angular 2 and then transition over this duration to its final style here. So the style I want to set up here therefore is an opacity of 0. And I want to transform such that it flies in, so translate x should be -100 pixels. And now if I save this, now we should see a nice animation when I actually add new items to the list here. You saw it up on the initial loading already, and now each new item is smoothly animated in like that automatically by Angular 2. It doesn't work for deleting though, so let's handle this next. Well, let's say for deleting, we want to have it fly to the right. So to do this, I'll add a new transition here to my trigger. And here I want to navigate or animate from any state to any state would be possible too, but to void specifically. And here I want to start with the state it already has, so no need to define a starting state. Instead, my animate function should now have a final state, because here I don't have the problem of it snapping to some other state at the end. This should be the state it takes at the end. So here, with style as the second argument, as you learned it above, here I set up the state I want to have it, or I want to have it at the end. And there I want to transform to translate x plus 100 pixels to move it to the right, and to also fade it out by setting the opacity to 0 again. Well, and with that in place, the timing, yeah, let's have it at 302. Once it reloads and I click on an element, you see it smoothly transition out and being removed. And this is how you can animate lists, and the same would of course also work for ngIf, where you also have that behavior of something new being added to the DOM. Well, that was a lot, but I want to mention two more things or show two more things. One is a more detailed control over the individual steps during the animation process here. We already saw that we can define multiple phases, but each phase gets the same importance. It would be nice if you could define some keyframes to specifically say, okay, you animate over 1 second, after 200 seconds you should have this state, after 500 seconds you should have this state, and so on. Well, we can do this. I'm copying my trigger here, a final time, and here I want to set up list 2, which in my template I bind to my second list here, which uses the same data source. So here add list 2 sets up the trigger to bind it, and then we can set up the animations here. Well, I'll leave the in state here, but for the transition, when coming in, I want to change this. Here, I don't want to specify a normal array as I did before to have these different equally weighted phases. Instead, I'll pass an argument, which is still an array, but there in the animate function, let's say 1 second, I use the keyframes method as the second argument. This needs to be imported from @Angular core. Now, the keyframes method here in the animate function allows me to be more precise which part of multiple styles I can now set up should occur at which timing. The overall animation will take 1 second, but I can now control which state inside of that animation should take how long. So here keyframes therefore is also an array with now the individual phases. And there I simply apply a couple of styles with the style method again. So let's say when we let it enter, it should transform, and at the beginning we have it on the left as before, minus 100 pixels. We also set up the opacity as before to 0. Now let's say we want to have another style during that fly in animation. Here we want to have transform, set this to translate x 50 pixels. Minus 50 pixels. So halfway there, because we want to end at 0, translate x 0 at the end. That is our final state up here. That. We want to animate the opacity to already be at 0.5. And then we have yet another style, let's say, where we want to say, okay, the transform function is now also almost there. So translate x is now minus 20 pixels, but importantly opacity is 1, so we're done when it comes to opacity, but we're not completely at the position we want to be. This will work like that. I can now save this, and if we let this reload, you should watch the bottom list. You already saw it up on the initial fly in, and you should see it if you watch the comparison to the top list. If I add a new item, this is much slower, and it starts fast and then takes very long for the last bit. The reason for this is that by default, all these steps here take equally long. I have 3 elements here in my keyframes array, and then every style is triggered after a third, for the third of a second. I can override this. By passing the offset property, I can say at which timing of these 1000 milliseconds in this case should you be at this state. So the first state is at the beginning, offset 0. Then here, let's say we want to be at this not after half of the time, which it would make sense because we are halfway in and halfway the opacity, but we want to be at this point after 0.3 of our animation time. So 30% of our animation time, so 300 milliseconds in this case. And we want to be almost done after, let's say, 0.8. And then I will add a final style here with an offset of 1, where I'm done. This is my final keyframe, so that it doesn't snap at the end. Well, with this, if I let it reload, we saw it here upon the initial loading, and if I add a new item, it starts fast, but then smoothly finishes. This is how we use keyframes to control precisely which state we want to have at which time during the transition. That's important. Keyframes are for the time during the transition, so over the time of such an animate function. And of course, you could still have multiple animate functions as we had before. In that array you pass to the transition, you could have multiple animate functions, and each animate functions could have multiple keyframes, so unlimited possibilities here. Now for animating an item out, let's say we wanted to have 2 different animations which take a different amount of time. So 2 different animations would be rather easy. Here is where we animate out, and we're having this style being set up during the animate function. And if we now want to have a second style, we could add a new animate function here. And let's say here we simply want to change the text color to red. Now if I save this, let's see what happens if I do animate out the item on the bottom list. If I click on milk, well, it's invisible before I see the color turn to red. That is not really optimal. So if I switch the order here, so that I at least see this, let's see if it at least works how it should work. If I click an item, it gets red and then is animated out. But what if I wanted to have both at the same time, but maybe with different timings, so that I don't wait for one animation to finish before starting the next? I can do this by passing or by using the group method. That's also a method to be imported by Angular 2, or from Angular Core, I mean. Yeah, so from Angular Core. And in this group method here, as an argument, we pass an array of animations we want to perform synchronously, so at the same time. So here I can now pass my 2 animate methods, and I'll give it different durations so that we can clearly see that both happens at the same time. And now if I save this and we let it reload, let's remove an item. You see, it turns red whilst moving, but it moves slower than it takes to turn it red. And this is how we can use animation group to group multiple animations with possibly different timings together to have them happen at the same time and animate different things over, as you see here, possibly different durations. To wrap this animation introduction up, there are a couple of callbacks you can listen to, so that when an animation finishes, you might want to execute some other code. So here in app component, let's say on that div element here, we can listen to these callbacks here. We set up event binding, but then again with the @ sign to indicate that we're in the animation world, like here with the property binding where we also use the @ sign. We set up the trigger here, so div state for this div, And then we got the start and the done trigger. This method will get executed whenever the animation starts. So here we could say animation started, execute this method. And let's pass the event exposed by Angular 2 to see what's inside of it. And I also want to listen to the finishing with the done event on our trigger, animation ended, and also pass the event there. And then in the app component, I want to set up the two methods here. So animation started, which receives some event. And here I want to simply log this event so that we can see what's inside. And then animation ended with the event, and also log this event here. With that, let's save this and reload this application here. And now if I click animate, you see we had the starting and the ending animation fired, and here you see what's inside the event. We see the starting state, the to state, and the timing. And the same is true for the same data is part of the animation ended event object Angular 2 gives us. So these callbacks might be useful for you if you have some code which animates something, but after the animation finishes, you want to execute some other code. And you can do that by listening to these built-in start and done events on your trigger. I hope with that you feel a bit more comfortable using animations. You got a nice introduction to how you might create your own animations in Angular 2, how you can animate things in your Angular 2 application. And with that, play around with it. Set your own challenges. Take your existing projects, maybe the recipe book, and animate some things. This is a challenge. This is where you'll learn the most. See you in other modules. Bye. Hi everyone, welcome to this video. In this video, we'll turn an online-only Angular application into an offline available one by adding a service worker. And as you will see, this is super easy to do with Angular, and I will show you how to turn it into such an application and how you can then also configure it to fully meet your needs. So let's dive in. We'll start with this very simple Angular application here, and you can find the code to that project attached to this video. And this is obviously a very, simple, not too exciting Angular app. It is rendering a list of blog posts, dummy blog posts, which are fetched in our app component here from JSON placeholder. Well, that is just a page exposing a dummy REST API, which you can use to get some demo data to display on your page. You can also send dummy post requests to them and so on, but that's not what we'll do. We'll focus on getting data. So this is a normal Angular app, not too many features, but it represents a typical Angular app. We got more than one component, and we also got our posts. And if you watch closely, you see I'm also using some special font, which I'm actually pulling in my index.html file. Here, I'm importing this Oswald font here from Google Fonts. So this is what makes up our Angular app. Now, if we inspect it in Chrome, we can go to the Application tab here in the Developer Tools, and we can turn this to offline mode, which means we're still online. We don't have to quit our Wi-Fi network, but this will simulate that we got no internet connection. And if I now reload the page, well, obviously I get an error that we don't have an internet connection. If I go back online, it works again. Now let's see how we can actually fix this or change this behavior with the help of a service worker, and how we can easily add such a service worker to the app with Angular. Let's first of all understand what a service worker actually is. Now, this is how our JavaScript code typically behaves. It runs in a single thread. That means our web application, which can consist of multiple pages, or in the case of an Angular app with one page only, this app often uses JavaScript. And if you're using Angular, you're of course using JavaScript because Angular uses JavaScript. So this JavaScript code, the entire Angular app, runs on one single thread. And JavaScript has its features to still handle asynchronous code and not block the execution. But this is all normal JavaScript. Now, JavaScript and the browser also offers us to run an additional thread. We can run a so-called web worker, and a special form of that is the service worker, on another thread. So this still then uses one and the same thread, but it's a different thread than your main JavaScript code. And the important part is that this thread is kind of decoupled from your HTML pages. So this means that this can also continue running in the background, for example, on your mobile phone. That is something mobile browsers typically offer. This can continue running, and it could therefore also do advanced things like receive push notifications. Take my full progressive web app course if you want to learn more about this. But one other crucial thing that a service worker can do is it can manage all your different pages in case you got multiple pages, or your single page if you're building an Angular app, and it can listen to outgoing networks requests. So it can listen to requests going out of your web page. For example, if you're fetching the assets of that web page, the CSS code, the font, the JavaScript, or also data from an API. The service worker can catch these outgoing requests and do something with them, like, for example, cache the responses in a special cache storage, or then also return these cached responses back to your page so that it also works if you got no internet connection. Of course, only if there is a cached version available. This is what the service worker does. It can be seen as a proxy between your app, your front-end app, and the HTTP request you're sending to the backend. It proxies that request, which means it catches it, does something with it, and might then allow it to still go on and leave the app, but it could also block this. Now, configuring such a service worker and writing it from scratch is something you can do, and something you'll learn in my full progressive web app course. There you also learn about features like push notifications and so on. For this video, we'll focus on how Angular can easily add such a service worker to our Angular app, because it turns out that there is a special package we can install. For that, let's quit ngserve, and now here it's important that you're using the latest CLI version for that project, and this project does. And then you can run ngadd to add a third-party package, but that's more than just a npm library, really some functionality to your app, and only some features can be added, because essentially this will execute a command which has to be defined by whichever package you are targeting. So not even close, not every third-party library supports this feature. But there is a special library which does support it, which you can target with @angular/pwa. And if you run this will actually configure your existing project to use the Angular service worker package and start with a pre-configured service worker. So it does a lot for you. You can already see it added some things to the index.html file, like the no script section to give a warning if JavaScript is turned off, because we need that, of course. We need it turned on. It loads this manifest here, which it also generated. Now, that is important for actually having a launcher icon for your app. If you have it on a mobile phone, you can even save it to the home screen and then start it with that. And you can define which icon that should use and so on. So that is the manifest.json file. Again, learn more in that course I mentioned. For us, interesting is the app module. Because in the app module, we are using a service worker module, which is imported from @Angular service worker. And this is really an official package of the Angular framework. And it does what it sounds like. It registers a service worker, which will be that proxy that catches outgoing requests and does something with them. And you will learn how to configure what it does to them later in this video, of course. We use it here by calling the register method, and there we target the ngswworker.js file, and you won't find that file here. And the reason for that is that this file will actually be auto-generated. It will be generated during the build process, and it will be in the dist folder therefore, and it will hold your service worker, which will contain a lot of functionality which you don't have to and typically don't want to write on your own. And here it's also configured to only be added if you're building for production. In the assets folder, we see some icons were added for that manifest.json file, and in the root project folder, we see that in the package.json file something changed. For example, the Angular PWA package was added, which includes that Angular service worker package. And we got this ngsw config file. this is the file where you can configure that service worker which will be generated, but we'll take a closer look at this in a second. The angular.json file, which manages the CLI project, also was adjusted a little bit. There, service worker is set to true for the production build. This is required because the service worker will cache certain resources, and to ensure that the new build updates the service worker, these resources will contain a hash, and that will then also be injected into the service worker, which is why we need to make the build process aware of the fact that we need a service worker. This is how that works. Now let's simply see that in action. Let's create a production build by running ng-build --prod. And this will now bundle and optimize the entire app, use ahead of time compilation, and so on. And it will spit out our Angular app in a dist folder, and there we should then also see the service worker. So let's have a look. If we close the source tab here, let's refresh. Here's the dist folder, the Angular PWA folder for the project. And there we see that NGSW worker.js file. You remember, that is the file we are importing in the app module here. We're registering it here. So this can be found in the dist folder indeed. If we have a look at it, you see there's a lot of code in there because, well, it's actually pre-generated for you to do all that caching and so on in a very efficient way. And now let's simply see what it does. And for that, you need a web server you can run to host your production app here. You could do that with ng-serve --prod, but there you will actually not see the service worker in action correctly, because it will only build it in memory. So therefore, what you should do is install a lightweight node server, and thankfully there is one. You can install it with npm install -g to install it globally, http server. This is a package you can use to launch a simple node-based server, which will host the content of the folder you run the command in. And the command you need to run is just http-server. So let's navigate into our dist folder, and there in the Angular PWA folder, and let's run http server, and then you can assign a port with -p 8081, for example, and it will then bring this up, and now you can visit localhost 8081, and you should see your Angular app there. Now this app looks like a normal app. Now reload it once to make sure that the service worker can do its work, and go to application again. We should now see that under application, we got that NGSW worker running. And if you don't see that, try reloading that page one more time. Also make sure to clear the storage here entirely if you worked with service workers and this port served on your local domain before. Now you should see that. The interesting part is if I now tick offline again and I reload, it still works, right? We still see the same content as before, even though we're offline. Now, how can that work? If we go to the network tab and we clear it, and we now reload, we see we're making a bunch of requests here, and they're all essentially served from the ng service worker here. So from the service worker, this is all served. The interesting part is the posts request here probably, which is still kind of can connect to the outgoing server. For that, let's again disable Wi-Fi, and let's try this again. And now this does not work, but what we can see still is that for one, there is a bug or an intended behavior in Chrome, which leads to these API requests still going through, even if we simulate offline mode. But more interestingly, we see a white page. We don't see that there is no internet connection error. Now, we would not just see a white page. We would see any content we add here if we load our page. So we essentially see everything that's hard-coded into our Angular app. The dynamic content is missing. We'll take a look at this in a second. But all the hard-coded content is there, because what we can see in the network tab is that we're loading the main page, the styles, not the font, but the styles, the JavaScript files, all that is loaded from the service worker. And the failing things are the font and our posts. Let me turn Wi-Fi back on and also leave that simulation mode, which didn't work too great, I guess. And now, of course, if I reload, it again works. And let's now change something. First of all, let's change something at the app component. There, I'll add a h1 tag where I say my posts. Now let's quit that HTTP server, go back into the main folder, and let's run ng-build --prod again. And let's see how this now changes the app and if I'm right regarding my statement that hard-coded content would be cached. So let's wait for this to finish, for that build to finish. And once it's finished, let's go back into that dist folder and there into that Angular PWA folder. And let's run our server command again. So HTTP server on that port. Let's reload the application here. And you might need to reload twice, and you should then see my posts. The reason for the double reload is that the service worker was loaded, and the service worker is aware of the fact that the index.html file changed, or that the script rendering content to it changed, to be precise, because of that hashing thing I mentioned. This hash table which is automatically generated and all the files having hashes, because by default it would of course fetch these resources from the cache, so we would see the old version. We don't want that, so we take the new version we let us give the new version by using that Angular service worker package, which takes care about that hashing and the fact that the service worker is aware of the new version for us. So we got that. Now if I go offline again, you see that is also part of the loaded page, and if I go fully offline by turning off Wi-Fi, we still see that. So now the font and the API the API data is missing, I should say. So that is what I now want to change. And to change this and get that same page here when we're offline, as I'm getting when I'm online, we need to change the service worker config, which can be done in the ngswconfig.json file. Now in this file, you can configure how the Angular service worker behaves. So let's take a closer look. Now this file is actually not that long. It's a JSON file, JSON format. And first of all, we have the index page. This indicates what is the root page of our app we want to cache and load. And that of course is the index.html file sitting directly in the root server folder we're serving from. And then we got a so-called asset group, or actually asset groups. It's an array. And in there, we got two asset groups, these objects which we have in there. Now, asset groups are configurations that define which static assets should be cached and how they should be cached. Dynamic assets, for example, would be the data from the API. So data we're fetching, which might change on that API. So it's not static, it changes frequently. Our HTML file, our JavaScript code will also change with every build, but after the build, it's static. It's not changing in some database or anything like that. So that's what an asset group is. We can give such a group a name, whichever name you like. And you can then define how should these assets be loaded. Prefetch means that when your page loads, Angular will go ahead, or the service worker will go ahead, and already prefetch all the assets which are specified in this asset group, which means it puts it into cache even if you haven't needed them yet. The alternative to prefetch is lazy. You can use that too, and that would only load them once you needed them at least once. The advantage of lazy is, of course, that you don't occupy all the bandwidth right at the beginning. The downside is that if you need it for the first time, it will not be there. So if the user loses the internet connection before the asset, let's say the CSS file, is required the first time, it will not work because it will not be cached. With prefetch, it will be cached even before you need it. There also is an update mode. I guess you can see it down there. Now, this is important for the case that you're pushing a new version of your Angular app and therefore also of your service worker to your server. And the user is already browsing on that server. And it will get informed about the new service worker. And now the service worker can already prefetch the updated assets or also load them lazily when they are required. Now, the assets which should be loaded are the resources then. Resources has one key property, the files, and there you have an array pointing to the files you want to cache. You can point at something like the index.html file, and this is always seen relative from the dist folder, so from the folder you will have in the end once you deploy this. But you can also set up patterns like every CSS file or every JavaScript file in the root folder. Or you could say every CSS file in any subfolder. This is what this pattern would say. So you can also set up glob patterns like this or directly point at the file you want to use. Without the hash, because you can't know the hash in advance, Angular will generate that automatically, will take the unhashed file names here, and then automatically generate a service worker which will take the hashes into account. Now here we get a second asset group for, well, basically all images we got and so on. It differs from the first one in regarding the fact that it's only preloading that if we need them, if we visited them or used them at least once. And this is leading to the behavior we have right now. Now we got one other static asset, which is not included here. And that is our external font. It's not changing, or at least not regularly, so we can treat it as static. But it's not included here because it's not one of our files. But we can take it from the index.html file by just copying that entire link, which will be requested eventually. And then we can go back to the ngsw config file, and there we tell Angular that we also want to cache this. Now we don't add it to files because this is for local files. There is an additional resource type we can define, and that is URLs. It's also an array of strings, but here we put URLs like this one, which are reaching out to other servers to then fetch resources from there. With that added, let's save that file, quit your server down there, and let's go back into our root project folder, and let's create another build with ngbuild prod, like this. And once this is done, and we revisit the dist folder and serve that again, we should see that the font is also loaded in an offline mode. So we go into the dist folder, into Angular PWA, rerun that HTTP server command, and let's reload that page. And with it reloaded, and you might also close it and open a new tab to ensure that the new service worker gets really loaded and it's not still using an old one. With that loaded, you can tick that offline box here again, or since I always needed to do that, simply turn the Wi-Fi off. Go to the network tab to see all requests and reload the page. And now you should see that the font here also is not marked as red, but is actually loading the font as it should. So this is now also working. It's now also fetching this, and we're still, or now again, able to use it in offline mode, that font. Now what about the API? Regarding the API, we can also prefetch this. For that, we add a new configuration item, and that would be data groups. Remember, we got asset groups here for the static files essentially. Data groups is for dynamic data. So typically data you request from an API, data that might change frequently. How is a data group configured? It is an array because it's data groups here, but one data group is then again an object, just as an asset group. You then define a name of your choice, like posts, but that name is totally up to you. And then you define the URLs you want to handle with this group. And in my case, that is the URL I can see in my app component, which is where I make this HTTP request. This URL to JSON placeholder. This is what I'll take, and this is what I'll put into the URLs array as a string. You could now also add a version here. If you got an API which might have different versions and the version changed, then you could lock the version in here to, for example, cache different data pieces side by side for different API versions. Here I will not use the version. And instead, what you can add here is a cache config. This is another object where you can now in detail configure how this data should be cached. And for that, you can, for example, set a max size. This is a number, and this defines how many entries do you want to cache. And now that's important. This does not mean how many posts, for example. This means how many responses. Now for this single URL, we will only cache one response at a time. But if you had a more generic URL with a star, let's say, for different endpoints, then you might want to make sure that only for 10 outgoing requests, the answer was cached, to not pollute your cache and grow it infinitely, because your space is actually limited and managed by the browser, so you don't want to cache everything. So here we could say cache 5 responses. Again, for this example, it doesn't matter. We can then also add max age to define how old should the data in the cache be before we get rid of it and definitely fetch new data. because you might want to fetch from cache first to deliver something onto the screen as quick as possible, and then maybe reach out to more up-to-date data behind the scenes. But for that, you of course need to know, is the data in the cache still valid, or should I always fetch new data? This is defined as a string, which you write like this. You could say 1 day, or 12 hours, or 50 minutes. This is essentially the format you have. Details can be found in the official docs, and you find a link to that attached to this video too. So here I'll go with, let's say, 6 hours. And then you can also add a timeout. The timeout is defined in the same way. And there you could say, if I'm waiting for a response for, let's say, 10 seconds already, then I want to fall back to the cache and not wait longer, but I don't want to use the cache immediately. I want to wait for these 10 seconds at least. So I could say 10 seconds here. Last but not least, and that's important because it works together with the above values, the strategy. There you can have two types of strategy. Freshness, which means always try to reach out to the backend first and only use the cache if you're offline. Or performance. Performance tries to get something onto the screen as quick as possible, and it will take max age into account to know whether it should absolutely reach out to the backend or just use the cache value. On the other hand, freshness will take timeout into account to know how long to wait for a response before it uses the cache. So I will go with freshness here, and I will save this. And now you know the game. Let's go back and let's build this again with --prod. And what we should see is that now that we built this, that if we then go back to the build project and serve it, that this actually then works in offline mode. So let's bring up that HTTP server, reload this page, and as I mentioned before, feel free to close it because a new service worker to be registered should also be able to be loaded without you closing that tab and opening a new one. Angular can handle that, but by default, this is required. By default, for a new service worker to go active or to turn active and do its job, you need to reload the page. Also, because Angular does not use the new updated code you might ship onto the server and load it into your already running app, because that might break your already running app. So close the tab, open a new one. Now in that new tab, reload at least once so that the API responses can be cached. The first reload loads the service worker, the second one loads the API responses, then turn off the Wi-Fi and load again. And what you should see is that you still got your posts here. Now one thing you can notice is that the fonts are missing because, and that's just something you have to know about Google Fonts, the way it's loaded, it takes two URLs. This is the URL where it goes to and tries to fetch the font then. The other URL we put in there is the one which just holds the rules for the font and then that extra URL. So let's add that newly gathered information here. Now replace this at the end here with ** to load any fonts from the URL. Close the HTTP server and build this one more time as you saw it before with ngbuild --prod. And we could already see that the API data was loaded at least, so that this was present. Now with this build one more time, let's again go back to our dist folder and let's serve this one more time. But then open a new tab for it to become active. Reload this one more time to store, to make sure that the responses are really stored, I should say. And now let's go offline again and reload this app. And you see the fonts are there too. And in the network tab, we see everything is fetched. The posts fail, but that's no problem because we take that from the cache, which works. You can see it here in the response. There it is. And this is how we can use the service worker, the Angular service worker package, which you can easily add with the ngadd @Angular PWA package, which includes that service worker package, which also gives you that manifest.json file, and which overall is something you have to learn, but then gives you the powerful tool of making your web app offline available. Now check the official docs, which you find attached to the video, of course, and I hope that this was helpful. Welcome to a new module. Throughout this course, we learned a lot about Angular 2, but one thing we haven't covered is testing unit tests, to be precise. Well, the reason for this is that I really wanted to focus on the Angular 2 code and not confuse people with mixing in some non-Angular 2 testing code. That being said, testing is something which a lot of people might want to do in their project, which actually improves your project, and hence I will give you an introduction in this module. And that is important, an introduction. You will learn how you can write your tests with the Angular CLI. You will also find resources for non-CLI projects. You will learn how a test generally works and why you might want to test, and which testing utilities Angular 2 offers you. I will give you, or I will explain some example tests. For example, we will test a basic component, a service, and a pipe. But thereafter, it's really up to you to use the resources I also provide to dive deeper into it. Because testing alone would be enough content for, let's say, a 15-hour course, and it's not what this course is about, and it's not what this course should be about. But with that, let's dive in. Why might you want to create unit tests? Let's have a look at this application. We got a user component, we got a user detail component, a reverse pipe, and a user service. Well, the user component also uses some input binding here or some property binding with the user detail component. We can ask a couple of questions, or one and the same question actually. Does the component work as intended, the pipe, and the service? This is what we want to answer with unit tests. We also might want to answer, does the input work as intended, or does the injection here work as intended? These are questions we want to cover with unit tests. And with unit tests, we hopefully get a true response for all our tests telling us that our application is working as intended. Of course, you can already imagine that writing the tests correctly is an important part in order to get the right answers. And that's something I'm not going to teach you here because I can't. Writing correct tests is, again, something for its own course. Not even an Angular 2 specific course, a course focusing on testing. It's not the goal of what I want to do here. I want to show you how to use testing in an Angular 2 application, not philosophize about how testing should work or how tests should be written. So with the answers to our questions, the cool thing is unit tests allow us to guard against breaking changes, because we could say upon upgrading our Angular 2 application, we rerun all our tests and we see which tests now fail. If we know they worked before, we know which places in our application now are broken due to the update. We can also analyze our code behavior to detect both expected and unexpected results. And we can reveal design mistakes. Maybe when writing our test, we experience some problem writing it because we find a mistake in our general design, or we find it whilst running the test due to an unexpected response. So this is where tests can help us. Again, the philosophy behind testing and how to write correct tests is something which will not be covered here, which can't be covered here, but I want to show you how to create tests in your Angular 2 application. For that, I created a brand new project with the CLI. Again, at the end of this module, you'll find a lecture where I also link to the official docs actually, which really have a great article on testing. And not only does this article dive really deep into it and explore some use cases or a lot of use cases I don't cover here, it also will give you a setup instruction how to set up the, testing environment, for example, with System.js. Well, back to the CLI case though. We do have this app component, and by default we do have the app component spec file, which is not empty, which has this code instead. This is a unit test, or actually there are a couple of tests. Each block beginning with it here is a test. And the before each at the beginning, well, as you might guess, executes some code which should be run before running each test. Now we're seeing a lot of code here which we haven't seen before. We're using a couple of Angular 2 specific test utilities here to make our tests work. But before diving into them, let's understand how should a test theoretically work if we think about it logically. We do have our Angular 2 application with the app module and the app component, and it runs in the browser. Somehow we need to run the same in the testing environment, and the testing environment in the end is just a script running over it, we could say. So in order to simulate the same behavior, we also need to bootstrap our application, we need to set up the app module, and then we need to execute certain tasks the user might do or see. And that is what's happening here. And I think it's a great start to simply analyze this file to understand how Angular 2 unit tests work. So at the top, we import two things from @Angular core testing. That's the testing package Angular 2 ships with, which has a couple of utility tools, for example, testbed and async. I'll explain both of them in a second. Then we describe our to-be-tested unit in this case, which is our app. Here we want to test the app component and module, of course. We then have a closure, this function executed here. This is a part of the describe function here, and that will all be executed by the test runner we're using. Now we'll use the CLI with a command I'll show you in a second to run these tests, but you could set up any testing environment. A typical test runner is Karma, simply a package you install. It is installed here, which runs our tests. This script I was referring to. Well, then we first execute before each, so we do something before each of these blocks here is executed. Because important, even though these blocks here follow, well, after each other, each block is executed totally independent of the block before it. So this block is not influenced by the code in this block, and this block doesn't care about the first two blocks. Therefore, before each is the only thing which will be executed before each individual block. And here we configure a testing module as this method on the testbed, and testbed is basically the main Angular 2 testing utility object. So this allows us to configure the module for our testing. And what we do here is simply declare which components we want to have in this testing environment, which is our app component. So this clearly looks like the app module with the declarations, but it doesn't have the imports, providers, or the bootstrap. And that makes sense because here we want to focus on a part of the application. We're not really running it in the browser. We only want to focus on the app component, and the rest will be simulated by our testing environment. So this is declared and initialized therefore, and then we got a couple of tests. The first one checks if the app was properly created. We always need to create the component in each it block, since each block is contained in itself. We do this by using create component on the test bed, and then we store this new component in this fixture variable. That's just a name you'll commonly see, fixture, for this created component, this testing unit we're looking at. Well, we're creating a component, and of course we pass as an argument which component we want to create, the app component here, of course. Well, then we can get our app by using this fixture, which holds our created component. The debug element, that's just a property we can access to get access to a couple of, well, elements we can now have a look at. For example, the instance of the component which was created, which is our application in the end. And then we always end our it block here by using the expect method. Now that's not coming from Angular 2, as is before each and it, by the way. These are all testing package, so Karma related, or Jasmine to be precise, which is the testing package related methods. So expect basically says we expect whatever we pass here, so our app, we expect our app to be truthy, which means yet to kind of exist. And this is how we can read it. We have it, then this string is purely up to your choice, so it should create the app as basically human readable. And then we tell what do we expect when we should create the app. Well, we expect the app to be truthy, to be somehow existent. In the next block, we check if, or we say, it should have a title which says app works. Because that's the default setup, right? We got the app works property, which we output here with string interpolation. So it should have this title, and we check it here again. We create the component, we get access to the instance, and then we say, well, we expect this app to have a title property, so this property here, which equals app works, this string. And of course, it's only true as long as we don't change or remove this title. So that is how you write your tests. You have to reflect your actual application. Well, and finally, the third already existing test here is that it should render an h1 tag. We create it again. Now we call detect changes to trigger change detection. That's the only way to do it. It won't run automatically since it doesn't run in the browser. So we detect or we trigger change detection manually so that the template gets rendered. Here the native element, which gives us access to our template. And then we basically say, well, on this compiled template, we expect the h1 element, we get it with a normal JavaScript query selector, since this is a normal JavaScript object decompiled variable here. We expect the h1 element to have a text content which contains AppWorks. These are the three already existing apps, and this is the logic how this file gets executed, how it uses the Angular 2 testing utilities with testbed and async. I will come back to this in a second. And the default testing environment methods like it and expect to, well, basically describe what we would like to see and how it should work. Now, this is the theory. In the next videos, I want to dive deeper into this, show some examples for testing a pipe, testing another component which also has a service injected into it, and what this async thing here actually does, as well as which other utilities the Angular 2 testing package offers us. Well, now that we understood how these tests are generally written, let's see them in action. In the terminal, run ng-test inside this project folder to run our tests through the CLI, which again already has this test runner and so on built in. Now, what this will do is it will start up the testing environment. We can ignore these warnings. It starts up Karma, and here we see that it executed 3 of 3 tests successfully because we have 3 tests here. Now let's change something to see a test fail. If we go to the app component and change AppWorks to AppWorks without the second P, so just with one P, then the test where we check that it contains AppWorks, as well as this test here, should fail. So if we save this here, it should automatically rerun, and now we see 2 failed tests. And now we can simply inspect our log here, and it might be a bit hard to read, but basically here we see expected AppWorks to equal AppWorks, so this is a problem when failed. And the same is true down there, because both times we're missing the test that we don't have AppWorks here in the template where we expected it to contain AppWorks with 2 P's, but now it only has 1. So this is how we can then interpret these test results and find out what's going wrong. And now I'm going to fix this again to save it and rerun the tests automatically. Just takes a couple of seconds. And now we see they're all successful again. So this is how we run the tests, keep this running, and how we then see failing as well as successful tests. Now with that running, I can add some new things to this application to, well, enhance a little bit and dive deeper into testing. I want to dive deeper by quitting this process and creating a new component. So I'll create a new component with NgGC and I'll name it user, a user component. So I'll hit enter to let it create a new subfolder here in the app folder, the user folder, and there we got CSS, HTML, TS, and this spec file, this testing file. In this user component HTML file, I want to change this. I want to create a new div here where I have a h1 tag where I say user logged in, and then a paragraph where I say user is, and then some data which we're going to fetch from a service actually. So here I want to output the username. I will have to create this property. Now I'm copying this to basically later on check with ngIf which div to display. Here I will say user not logged in. Well, let's make this a lowercase l here and lowercase I. So user not logged in. And then here, of course, we don't display the user. Instead, we have please log in first. So this is my template code here. In the TypeScript file, I want to also adjust this. Here I want to have a user which has a name field, which is of type string, like this, so that I know this is how a user object looks like. I also want to have a isLoggedIn variable or property here, which is false by default. And with that, I can go back to the component here and basically say display the first one with ngIf if isLoggedIn is true, and the second one, of course, here ngIf displayed if it is not true, so if not logged in. That is my user component. Now, of course, this should be added to the app module. It is done so automatically by the CLI, but check that you have both the import and the addition to declarations here. And then we can go to our app component HTML file and include it here, but I won't even do this because I won't watch this app in the browser. Instead, I will only test it. So I will leave this here, close all these files, and now we want to write some tests for this new created user component here. Actually, we already have a spec file, but this is very simple. It includes the test bed and async task, though it doesn't use it. And then it only describes that it should create an instance. And here we try to create a new user instance like this. Well, let's remove this test here. It's not really that helpful. Let's write our own tests instead using the Angular 2 testing environment and not creating some, well, non-Angular 2 tests. So here I first want to declare the module again. So I will set up the before each method here, which takes a callback, ES6 function in this case here, where I simply say testbed, and testbed is really just this main testing object giving us access to all this configure my Angular 2 application for testing utilities. And here I want to call configure testing module. This expects to get a JavaScript object where I add my declarations like in the ng module, which is an array. And here I will set up the user component because that's the component I want to test. Make sure to also have that import up here. Now, important, if you were not using the CLI or any other Webpack based setup, you then need to compile components thereafter. You need to execute compile components to, well, compile them. Only when using Webpack, this is not needed because Webpack has a different workflow build process where they will do this anyways because of the way you import your external HTML files or CSS files. It will do this whilst bundling or producing your app. In a System.js setup, for example, it won't do this automatically, so you will have to do that since the Angular 2 compiler, which would do this in the browser, won't run here. So with that, we have our compiled components or our setup here. And next, I want to create a test. So we write it and then give it some description of your choice. That's just something for you to read to understand these tests if you see them in the log. So here, we want to check that the app was created. So it should create the app. That is what we're checking. And there we then have a second function, which is a ES6 function here with the arrow. And there I want to create my fixture again, where I use the test bed and then create component and create a user component like that. Now we created this component in the testing environment. So it is like if it were added with a selector in some HTML template and we browsed to this page, then Angular 2 would create it in the background. Now here we're creating it. Now here we're creating it. And with this fixture, I can now get my app from this fixture. And there we typically do this by accessing the debug element, which is the element exposed to us for testing purposes, where I can access my component instance. So this is my application, this running component instance. And I can then say, well, I expect this app to be truthy. We saw that before. This just checks, well, does it kind of exist? Well, if I save this and I now run ng-test, let's see if this works. It will take a couple of seconds to start up. And then we see 4 successful tests down there. So this worked. It's a very simple test though. We only checked if the test or if the application is actually starting up. So thus far, we had very simple tests, checking if components are created and so on. Let's spice it up and let's add a service to our user folder, the user service.ts file. In this file here, I will basically export my user service class as you know it. And in this class, I want to have a user object which I can retrieve from my component. So here I'll have my user, and this shall be an object where the name is Max. Just like that. That is all. This is a very simple service. And here my user component and ngOn I want to say this user equals, well, then I need to inject my service here. So let's inject user service here of type user service as we learned it throughout the course. Add the import up here too. And then I can say this user service user. Note that this is no asynchronous task or anything like this. It happens synchronously, but we do inject something. Of course, for this to work, we need to provide it. And here providing it on this level should be enough. So providers user service like this. With that, the application should work, but how do we make testing work? Well, we want to get the username from the service. So let's create a new test for that. We should use the username from the service because in our component here, we're assigning our user property to the user from the service. So that is what I'm testing here. So again, let's write the logic here. And I will basically copy that into that here so that I also get my app. But now I also somehow want to inject my service. So how do we force it to inject this user service into the component in our testing environment? Well, by creating a user service variable here, where I say fixture, debug element, injector to get access to the Angular2 injector, get, and now user service, which I also need to add as an import at the top. What this does is it uses the Angular2 injector, which exists and which is, well, part of this component we now created, and tells it, please get me an instance of this user service. This is how we do it. And as a side note, you can learn more about different ways of injecting this in the document in this article I will give you at the end of this module. So this is the user service here, and with that user service, I can now say that I expect my user service username to equal the app username. Like that. And if I save this, it will re-execute our tests and we should now see 5 successful tests, but we don't. So we can't read name of undefined. What went wrong here? Well, the following went wrong. We're getting this property from the service because we inject it. We do this in ngOn, but we're missing one thing which happens automatically in an app running in the browser, but not here. We need to run change detection to update our properties and so on. After running this, after injecting the service, now we see we get a successful test because now we're trying to access our username property on the component after we updated it. And we needed to update it because it isn't in the same state as at the beginning. We injected a service and got data from there, even though that happened synchronously, but it's still not the same state as in, well, our code here, where it is undefined at the beginning. Well, with that, now it would be interesting to see if our ngIf thing here works correctly. So we want to check if we see the username, if we are logged in, and if we don't see it, if we are not logged in. So for this, time to create some new tests, and we should display the username if the user is logged in, I'd say. So let's execute this code here then. And I can generally copy the code from the last test here. Though now I want to do something different. I also want to compile my code, or my template, so I will get access to the compiled template, I should say. So here I will access my fixture, the debug element, and there the native element, which is my template. And then here I want to check if, well, I expect my compiled template, I expect it to have a paragraph element, of course, and there the text content is expected to, let's say, contain the username. So app username, that should work, but only if we're logged in. So if I run it right now, we see it fails. It can't find it because we have please log in first in our text because we're not logged in. So we have to change this. I actually don't have to access my user service like this anymore. It will still get injected here, but I don't want to access it like I do in the test before. So I don't need to explicitly name it here. I don't need to retrieve it from the injector, I should say. It can be done by Angular 2 automatically. And then here, instead, I want to do something different. I want to access my app and set is logged in to true in this test, so that when I now save it, we now see 6 successful tests. Well, on the other hand, I should see something else than the username if I'm not logged in. So here we shouldn't display the username if user is not logged in. So here I will get rid of my app is logged in overriding. I will still detect the changes, but here I expect my text content to not contain this name, so not to contain. If I save this, it should rerun, and now we should have 7 successful tests, and we do. And this is how we can test a couple of things and see if our app behaves as intended here. With that, we got a basic introduction to testing components and services and when we inject services into components, but we haven't really talked about this async thing here, and our service thus far was synchronous. So there was no asynchronous task like we might have it when reaching out to a web server. Therefore, in the shared folder, I create a new service, the data service, and this service will now actually expose an asynchronous function which we want to test. So in here, I will also export this class, data service, and this should have a getDetails method. Now, getDetails will have a promise, the result promise, which is a new promise, and my IDE won't like promise here, so it will get red, but it will work, where we pass resolve and reject as arguments to the callback we're passing to the promise constructor. And then we basically set up a timeout which will expire after, let's say, let's make it 1.5 seconds. And here I want to execute another function, of course, where I simply resolve data. So I pass back a string holding data. And outside of this const of this promise, I will simply return this promise. So getDetails returns a promise, and this promise will resolve after 1.5 seconds. Now I want to test this. Back in the user component, which is where I want to use it, I will first provide the data service here, and I will set up a data property here to data, which of course is a string. And in the constructor, I want to inject it. So I will have my data service injected here so that the Angular 2 injector is able to do so. And keep in mind, we can always get the instance by accessing the injector as we did before. Well, back to the spec file here to write some tests. Thus far, we have tests using our user service, which is synchronous. Now I want to fetch my data asynchronously. So first, let's do a normal test and see if this works. But it probably won't work since I will name it. It shouldn't fetch data successfully if not called asynchronously. And this is not really a great test because here I'm testing features of the testing package and not of my app. But I want to show the difference between this way of setting up tests and using the async function here, which we'll use in a second. So right now we always pass the function as the second argument here, and inside of this callback I would then execute my standard code, get access to my application here, and now I somehow need to access this getDetails method, which happens asynchronously. The thing is, I don't necessarily want to execute the real getDetails method, because this method might reach out to a server, and in a real application you don't want to reach out to the server all the time when testing it. Instead, you kind of want to fake it, you want to override it, you want to create your fake implementation, which still is asynchronous but does something else, or does it at least not reach out and provide simply some dummy data the real service would also give you back. So therefore, I will create a new variable spy, and I will use spy on. And this is another function provided by the testing environment, so not an Angular 2 specific testing function. And here we first tell on what we want to spy. Well, the thing I want to spy on is the data service, which I can get access to, like I did here for the user service, by using the Angular 2 injector. So let's add it here. But now, of course, let's call it data service and get access to the data service. Add the data service import for that too. And then we use this data service to spy on the getDetails method there. You pass it as a string, but this name here has to match the method name you want to spy on. Well, with this set up, what I can do now is I can chain something with and then say return value. So we spy on, that means we get informed whenever getDetails gets executed. So this is what spy on means. We listen to it, and whenever it gets executed, when running a test, we won't execute it. Instead, we will return a value on our own. Now, the value we will return here is promise resolve data. Now, what this does behind the scenes is it will execute the code, the asynchronous code, but it will eventually give us back our own data and not what this asynchronous task would have given us. It will still run in an asynchronous fashion though. So what I can do here is I spy on it, I get this data. I can now run the change detection to update my component after I got this data here. And then I want to check if this worked. So I will say expect, and I expect my app data field to be undefined. Normally, I would expect it to be something else, because in my user component, here in an ngOn init, I will now use my data service to get the details, and then, this is here a promise, then use the data I get back to set this data equal to the data I get back. That is what I would normally expect to happen. So that once this promise resolves, the data the promise passes me is stored in this data property. Here in the test, I'm saying that I expect it to be undefined. And the reason why I do expect it is because I know that this will kind of fail. And I will come back to this in a second. And before doing so, though, we should set data here of type string to avoid compilation errors. So if I now test this, we get success. And that means it does not give us the normally expected result. The normally expected result would be to get data, right? If I now write this, you will see it fails. The reason for that being that it indeed is undefined. So I'm just writing the other case to have a success test here. But undefined is not really what we would expect at runtime. We would expect data to be undefined at the beginning, but to be data, since this is what we return here, a string of name or of content data in the end. So how can we test such an asynchronous task where the state changes during the runtime? Let's write a second test for this. I will copy the first one here, but here I expect it, so it should fetch the data successfully if called asynchronously. And here I will generally use the same code. I will adjust it, but I will use the async function here. That function we're importing from the testing package, the Angular 2 testing package, and I will wrap my callback with that function here. Now what this does is it creates a kind of an asynchronous testing environment for Angular 2. It fakes it it's not really asynchronous, but it allows us to run asynchronous tasks there. And Angular 2 is aware that there are asynchronous tasks and is able to handle them as if it would handle them in a real application context where they are indeed also asynchronous. To do this, I need to add one thing though. After detecting the changes, I need to use my fixture and execute when stable. This function on the fixture allows me to react to all asynchronous tasks are finished. So here I can then execute the then function of my promise, which takes a callback to be executed once it is done. And inside of this callback, I will expect something to happen. So once the asynchronous task has been finished, and there I expect it to be data. And now with that nested in there, I can now save this. And now we get 9 successful tests. Because now we're waiting for asynchronous tasks to finish. It's not really happening asynchronous. We're faking it here. Remember, we're returning our own value. But with async wrapping this callback, we're telling Angular 2, hey, we do have some kind of asynchronous tasks, even though the promise resolves instantly, it still is a promise wrapping some value and not resolved or not the value itself. So with async, we're now able to call when stable here and wait for our environment to stabilize, for all asynchronous tasks to finish, and to therefore successfully access the data at the state it would be in a real environment. We do have an alternative to using this setup here. Since it kind of happens synchronously anyways and only theoretically is asynchronous, you noticed we didn't wait 1.5 seconds here. We can also copy this test, copy it down here, and call fake async or use fake async as a wrapper. This needs to be imported from the Angular 2 testing package as well. What this allows me to do is, it allows me to get rid of the when stable function here, like this. So instead I execute expect and so on instantly, but I call tick in between. Now tick also needs to be imported from the Angular 2 testing package, and tick basically means in a fake asynchronous environment, finish all asynchronous tasks now. When tick is executed, asynchronous tasks are finished. We can finish them immediately since we resolve it immediately here. We don't wait 1.5 seconds. That is why we wrote it this way. We don't want to wait that time when testing. So we finish them immediately and we should have access to the data. So let's see if this works if I save this. Indeed, we get a successful test here too. And this is how we now also use fake async. So you could use either async with this setup when stable and then in the callback your expectation, or fake async. It takes the same time, it's just a different philosophy. Here you more like fake or behave like it was really asynchronous, and here you just use tick to say, yeah, let's go on. This is how you can use services and components. I picked this task or these two building pieces as they are very important and probably amongst the most complex, especially with the injection and asynchronous tasks. I hope this was helpful. Again, I do have a document where you can dive a lot deeper into that. I want to finish this module by having a look at isolated and non-isolated testing cases. Let's have a look at this and learn what this is. This is our example app, and as you can see, we got a user component and a user service, and both are connected because we inject the user service in the user component. Now let's say we have a reverse pipe, which reverses any string. That pipe can be tested isolated. We do have this Angular 2 package or these Angular 2 utilities you saw, testbed, async, tick, and so on. There are a couple of utilities in this package, and actually you already saw most of them. The others can be seen in the reference I'll link in the next lecture. But anyways, a pipe can be tested totally independent of Angular 2. Why? Because how does a pipe work? It has this transform function where you pass a string in and get a string out. No need to involve Angular 2 for such a basic pipe. You might have other tasks in your application where the same is true. If you get a service and in the service you get a method which only transforms some data or let's say doubles a number, well then you can test it isolated. You don't need the Angular 2 testing package for that. You can write a normal unit test. And this is what I'll show you at the example of a reverse pipe now. I will create the pipe in the shared folder and I'll create it manually. I'll name it reverse.pipe.ts. And in there, we of course export a class, which is named reverse pipe. And on this class, we attach the pipe decorator, as you learned it, to be imported from @Angular core. And there I pass an object where I give it a name of reverse. Well, and inside of this class, I therefore need to have the transform function. And this transform function expects to get a string, or the value, let's say, which is a string, and possibly some params, though I won't pass some here. Well, and then I can simply return the value, split it by, well, nothing, so that each character is separated. So split it by each character, basically. Call reverse on that. That's a normal function available on an array, and a string is just an array of characters. And then join them again with nothing in between joining them, so that each character is attached to the character before it without a white space in between or something like that. That is what my reverse pipe does. Well, and now for testing this, I can really write my own reverse pipe spec.ts file. Now, if we have a look at the user component spec file, how does a spec file look like? Well, if I copy it, which is a bit overkill, whoops, not here, I of course want to get rid of all the it statements except for one maybe, get rid of all these imports, and I can also get rid of the Angular 2 testing utilities because I don't need them. I also don't need the before each. There is no setup to be run before each pipe. All I want to do here, for example, is I want to create my reverse pipe, which is a new reverse pipe, and that is why it's called isolated. It doesn't depend on any other piece in my Angular 2 application. It doesn't even depend on Angular 2. And all I want to do is I want to expect reverse pipe transform if I pass, let's say, hello in there to equal, well, and then this should be OLLEH. That is all. And if I save this, we should now have 11 successful tests because this clearly should succeed. And we do see 11 successful tests indeed after rerunning ng-test, or if you still had it running after saving. This is an isolated test. Of course, you could have some pipe which depends on Angular 2 or something like that. And it really comes down to this question. Does the thing you want to test depend on Angular 2 or other pieces of your Angular 2 application? If yes, well then you get these testing utilities like testbed, which allows you to create components, access the injector, set up the module for testing, and so on. You got async, fake, async, and tick to, well, handle asynchronous tasks, and so on. In the lecture at the end of this module, you will learn more about other resources, about other tests you could write, other things you can test. If you don't have that, if you don't have a dependency on Angular 2 or other pieces in the app, well then an isolated test like this might be all you need. And with that, we had a good introduction to how testing here works, how we can use the Angular 2 testing package, the features it offers us to write our tests, to use services. And as I already said at the beginning, I could continue for a couple of hours here, but this is not what this course is about and not what I want to make this course about. It is a good introduction. With that, you should be able to dive really deeper into it with the article in the next lecture. You should be able to use your general unit testing knowledge you already have to take advantage of these tools Angular 2 offers you to create components, to access them, and so on. And with that, that is all I can do. I can encourage you, dive deeper into it, and I hope this introduction was at least helpful to understand how you might decide when to test the connection of Angular 2 and your component or whatever, and when to test it isolated, why unit tests are helpful in the first place, how to get started with the testing utilities Angular 2 gives you, and how to create these example tests we created here. See you in the other modules. Bye. Throughout this course, you learn a lot about Angular, of course, the framework, how to build amazing apps with it, and the many features it includes. Now, what's also part of Angular, and you therefore could also call Angular a platform and not just a framework, is the CLI and the entire infrastructure it gives you around your projects and around your code. Because the code, of course, is the heart. The framework allows us to build amazing web applications. But with the CLI and the project which is configured, and a lot of useful tools around the CLI and around your projects, you actually also can have a very easy and great time building, publishing, deploying, and managing your Angular projects. And that's exactly what we'll have a closer look at in this module. In detail, we'll have a look at Angular projects and the different configuration files again, so that we understand what we really can do there and what their role is. You will see how you can create and manage projects and many things inside of these projects. We'll take a look at something which is called schematics and builders, which is a set of pretty cool features which is included in Angular projects and the Angular CLI, and which is worth knowing about. We'll have a look at projects, apps, and also how to build libraries, because thus far in this course, of course, you learned how to build web applications with Angular. Now, what if you wanted to build a library that can be used in multiple projects? That's also something we'll have a look at. And we'll also have a look at a couple of other things, for example, at deployment, browser support, and much more. So let's dive in. And to dive in, let's create a new project. Now for that, make sure you're using the latest version of the CLI with npm install -g add Angular CLI at latest. On Mac and Linux, you might need to add a sudo in front of this. On Windows, you don't. Now, once you got that installed, once you got that latest version installed, let's create a brand new project. And you know how that works with ng-new. Now, actually, before we create such a project, let's hit enter here without entering any name. Now what you'll see is that if you do that, you actually also are prompted for a project name. So you can also use the command in this shorter way. Now let me skip this or cancel this with Ctrl+C for now and type ng-new --help. The --help flag can be used after any command to learn more about the command and the different configuration options you have available. So in this case, if I hit enter, you see there are a bunch of flags we could add after the command. So we could type ng-new, some name of our choice, and then for example --collection or --commit. And here you see a description of what these configuration flags do. Now these flags change over time, new options are added, some options are deprecated, so going through all of them doesn't make a lot of sense here, but there are some which I want to draw your attention to. This here, for example, will become important later, create application. It's set to true by default, so you only need to add it if you want to disable this. And right now this doesn't make much sense to us, but we'll later see why this command can become very important and useful. It can become important if you want to manage multiple applications and libraries inside of one Angular CLI managed project. Again, more on that later. Dry run can also be interesting if you just want to see what the CLI would do with your command, with the ng-new command here, without actually creating the content on the disk. This might sound like it doesn't make much sense, but if you're passing multiple configuration flags, adding --dry run will spit out what the CLI will do thereafter, so that you can verify whether you will get the project you want without actually going through the full setup process and writing everything to the disk, which can be nice at times. With inline style and inline template, you can set up whether new components you're going to generate will actually start with inline styles or inline templates or with external files. This can save you the hassle of setting this for every newly generated component individually. The prefix command allows you to configure the default prefix every new component you generate with the ngGenerate command will have. Now, let me also note at this point that many or most of these options actually can be changed in the existing project later too. And I will show you where to change them and where to generally adjust the configuration in a separate lecture, of course. Routing allows you to specify whether you want to start with a routing module and some initial routes. Skip tests allows you to define whether newly generated components and services and so on will have testing files next to them. Skip install allows you to create a new project with the files written to the disk without the npm dependencies being installed. This speeds up the creation process, and you can then always install the dependencies manually later. So these are some interesting options here, and ng-new-help allows you to go through them in detail. In addition, also check out the official documentation, and that is true for all the things I will be showing throughout this module. I will also reference the official docs from time to time. There you find the latest up-to-date information about Angular, the CLI, the different configuration files it uses. And for example, here for the CLI, you find a list of all the commands it supports, the aliases, so the shortcuts you could use. And of course, then if you click on a command, you find detailed information about this command, what it does, and which options you can set there. You see a bit more information about the different configuration options here. So definitely also check out these pages here if you want to learn more about the CLI in general or the individual commands. With that, let's create a new project here. So here I'm going to write ng-new angular config and simply hit enter without any additional flags. Now then here I get asked whether I want to add routing, and I'll choose N for no here, and I'll choose CSS as my, well, style sheet format so that I don't want to use SAS or SCSS here, which you could do though. You can choose that, and then you can write your styles with a style preprocessor like SAS. Now, since I didn't choose try run or skip install, this creates the full project, installs all dependencies, and writes everything to the disk. And I'll be back in a new lecture once this is finished. So here is the project which was created. And I did open it in Visual Studio Code, which is a free IDE which I can strongly recommend for Angular or for web development in general. You find versions for every operating system, and you can install it, and you should see something like this. Now, I tweaked some settings there. For example, I installed a special theme here. I installed the Darkula theme, and you can install extensions by going to the extensions area here under View Extensions. And there, for example, if you search for Darkula, you can find that theme I installed, which of course is totally optional. I also installed the Material icon theme to have nicer file icons, which is also optional. And this is also optional, but my recommendation, I also installed the Angular Essentials extension pack by John Papa, which installs a couple of extensions that make your life as an Angular developer much easier in Visual Studio Code. So I do recommend this Angular Essentials extension. After installing all of those and activating them and reloading, you should have a project that looks something like this. Now, I did add a .prettier.rc file to configure Prettier, which is the file formatter I'm using, and I set it to use single quotes here, basically just how it should auto-format my code. Auto-formatting is something you can do with a keyboard shortcut here. If you search for Format Document, this shortcut will auto-format your code with a tool of your choice, in my case Prettier, which is part of that Angular Essentials package, and this will make your code easier to read, fix simple errors, and simply give you a better time as a developer. This is the starting project therefore, and this is a typical Angular project as it's generated by the CLI. I haven't changed anything in there. Now, of course, you know this project, right? We worked in a project like this throughout the entire course. We get the source folder with the app folder, and in there we can add our Angular components and services and directives and everything and write our Angular app. Now, we'll not focus on creating an app in this module. Instead, we'll focus on the project and what you can do with the app, where the CLI can help you, how you can deploy this, and so on. So therefore, now that we have this basic setup and we understand what we do have here, we also see we have tons of configuration files here. So why don't we take a closer look at those to fully understand what the CLI gave us there? So it's configuration file time. we do have a bunch of files, and let's go through them to understand what we got here. Now, please note, over time, some files and the content of some files can change, but the general idea, of course, is the same. Now, let's start with the editor config. This is a file which in the end is picked up by some editors, by some IDEs, like Visual Studio Code, and it basically tells the editor how to, for example, do indentation in this project so that it can override your user default settings or the IDE default settings and make sure that the code in this project actually is the same for all users across the entire world, no matter which editor they use. So this is simply a code style thing. This, of course, does not affect the way Angular works or how you write Angular code. It really just influences how the code looks like and is formatted. NgRx, by the way, is kind of related to this, but is not part of a default Angular project, at least not at the point of time I'm recording this. This is a file I added here to tell this auto formatting tool, Prettier, which I'm using behind the scenes, to basically use single instead of double quotes. So in the end, this should work together with editor config. Now, I skipped gitignore. Gitignore, of course, matters if you're working with Git. Git is a source control tool. It helps you create code snapshots and go back to older code snapshots if you mess something up and so on. And you can learn more about Git with the attached Git starting resources. And gitignore is a file which basically tells Git which files it can ignore, which files you don't want to manage with Git because they will be regenerated frequently, like node modules, which you generate by running npm install, and so on. Now, the AngularJSON file is a bit of a more complex file. This manages your entire project configuration, and I will come back to that in a second. Let's skip it for now, and let's move on to the browsers list instead. The browsers list file is an amazing file. This configuration file is picked up by the Angular CLI when you build your project for production. And it basically tells the Angular CLI which browsers you want to support with your project. Now, the Angular CLI takes this information about which browsers you want to support. In my case here, for example, that I don't want to support Internet Explorer 9 to 11, which you would have to change here. Remove not, as you see, if you do want to support it. And the CLI will then use this information, for example, to adjust your CSS styles and prefix them to support all these browsers, and also to load the right polyfills and create the right code bundles that include those polyfills, and more on polyfills and what the CLI does with them later. But this really allows you to control which browsers your application supports. And of course, you want to be as restrictive as possible here and not as open as possible, because that will ultimately lead to less code which your users have to download. So if you know you don't have to support Internet Explorer 9 to 11, well, you should not support it. The Angular framework, by the way, does support those browsers, but still, excluding them can make sense to ship less code. The Karma config file here, that's a file which is used for testing in the end, for unit tests, where the Angular CLI uses Karma behind the scenes. And unless you really know what you're doing, you should leave it the way it is. It allows you to fine-tune how your tests are executed and so on. Package log.json is a file which is generated based on your package.json file, which in turn is a file that manages the packages your project uses and the versions of those packages. Now, with my current theme, I see that's a bit hard to read, so let me quickly switch this to the default Dark Plus theme, where this is a bit easier to read. Now, what do we have here? Now, this package.json file has a couple of scripts we can execute. We can also use just the ng command, though, so we can ignore this. Behind the scenes, this uses the ng command. More interesting are the dependencies and def dependencies. I did talk about them earlier in the course already. In the end, these are the third-party packages our project uses to build our application and to run successfully. That includes all the different parts of the Angular framework, RxJS for observables, and then some dependencies of the Angular framework. But we also got some development dependencies, which are tools we only need to build our project. So this is not code which will be part of our running application. These will be tools that help us build the application efficiently. That's the Angular CLI, and then a couple of tools used by the CLI for compiling and optimizing the code. We got Karma for testing, we got TypeScript for compiling TypeScript to JavaScript, and so on. Now, you use this file by running npm install in the terminal or command prompt, navigate it into your project folder, and here I'm just using the built-in one, which you get with terminal, new terminal. And this will basically create that node modules folder based on the dependencies mentioned here. It will also generate a package.log JSON file, which stores the exact versions of your third-party dependencies. Because here in package.json, you specify some minimum requirements and some flexibility. And then once you do run npm install, you log in certain exact versions, which are saved in here. And last but not least, we got the tsconfig files down there. Now we see three tsconfig.json files. This configures the TypeScript compiler. And if you took my Understanding TypeScript course here on Udemy, which of course is not a hard requirement, you know what you can set there. The official TypeScript documentation, of course, is another great place. Now, unless you know what you're doing, you can leave the defaults here. But there you can set certain interesting things. For example, you can add strict mode by setting this to true, and now TypeScript will be way more restrictive regarding what you're allowed to do in your code. This can be a pro and can be a con, depending on which kind of code you're writing, how many third-party packages you're using, and so on. It can force you to write cleaner code, but it also sometimes means that you have to find workarounds to get something to work in TypeScript, which you know will work, but where TypeScript doesn't fully understand your code. So here you can configure TypeScript, and you have this base configuration file here, and then two specific configuration files which extend this base configuration file for testing, for the testing environment, and for the real app compilation. And there some detailed settings can be set for the concrete compilation of the app. Now, what you'll also see, by the way, is one extra flag which is not default TypeScript, and that's the Angular compiler options. This is picked up by the Angular compiler, which is not the TypeScript compiler, which is the compiler that kicks in after TypeScript compiled your TypeScript code to JavaScript. The Angular compiler will then compile your Angular application, so your compiled JavaScript code and your HTML templates and so on, into instructions that can be executed at runtime. So instructions to insert buttons in the DOM, to add event listeners, and so on. So the real DOM instructions that the browser understands. That's what the Angular compiler will do, and you can configure that compiler as well. And unsurprisingly, again, the official docs are a great resource here. Under Dev Workflow, AOT Compiler, Angular Compiler Options, you find detailed information about the Angular compiler and which options you can set there. Now, as always, mostly the defaults will work for you, but you can check out this detailed documentation here to see whether you need to set some other setting there to build your Angular application the way you want. And last but not least, we have the tslint JSON file here. This simply is used for linting, which checks your code quality and basically tells you whether you're following best practices and you wrote your code in a good way. If you get errors here, these are not real errors. These are just improvement recommendations on how you could improve your code. Though, of course, sometimes there also just is a recommendation which you don't have to follow, because not all these recommendations are best practices. Some simply are opinions which you don't have to share. So this is what we have here in terms of configuration files. Now let's again think about some Angular CLI commands before we dive into that missing configuration file, the AngularJSON file. So before we explore this angular.json file, let's see which Angular CLI commands we can use inside of our project. We used ng-new outside of it. Now we can basically use all remaining commands inside of it. Now you can type ng-help here, not ng-help, but just ng-help to learn about all the commands. And of course, as mentioned, you have that page in the official documentation. There under CLI commands, you also see all the commands. Now, some commands are really niche commands which you'll rarely need, but of course there are also some commands which you'll need all the time. For example, ngserve. You know this one. It serves your application. Now, just as before, if you add --help thereafter, you get details about this command. And you can see there are quite some flags you can set. Now, not all these flags are required, of course. The defaults work just fine. But for example, you can set a port flag here to use a different port than the default of 4200. You can add --prod to actually serve your app in production mode to have kind of an idea of how it will work once you do build it for production. This, however, is not something you can use on a real web server. It's not production ready. It's just a preview of how production mode will work. You also have --open. This will actually tell the CLI to not only serve the app, but to open the app in a new browser tab once it's done serving it up, so that you don't have to manually open it there. And so on. There are a bunch of configuration options you can set there. Again, most of them are rarely needed, but if you do need them, well, here they are. As mentioned, over time they might change, but still, this command and the official docs here are a great place to learn more about them. Now, besides ngServe, we also got ngGenerate. And ngGenerate, with --help, allows us to generate things in our application. Here are the things we can generate. You saw a couple of them throughout the course, like components, directives, but you could also generate guards or services. You could generate pipes or modules, interfaces and intersetters for the HTTP client, an application, which is something I'll come back to, and some niche things like a service worker or a web worker. You also see additional flags here, but to see all the available flags, you should be a bit more specific and, for example, say ngGenerate component --help to see how you can configure the generation of a component. And there you see that there are, again, a bunch of configuration options. Now, this might, by the way, be overwhelming by now, but keep in mind that you don't have to learn those by heart. The defaults will work just fine in most situations. Just when you find that a default doesn't work for you, you might want to look into these configuration flags here and see whether you can change the defaults to give you the component or whatever you're trying to generate in the way you want it. For example, to not use inline styles, to not use inline templates, to change the default prefix which is added, to not generate test files, and so on. And of course, this does not just exist for the component generation, but for pipes and so on. So ngGenerate, of course, is an important command. nglint uses this tslint file I mentioned before. It will now basically go through your entire setup and tell you if you have any linting errors. And here everything passed, but for example, if I go to the app component here, and I do remove this prefix app root, and I would lint again, it should tell me about this. So let's wait for this to finish. And indeed, it found a lint error, and now it tells you that in the app component file, in line 4 here, the selector should be kebab case and include a dash. So it tells me that I'm not following this recommended practice of naming my components like this. So that's linting, and you can always use this lint command from time to time to check your code quality. ngbuild, of course, is also an important command to build your project. With --prod, you build it for production, so you optimize it as much as possible. And you also saw before in this course, in the deployment section, that this will generate a dist folder where you find your generated project files, which you then can put onto a server to, well, serve your application from there and to really serve your application to all the users out there in the world. So here is this dist folder. Now I will come back to deployment a little bit later. You learned how you can deploy it, but actually there also is a different way of deploying with help of the CLI, and as mentioned, I will come back to that. For now, let's ignore it. So these are the CLI commands, and again, I pointed at it before, but check out the official docs to learn about all the commands and all the configuration options. There are some commands like ngupdate and ngadd and ngdeploy, at which we'll have a closer look in this module though. Before we do that, let's analyze the AngularJSON file though, because that configures our project in the end, and thus far we didn't have a closer look yet. So what's inside of the AngularJSON file? This is a file which is generated automatically when you generate a new Angular project, and this is used by the CLI behind the scenes to run different CLI commands and to know how to run these commands. Basically here, you can set some defaults for all these flags you could otherwise add manually to every command. And of course, setting defaults is more appropriate because it saves you the hassle of having to add all these flags all the time. So what do we have in there? Now this Angular JSON file uses, well, the JSON data format to, well, store its information, and there it follows a certain schema which is developed by the Angular team, and it's stored in this folder. Not something we should change, just some information. The version here, you can leave this the way it is. This is just the version of this file format here, basically. Interesting is the new project root entry here. This controls where new projects in your project here in the end are added. This might not tell you much. What are projects? We'll come back to that. It turns out that you can manage more than one project in an Angular project folder. And thus far, throughout the entire course, we always had just one project, one app. Well, you can manage more, and I will show you how later in the course. For now, let's go with that one project. So next we have this project's entry, and there you have one nested entry per project. Now, as I mentioned, we have one project here, and therefore if I make this smaller, we see there only is one entry. And that also, as you see, is the default project against which our CLI commands will run. If you add multiple projects, again, something I will show you later, then you could specify here which project the CLI commands like ngGenerate and so on will run against. But here we only have one, so let's expand this again. Now we see which project type this is, and here it's an application. Now you have multiple types here. You have application and library. And by the way, you get auto-completion here, either automatically or by hitting Control Space. The default is application, which is a regular Angular web application, but you could change this to library, and I will show you what a library is later in this module. For now, let's leave it at application. Then we got the schematics here. Schematics doesn't tell us much, but schematics actually is a really cool feature of the Angular ecosystem, you could say. I will come back to what schematics are. For now, let's ignore it. Root basically tells the Angular CLI what the root folder of this project is, and here it's the, well, folder here itself, so the entire folder, and then where our source files live in. And you could change this if you wanna store your code in a different folder than source, but I'll of course leave it at source, but you can change this. Here you set the default prefix, which is added in front of every component. So if you don't want to use app, you can use a different one here. And then you get this architect command here, this architect area, which is the rest of our project-specific settings. Now here, the different commands you can execute can be configured. For example, the build command. There you see which tool gets used under the hood. And this is a tool which is part of the Angular Dev Kit package, which is one of the third-party dependencies we have added. And this basically is just the tool, the configuration, the code, which knows how to build an Angular project. So which steps to execute and so on. And this tool can be configured with options. These are options you also, at least partly, can set with these extra configuration flags on CLI commands. So on ng build --AOT, for example, controls that this should be built with ahead of time compilation. And by default, this is true, so you would only need to set this if you want to set it to false. But you can set this with a flag, or if you know this should always be the case, here, for example, with that AOT option. There you see the default is true, but if I set this to false, now all builds would be done with the AOT compilation turned off. We see where the project should be output into, and here we see that is the dist folder and then the Angular config subfolder. We see what our root entry file is, and you could change this, of course. What the root entry file for the Angular application is, and you could change this as well. Where the polyfills are managed, you can change this as well. You can change everything here. And what your project-specific configuration file, tsconfig configuration file is. Assets allows you to configure which files or folders should be copied over in the output. In the source folder, we have an assets folder, and there I have nothing in there. But if I would store, let's say, an image in there, which I always want to be able to use in my application, I could store it here, reference it from inside my components, for example, by rendering an image tag there, and it would be copied over into the dist folder so that it is available in the served app as well. The styles node is one we used throughout this course project to include Bootstrap. Here you can set up which CSS files, either your own ones or third-party package files, should be included in the application by default. Of course, every component has its own style file, as you learned, but if you have some global application-wide styles, you would add them here, and these style files are also then used and evaluated by the build workflow, and in the end, optimized and copied over. For example, here you find the copied over style CSS file, which is empty for this default project, but where you could add your default styles. Here is the file where you would add your styles. So that is something. And if you have some scripts, some JavaScript files which should be copied over, you could specify them as well. Now you might not need this very often because you will write most of your logic inside of your Angular files, of your Angular components and so on. But if you would be using a third-party package like, let's say, Google Maps or Lodash or anything like this, where you maybe downloaded an already optimized script file, well, then you can just specify it here and it will be copied over and included in your application. Now, a side note already, more about all these configuration options, of course, can again be learned in the official docs. There, under Workspace Configuration, you learn about all these settings in great detail and what you can set there and why and in which different ways you can configure things here. So in addition to watching this lecture, this is a resource you also might want to check out to learn everything about what you could possibly do here. Now, besides the options for the command, you also find configurations. This might sound like it's the same, but the difference is that options basically are default options which are always applied. With configurations, you can configure different environments for your options. So you could say, I want to have some steps or some options which are only taken into account if I build for production, for example, or if I build for development. So here we got some production-specific settings. For example, that a file should be replaced. This is in the environments folder. And in the end, this simply tells the CLI that it should swap the environment TS file for the environment.prod TS file when it builds for production. This allows you to specify different environment variables in the end for the different productions you're building for. So let's say you're using Google Maps and you have a Google API key, and you have one key for development and one key which is more locked down and restricted for production. Then you would store the development key in the environment TS file and the production key in the environment.prod TS file. And thanks to this setting here, once you build for production, which you do with ngbuild --prod, this configuration will be used and the files will be swapped so that for your production code, your production key will be used. A little side note, --prod is just a shortcut to target production. The long form is --configuration equals production. Now, for production, this doesn't make much sense because you have the shortcut, but you can add your own configurations here, like a staging configuration. You can add it and override your own options here if you want to. Whoops, staging. So now here, I could set my own options, like AOT to false if I'm building for staging, and I could target this custom option with configuration staging now. So you can add your own configurations there besides the default ones which are included. And as you just saw here with the AOT example, you can override any default options configured up there. So these defaults are always used unless they're overwritten down there. And here you see for production, there are quite some overrides or some extra settings. For example, here we have the maximum amount of optimizations and so on. And you can, of course, fine-tune and tweak this all to your personal likings. You can add more environments as you learned, and you can configure which options are adjusted in which way for which environment. So really, really powerful. Now, this is all still for the build command, right? Now, let's close this and move on to the serve command. Now, there you see options is much shorter because here we have one main option where we basically tell the CLI that for this serve option, we want to use the build option. So all these options should be used for serve as well. And then we also have this production specific configuration if we would run ngserve --prod. Now, in case you're wondering how you should ever know which options exist, for one, as I mentioned, you get auto completion here. If you add new empty quotes, you see which settings you can set there. And in addition, the official docs I mentioned guide you through that. and you can learn more about the different options there. Now then we got an option for internationalization, which I'll ignore here. We got the test options for running your tests and how your code should be compiled and used there. We can configure linting, end-to-end testing, and then we're done. And this is the Angular JSON file. It can look intimidating, but as always, the defaults are fine for most use cases. And if you need to tweak something, you got auto-completion. You can check out the official docs to learn more about that. Now, I want to come back to something I mentioned earlier. Schematics, because it turns out that schematics, this term, is super important and helps us build amazing applications. What are Angular CLI schematics? Schematics are a powerful tool or a concept introduced by the Angular team, or specifically by the Angular CLI team. Schematics are basically blueprints which certain Angular commands can pick up. And for example, you can have schematics for NgGenerate to generate new building blocks in your app, like components, for NgAdd, which we hadn't had a closer look at yet, for adding, for example, libraries or certain capabilities to a project, and NgUpdate for keeping your project up to date. You can build your own schematics. Angular has some built-in schematics, which you have unlocked by default in the Angular CLI, and third-party packages can also add schematics, and that's what makes this feature powerful. Now, adding your own schematics, of course, is super powerful because you could build your own blueprints, your own NgGenerate command for generating, let's say, a specific version of a component, which you need all the time. But let me also say that building your own schematics is not trivial. If you search for Angular schematics, you will find an introduction on the official Angular blog and also something in the official documentation. And there you also have this offering schematics part where you learn how to build your own schematics. It is fairly introductory, but it might be a nice start. If you want to learn all about it, it will be a lot of trial and error though. And I can also recommend checking out some third-party application schematics, because that's what I now want to focus on. You might know Angular Material. It's a third-party package, actually also maintained by parts of the Angular team, but totally optional. It adds components, so pre-built components, to your Angular app, which follow the material design spec. A material design is a design language invented by Google. It looks the way this page looks like. Now you can check out components here and see which components this offers, and this is of course not the focus of this module here. But there you can get nice pre-built components, which you can then easily drop into your application to use them there. Now if we click on Get Started, we see that we can run one simple command to add Angular Material to our project. Now let's copy this command and give it a try. Let's head over to our project, and there I will run ngadd @angular/material. And Angular Material is not the only package which supports the ngadd command. Every third-party package can support it, no matter if it's built by the Angular team or not. And there are a lot of third-party packages out there, for example Ionic, which do support it. Now to support it, these packages need to include certain configuration files in their package source code in the end, and ngadd will look for these files, and if it finds them, it is able to run. Now these files, which these packages have to include, then tell ngadd what to do. And let's see what ngadd does with Angular Material. Let's hit enter, and now you see as a first step, it installs packages through npm. Now this is not all it will do though, but it's one part of what it does. It will install all packages you need to install to use Angular Material. That's the Angular Material package itself, but also some third-party dependencies this package needs. Then some packages or some tools might prompt you for certain choices you have to make. Not all. Some have some default steps which they always execute. Here, for example, we can choose a default theme with which we want to start. And here I'll go for Deep Purple and Amber. We can here also choose if you want to use Hammer.js for gesture recognition, and I will choose yes. Also add browser animations with yes, so that we have all these nice animations, and hit enter. And now you see it again updates the package.json file because it now installs more dependencies. And that's the interesting part. It did not just install some packages, so it's not just a replacement for npm install. It also updated some other files. It updated the main.ts file, the app module, AngularJSON, the index.html file, and styled CSS. So why don't we have a look at all these files to understand what NgAdd did? And let's start with main.ts. In main.ts, you see it added an import for Hammer.js, which is a third-party package that helps us with gesture detection. And that is it actually. In the index.html file, you see it included some Google fonts, the material icons in the end, and the Roboto font, which it uses. So that is an adjustment it made there. In the app module, if we have a look, there it actually added the browser animations module from Angular animations, because some Angular material components use animations, and of course those animations should work. In the style CSS file, you see it set some default styles for your website, like a default font, for example. And in AngularJSON, there, let's see what it changed there. There you see that, for example, under the build command, it now also includes our theme styles, so that our theme is picked up when we build for production. So that's the NgAdd schematic. Pretty useful for third-party packages that support it, because it does not just install dependencies in package.json, it also does this, but not just. Instead, besides doing that, it also makes a couple of adjustments specified by the third-party package that need to be made so that you can immediately start using this installed third-party package. Now, I did mention ngGenerate and ngUpdate as well. What do these schematics do? Now, let's start with ngGenerate. We know ngGenerate, right? We can use it in any Angular project. That is because Angular and the Angular CLI has some default blueprints included. For example, for generating a component, for generating a pipe, a service, and so on. So these are basically schematics or support for the ngGenerate schematic that is already built in. But you could add your own, and third-party packages can also add their own, not just for ngAdd, but also for ngGenerate. For example, with Angular material installed here, we can run ngGenerate at Angular/material, so basically the name of the schematic provider. By default, if you leave this empty, it's the default CLI, the default Angular setup, but you can override it and use a different one, in this case the Angular material package, colon, then a name of a supported schematic, and there, for example, nav. And of course, in the official docs of Angular material, in this case, you learn all about the ngGenerate schematics it added and you can use. So here we can use nav, and then a name where we want to create our, in this case, navigation setup. And if I hit enter now, this uses this generate schematic provided by Angular material, and it adds a new component. So under the hood, it probably uses ngGenerate component, but it adds a new component which is not empty, but which has a different default blueprint. In this case, you see it has a blueprint where we have a side navigation controller, a toolbar, a button, and then also can show some content here, like maybe in a main block, simple H2 header, this works. And now let's include this main nav component here in app component. Let's use main nav like this. Make sure that in app module, this was added to declarations. And if we now run ngserve, you will see a nice navigation which works out of the box using Angular material components thanks to this custom schematic, this ngGenerate schematic added by the Angular material package. And you could build something like this on your own as well if you wanted to, but as I mentioned, a lot of third-party packages support it. So this adds on to the default schematics you already have in an Angular project. And of course, here I got an error because it's not main nav. Of course, it's app main nav, right? We can, of course, check the deselector here. So a little oversight from my side. Let me fix this in app component. And after fixing this, if we visit localhost 4200, we get this nice little application here where, of course, not much is happening, but where we now could build up on to build an application. So this is the NgGenerate schematic and what you have built into the CLI and the default project, and how third-party packages as well as yourself could add new blueprints to it. Now, besides NgGenerate, we also have NgUpdate. And NgUpdate is one of the coolest commands you can find. Of course, you want to keep your application up to date, and thankfully when Angular releases a new version, typically not everything changes. So typically updating is fairly trivial. Still, you might have to update a couple of dependencies in package.json, and maybe there are one or two smaller adjustments you need to make in code. Maybe very simple ones, but still repetitive ones, like adjusting a certain import, adding a new setting on a decorator, something like this. Now, NgUpdate can be executed like this in a project, and it will analyze it and tell you if there is something that needs to be updated. And for that, it basically checks every package which supports this schematic. Of course, all Angular packages support it, the Angular CLI itself supports it, and for example, some third-party packages, like Angular Material, also support it. Now you see here, everything is up to date for me. But if something would not be up to date, it would show you a table and tell you how you can update now. For example, then you can run commands like ngupdate at Angular core, at Angular CLI to update the Angular framework packages. This will actually target all packages, not just the core package, and the Angular CLI package to bring it up to date and run any migrations, so any adjustments that might need to be made. So this command makes updating super simple. And again, if you run just ngupdate, you will see a table of commands you should run in case your project is not entirely up to date. So ngupdate is a command which is worth running after every new Angular version that was released to quickly bring your project up to date and ensure that it works with this latest version. Manually updating wouldn't be that hard, but of course with ngupdate it gets even easier. And these are the three important schematics we have here. Now we also have something which is called builders. Now what's that? We explored schematics, now we also have builders. What are builders? Schematics basically are the tools you run to add something to your project, be that a third-party library, or with generate a new component, or maybe also just an update. With builders, you can, well, build your application for different environments. There are some built-in builders, ngbuild, ngtest, nglint. These basically all execute your code, compile your code, analyze your code, and then, for example, optimize it for production, run tests on it, or simply tell you how good your code quality is, so you perform certain build steps there. There also is another builder, and that is ngdeploy. This takes it to the next level. It will also build your project for production, but then also already go ahead and deploy it to a certain host. Of course, only some hosts are supported there. It's basically like with ngadd. There needs to be a third-party package or tool which supports ngdeploy so that you can deploy to a host. These are automation commands which you also can customize either by writing your own builder or deployment builder, which is pretty advanced, or by hooking into the configuration and adjusting those builders. Now let's take a closer look. Now, as always, the official documentation is a good place to go, and there you will see under deployment you can learn more about deployment and also about ngdeploy. Here under automatic deployment with the CLI, you can learn more about that. And here you also see the currently supported packages or services which support the ngdeploy command. I'll come back to that. So this is something you can look into. And of course, something we already had a look at in AngularJS, you can configure some of these builders like the ngbuild command. Now, we had a look at ngbuild and ngtest throughout this course. We saw nglint earlier here, and I talked about this configuration, so that's something we covered. Let's focus on ngdeploy therefore. As mentioned, you can either, of course, deploy manually, as we did it in the deployment section, or you utilize the CLI if you plan on using one of these services that supports the ngdeploy command. And here I want to use Angular Fire, which in the end simply uses Firebase under the hood. Angular Fire is a package that makes working with Firebase way easier, not just when it comes to deployment, but also when it comes to interacting with the database and so on. But we didn't use it in this course because it's not a Firebase course. I only used Firebase as a dummy backend. Still, I want to show you how this ngdeploy command could work. So first of all, we need to add Angular Fire to our project. Why do we need to add this? Because only after adding this, the deploy command supports Angular Fire. How would it otherwise know that it can use this, right? So we first of all have to ng-add Angular Fire, and just as with Angular Material, this will not just install the package, but also make any adjustments which are required and install any other dependencies it might need. So let's wait for this to finish. Now you'll see as part of me installing this or adding this, I'm asked to select a Firebase project. And indeed here you need a Firebase project. You probably do have one if you followed through this course. If you don't have one, make sure you sign into Firebase. For that you need a Google account. Using Firebase then is free as long as you stay within certain boundaries, which are quite generous. So sign in there and create a new Firebase project. Once you created that, rerun ng-add Angular Fire and choose this command. Now important, if you're getting any errors here, you also might want to install the Firebase tools globally, Firebase-tools on Mac and Linux with a sudo in front of it. And once you did install those tools, run Firebase login to log into your Firebase account, and thereafter try ng-add Angular Fire. Now with that, this will add a couple of configuration files here, some Firebase configuration files. And now the neat thing is we can simply run ngdeploy now, and it should automatically pick up Angular Fire as a deployment option. You see it now compiles the code because it runs the entire build process in production mode. What we normally would do manually, it does this here as well. But then it will not stop thereafter. Instead, it will take the build assets, the build files, and ship them onto a server. So let's wait for this to finish here. You see it finished building this. We can ignore the warning. And now it's uploading the files to Firebase, to this Firebase project. And once it finished, it also generated all the hosting configuration files here. Once it finished, we get a URL here, which we can enter into the browser. And there we see our simple Angular application. Now you can then administer this application both with this configuration file, the Firebase JSON file, and you can always redeploy it by running ngdeploy again. Or of course also from inside your Firebase console, and there you could also connect a different domain with it if you wanted to. So now that we talked about deployment, let me come back to the browsers list. I mentioned that this is important for telling Angular which browsers you want to support, and this of course is related to deployment. Angular will take the information here to auto-prefix your CSS code correctly, but also so that it knows which polyfills to load and which different versions of bundles it should generate. Now what do I mean by that? Angular has a built-in feature called differential loading. Now, we have our Angular app and we're hosting this, let's say on Firebase or AWS S3 or any other hosting provider, no matter if we used ngdeploy or not. We're hosting it somewhere. And now our app hopefully gets visited by users. We might have user A who has a modern browser and user B who has a legacy, so an older browser. Now the thing is, user A with a modern browser, let's say the latest version of Chrome or Firefox, needs no or less polyfills. All the features we use will work there just fine, and therefore we could ship a smaller code bundle to the user because our code doesn't have to be compiled down to super old versions of JavaScript, and we might not need any or all polyfills, so these packages which enable certain features in a browser. User B, on the other hand, needs a version which is compiled down to way older code, and he or she needs all or at least more polyfills added, so a bigger bundle needs to be shipped. It is what it is. The problem is, of course, we can always ship a bigger bundle, so that we support both B and A. If we always ship the most optimized and smallest bundle possible, we ignore user B. There, this just won't run. With differential loading, we do both. The Angular CLI actually produces multiple versions of your app when it builds it for production, you could say. And it produces a small code file, which runs first when a user visits your page to identify which browser this user is using. And then this small initial code file determines which bundle gets served to the user. So with differential loading, a user using a modern browser has to download less code than a user using an older browser. And this gives you the best of both worlds. You support all users, but you make sure that every user just has to download the code it really needs. And this is built into Angular. In our dist folder, we actually see two versions of every file, right? Two main, two polyfills, and two runtime files. And you see the names are different. ES5 basically is the version for the users with the older browsers. ES2015 sounds similar, but it's totally different, uses way more recent JavaScript and therefore also will be smaller. For polyfills, it's the same. Of course, here they both look very cryptic and large, but actually the more modern version will be smaller, and the same for the runtime here. So these are all files that you deploy, and they will be executed automatically. In index.html, indeed, the runtime file executes first, and there it then decides which other files it needs to load. So that's how this works. So this is this differential loading feature which you get out of the box. And you do partly configure it here with the browser list. There you tell Angular which browsers you want to support, and this tells Angular how it should build and optimize these different bundles. In addition, you have a setting in tsconfig.json where you specify the target JavaScript version you want to compile for. And here it's compiling for modern JavaScript. If you set this to an older one, then you force all users to use this older one. So differential loading really just is a feature to be aware of, not something where you need to do much. You have it out of the box, and this allows you to ship code that works for all users but does not force all users to download all available code. Also, one word about polyfills. You got this polyfills TS file. Now, crucial polyfills like this one are included by default, simply by having this import statement here. Angular will do the rest. If you are using certain features, like let's say animations, and you need to support browsers which don't natively support them, specifically Internet Explorer, Edge, or Safari, then you would need to comment this in and run this npm install command to make sure your Angular animations also work in those browsers. So it always comes down to which browsers you want to support. And you see detailed instructions here inside of this polyfills TS file. So this is how you ensure that your app works for everyone and how you automatically take advantage of this differential loading. Of course, as always, you learn a bit more about this here in the official docs. Under deployment, you can learn more about differential loading and how it works and why it's awesome. And with this, we're done with managing our application. Now, there is so much you can do, but you hopefully got a good overview of the different features and the ecosystem here. Now, I want to come back to one thing I mentioned earlier, multiple projects. Now, I mentioned that inside of an Angular project, or folder, I should say, you can have multiple projects. Now, you start with one project, but you can actually add a new one with ngGenerate, and then you can generate one of two project types, a library or an application. Now, let's start with an application here. If I type ngGenerate application, and I maybe name this backend, because let's say I have my backend UI for my administrators and a frontend UI for my end users. If I hit enter here, this will go ahead and ask me the same questions I got when I created this project, whether I want to add routing and which style preprocessor I want to use. And now you see it adds a new projects folder here, and in that projects folder, it has this subfolder named backend, which is the name I chose, which basically has a new Angular project in it. A bit slimmer because they share the same root AngularJSON file and package.json file here, but its own dedicated config files, its own source folder, and in there, basically what we already know. This is a separate Angular application. Now we could serve this with ngserve, and then project equals backend. This is important, of course, otherwise ngserve wouldn't know that it should use this project. You can set the default project AngularServe or ngserve or any other command we'll use in the AngularJSON file. There at the very bottom, you have this default project setting, which in my case is set to my starting project, Angular config. And if you set this, then ngserve or ngbuild without any extra flag will always run against this project. Here I ran it against backend, so unsurprisingly, if I visit localhost 4200, I now see this brand new project, backend, being served here. Now, you could argue that this is an ugly project structure though. Having a projects folder as part of our other main project, I'm not too happy with this. Well, we can do better. Let's go back to the main terminal and to the folder where we create our new Angular projects. And now let's create a new one, ng-new, and now let's say we're building a Angular shop. But it's totally up to you. This is just a dummy name. Now, you might remember that there is --help, which you can use to run some commands, and there was a create-application flag. And I will set this here to false. Now, if we now run this, something interesting will happen. It now will generate some files, but actually less files than before. It will install some dependencies, but it will not create a brand new Angular application by default. Instead, let's wait for this to finish and see what it gives us. Instead, once it finishes, it gives us a folder that looks like this. So we have the config files we know, but of course the app folder is missing. And now indeed here we can simply run ngGenerate application, for example, backend. And what it will do now is it will create that new projects folder thereafter and create it in there. So you see, here it is. So now we have that cleaner structure, which is nice if you have multiple Angular projects in one root folder. Now every project will have its own subfolder in the projects folder, which I would argue is cleaner than what we had before. So in case you want to work with multiple projects inside of one Angular managed folder, this is how I would recommend that you do it. Create the project with ng-new, your name, and then --create-application set to false. And thereafter add your different applications with the ngGenerate command. Now also, of course, you cannot just generate applications, so web applications. You can also generate libraries. So let's take a closer look at that. To create a library, we run ngGenerate library, an alternative to application. In this case, let's say my button, because it's an amazing library where I will share my own custom button component, which every other application should be able to use. And that's maybe important. What is a library? A library differs from an application such that you still write Angular code in there, you still build Angular components and so on, you can group them with modules, you can add directives. That does not change, but it's not meant to run standalone as a web application. Instead, it's meant to have some code that can be shared across multiple Angular web applications. So something like Angular Material. Angular Material is an Angular library. It comes with a bunch of built-in components, and you can use these components in any application. So this is an Angular library, and you can build your own. Now, we already made our first steps by creating it with the ngGenerate library command. You see, you generally get the same as before, but there are some differences. For example, we have an ngpackage.json file, which in the end allows us to configure this library in a certain way. In the source folder, we have a public API TS file, where we in the end export the different things that make up our library. And in the lib folder, we got some starting files. For example, a myButton component, where we can write our own library component, already added to a module, and also a service which you can or cannot use. Now, to learn all about library creation, of course, as always, the official docs are your friends. Under Techniques, Angular libraries, creating libraries, you can learn all about creating and also deploying, publishing your own custom libraries to NPM. For that, you will also need an NPM account though. So this is in the end something you can also do. And building a library really is straightforward. Here, for example, I could build my own custom button, which of course is super amazing. There, I will use ngContent so that users can pass in anything they want between my custom button tags. And that's it. So of course, the most amazing button in the world has no styles, no extra features. You absolutely need this library. Now, with that, we already would have a very basic library, which we now can configure. And again, the official docs can help you there to learn about how to exactly configure this. And with this, we are also able to build libraries and share them across either our own Angular applications or also publish them to NPM to share them with others. And this is it for this module. Now, there is always more you can cover, but I found it important to also point you at the official docs so that you know where you can dive deeper if something is unclear or you are interested in one specific features. Because Angular is a huge topic. It's the framework, and then as you saw in this module, the entire CLI ecosystem thing. That's why some people refer to Angular as a platform, because it's more than just a framework. It's also all these extra tools and helpers and features. And this ecosystem, of course, also keeps on evolving, which is why the official docs are a great resource to dive into the specific features you might be interested in. Now, of course, this course is about Angular, the framework, and how we build web applications with it. That always was the heart of the course, and that is honestly what most developers are interested in. You want to learn how to write and build Angular applications. But if you want to take your knowledge to the next step and maybe get a bit more productive with all these CLI commands, with deployment, with maybe custom schematics and so on, then this module hopefully showed you what you can do there, where you can learn more, and how to read all these configuration files, how to use all these commands, how to manage your projects. So I hope this was helpful. In this video, we'll do just that. We'll load an Angular component. Well, this would be pretty boring, so we'll do it in an exciting way. We'll load it dynamically as a custom element, as a native web component instead of a normal Angular component. What's great about that and how does it work? Let's take a closer look at this in this video. So let's get started with Angular Elements. What is Angular Elements? It's a feature of the Angular framework that allows you to turn your normal Angular components, which you use in your Angular app, into native web components. Web components are basically custom HTML elements, you could say. They are part of the DOM of the JavaScript API. They're not related to Angular, and you can use them in vanilla JavaScript apps or in apps built with other frameworks. So that's web components, and that is what you can create with Angular elements. Now, before you get too excited, right now, at the point of time I'm releasing this video, when Angular 6 was released, the web components you're building with Angular can only be used in Angular projects still. And the obvious question then is, why would you build web components at all? What is the use of Angular elements if you can only use these elements inside of an Angular app? And the answer is, they are useful for loading dynamic content. So let's say you got a content management system on your backend on a server, and there your editors can create HTML code. They know how to write HTML code, and therefore they create the content that gets loaded into your Angular app in HTML. Now, so far that is fine. But what if you actually want to enable them to also use some of your Angular components in the HTML code they prepare? If they do that, if they use your Angular component selectors, and you then load this content dynamically in your Angular app, it will actually not work. Because your Angular app is compiled ahead of time, or even with just-in-time compilation, it's compiled before the content is loaded. So if the content contains the selector of an Angular element, of an Angular component, this will not work. It will not recognize that. Let me show you what I mean. Here's a brand new Angular project created with the Angular CLI. Important, if we check the package.json file, I'm using Angular version 6 and I'm using RxJS version 6, and I installed the RxJS Compat package to have no issues with RxJS. This might be needed at the point of time of recording this. I need it for the Angular Elements package, which we'll use. In the future, you might not need this. All Angular packages should by default support the RxJS syntax. If you want to learn more about what changed with Angular 6 and why this RxJS 6 thing is so important, check out these separate videos I created on that. My Angular 6 update video and the RxJS 6 update video. But back to the Angular components. Let's create a new component. Let's name it alert component maybe. A normal Angular component. So in there, I'll export a class, alert component like this. And of course, we could create that with the CLI too. I'll import the component decorator, and in there, I'll define my selector, which is app alert, let's say, and a template, which could be, of course, an external file too, but here I'll simply add a div, and inside of the div, I'll say this is an alert, and then we all even output a message here, so some string interpolation. Now, last but not least, I'll add my styles array here, with a string in there to define some styles for this template. And there I simply want to style my div, give it a border of 1 pixel, solid and black, background of, let's say, salmon. So this is a light red color, and a padding of 10 pixels. And last but not least, let me also define a font family. And salmon, by the way, should not be a string. Let me define a font family of sans serif. Now this is my style for the alert. Now the alert uses this message property, so I have to add it here. And I want to make this bindable from outside, so I'll decorate it with add input, which I have to import from Angular core. And now with that, the component is finished, and we can now use it. To use it, we have to add it to our declarations array. There I add my alert component. And with it added here, we can go to the app component, to its HTML file to be precise. And in there, we can use my newly created app alert component like this. And of course, also pass a message, which, since it's a string, can be passed like this without the square brackets. This is just a shortcut in case you are passing some text. And there I could say, this is a normal Angular component. With that, if we save all these files and we go back, we see our component there. Now the styling didn't work. Yeah, I should add more semicolons instead of commas. With that, now we got this alert. So this is a normal Angular component. Now let's say in the app component, we actually want to load this dynamically. I got this content property there, it's null initially. And now let's say, instead of outputting this component like this, we have a div, and on this div, we use the inner HTML property binding to bind to the content. In the app component, in the constructor, for simplicity reasons, I can then add my timeout, just to simulate that this is an asynchronous task and we're getting this from a server. We don't have to put it into a timeout. We can also run this code once this app component loads, just adding this to, well, give us a little bit of time to prepare for the data to arrive, I guess. And in that function that executes here in set timeout, I now want to set this content to, let's say, a string that holds HTML, a paragraph. So this is obviously not using our element. I just want to show you that this works. We're now rendering this paragraph. If we inspect it, we see a paragraph is rendered to the DOM because we're using inner HTML. Now, it would be great if we could use our own element there. So if we could use app alert here, like this, app alert. And now we also set a message of rendered dynamically. Dynamically because we don't include it in our component template. We're not including it in the app component HTML file. But here we're hard coding it into our code, but we could easily imagine that this is coming from an API call, that we're fetching this from a server. So if we do it like this and then we reload our app, we can wait forever. We won't see anything here. And if we inspect our app root, we see that the div indeed is empty. So nothing gets rendered here. And the reason for this is that this is rendered as HTML code, but it's not recognized as an HTML element. App alert is not a built-in element. It's our own component, but that exactly is what I meant. Angular will not consider this after it has loaded our app, because the compilation of the templates, and therefore the part where it understands your component selectors, is already done by that point of time. And this doesn't change if we remove this from set timeout and execute it right at the beginning of this component. So here, we don't see anything either. So this is not the reason. The reason indeed is that Angular doesn't compile this code. And Angular Elements fixes this issue, or this problem, you could say. It allows us to basically take our Angular component and put it into a totally encapsulated, self-bootstrapping HTML element, which you can dump into your Angular app in this way, for example, and which will still work. Now, how do we create such a component? We need to install Angular Elements. And you can already see that I added an import up here, create custom element. This has been lurking around for a while, and it seems to be what we need. Now make sure that you install the Angular Elements package with npm install --save @Angular Elements, just in case this isn't installed already. Now I'm recording this with a beta version, but of course, by the point of time you're watching this, it probably was released as part of the normal Angular framework. So once this is installed, you should also ensure that, especially for the beta version, might not be a problem in later versions, that you got RxJS Compat, because this is required for this to run, at least right now. And very important, that you add this line to your package.json file. This is a polyfill, which right now also is required for this to run. This might also change in the future, but right now you need to add this. So add this line with this version and rerun npm install thereafter to download it and add it to your project. And with that polyfill installed, you can go to the polyfills ts file, and there you should add these two lines. Import @webcomponents /custom elements /custom elements.min and import @webcomponents /custom elements /source /native shim. This might also change in the future, but we right now need this to enable custom elements, to ensure that this works, that the native element, this custom elements package, or the Angular elements package, spits out that this element works. Therefore, this is needed. So with that all added, with the polyfills added and with the packages added, we can now try creating a custom element. And for this, in the constructor of app component, you want to do this in a place that runs early in your project, I'll create a new element and I'll name it alert element. The name is up to you. I'll store it in a constant, which is named like this. And I will use create custom element. And now I need to import my custom element. I want to do this on the alert element, so you should make sure that you add an import to that. So import alert component from, and now it's alert component. And down there, of course, it should also be alert component. Element is the name of the constant, but we pass in the component to create custom element. Now, create custom element also needs a second argument. This argument is used to configure this element. And there we need to pass the injector we're using. Now, Angular uses dependency injection, as you know, and the injector is basically the tool which does this injection, and we provide it to this custom element so that the element behind the scenes is able to connect itself to our app, so to say. Therefore, we simply inject the injector. So import injector from @AngularCore, and with that injected, in that object you're passing to create custom element, you add the injector key, and as a value, the injector you're injecting. That's a lot of injection going on, I guess. So with that, we created a custom element, and this indeed already is a native web component. Now we can use the custom elements API, and important, this is not an Angular feature. This is a feature provided by JavaScript and called define there. This allows us to register a custom web component. And again, alert element is just such a component. It's the same as we could have built on our own. So therefore here, we first of all define the tag by which we want to select it. And this doesn't have to be the same one as down here. So we could also use my-alert, for example. And then you pass in the element. So not the component, but alert element. So our custom element. Now with this, we can use that. So down there, I use my-alert. instead of app alert because I changed the tag. And now if we save this, it compiles, and if we go to our application, nothing happens. But if we inspect the console, we actually got an error that that doesn't find a component factory. Now, as I said, Angular elements are only available in Angular apps right now. So what we have to do at this point of time is we have to add the entry components array to our app module. Entry components essentially is an array of components which you don't use with its selector or via routing, but where you want to tell Angular that you're eventually going to use it. And this is exactly what will happen for the alert component. We declare it, that's important, so that Angular can find it, but we also need to tell Angular, hey, you won't see me use a selector for this. You won't see me load it with routing, but eventually I will need it. So please be prepared to load it when I need it. And that is why we also have to load the Angular component, the alert component, not our custom element, but the Angular component here, into our entry components array. And if we do that and we save, the app will reload and we get at least a warning, not an error. Sanitizing HTML stripped some content. Now, the custom element is in the end a bunch of JavaScript code. And this is sanitized, so this can't be rendered with inner HTML. That's a security mechanism to avoid cross-site scripting attacks. We want this mechanism, but in this case, we know our content is safe, and therefore, we want to be able to output it. We can do this with the help of the DOM sanitizer. You can also inject this. It's the DOM sanitizer object or class, which you need to import from @Angular platform browser. And with it injected, you can wrap this custom HTML code, which again, behind the scenes will use a lot of JavaScript. You can wrap this with DOM sanitizer bypass security trust HTML, so that this HTML code and whatever is connected to it is trusted. So now with that, if we reload this, we do see our alert after a second, but this time it's loaded as a custom element. If we inspect it, we see our template here and we see the styles we applied to it, but this now actually is loaded as a native web component. Still only usable in Angular projects. This will probably change in the future though, but already useful for dynamic content like this. Since we sanitize it, you should of course make sure that you know that this content is safe. But with that, you got a really great tool to load content into your app and control it as an Angular component and do all the fun stuff you can do with components whilst getting it from another source which is not hard-coded into your Angular project code when you're compiling it. Welcome to this video, Angular Master. You went through the whole course and you learned a lot about Angular. You should feel confident using its features and building web apps with it now. You learned about all its core features, some advanced features, how these features work together, and how you use them in a real application which you then even deployed. So these are all the building blocks you need to build amazing web applications with it. Now, of course, really learning and mastering a framework means using it. So use it, build example projects, pick some web pages you like and try to rebuild them, maybe in easier versions of them, with Angular. Dive into the individual features of Angular, maybe even dive in the source code of Angular. It's open source in the end. Or have a look at the official documentation to dive deeper into some specific use cases. Also, there are some advanced courses and tutorials available. For example, I myself do have some courses on Udemy which allow you to dive deeper or use Angular in conjunction with other things, like Ionic 2 to build mobile applications, or together with Node.js as a backend. These are all great next steps, and whether that's a course by me, some other tutorial, or your own example project, I'd be very interested in seeing what you build, what you do, so definitely send me a message if you build some amazing project or anything like that. All the best to you, see you maybe in other courses, and simply have a great time. Now, this course section is optional because this course section will act as an introduction to TypeScript. the programming language which we are going to use throughout this entire course, since Angular embraces TypeScript. But TypeScript, in the end, is just a programming language extending JavaScript. So if you know JavaScript, learning TypeScript is rather straightforward, and you should be able to learn those key TypeScript features by simply going through the course step by step. Nonetheless, in this course section, if you want a quick introduction to TypeScript or you want to have a summary of the core features, I will introduce you to what exactly TypeScript is and why we might want to use it, what its benefits are. And we are going to explore some of its key features and types, which we use all the time. Now, that being said, we will not cover every single TypeScript feature which you see in this course, since you will learn it step by step when going through the course as mentioned. So, what is TypeScript and why would you use it? TypeScript is a so-called superset to JavaScript. It's a programming language which builds up on JavaScript. It extends JavaScript, you could say. And that is really important. The core programming language still is JavaScript. So the base JavaScript syntax, you know, how you write JavaScript code, if statements, for loops, objects, all that does not change. But TypeScript then adds more features to the JavaScript syntax. And most importantly, it adds static typing to JavaScript. And that's also where the name comes from, TypeScript. It adds static typing to JavaScript, because JavaScript on its own is actually dynamically typed. And what does this mean and why is this useful? For this, I prepared a very simple example here, which you find attached. Now, this is not an Angular project. That's a standard empty project, basically, with just an HTML file and a JavaScript file. And I prepared this project to show you why we might want to use TypeScript and why Angular, in the end, uses TypeScript, therefore. This is a standard JavaScript function and a standard HTML file which has no actual content, but which imports this script file. Now, if I open this file in the browser, simply by copying the path here and then opening that path in the browser, if I reload this page and open the developer tools, I see 7 here in the developer tools in the JavaScript console. And I see 7 here because in this script file, I define an add function, and then I call this add function and store the result in this constant, and then I log this constant. So that's standard JavaScript, nothing fancy here. Now, JavaScript has types. JavaScript knows the concept of types. For example, here, the 2 values which I'm passing in are of type number. And that's something JavaScript knows on its own without TypeScript. The important thing just is that JavaScript, as I just mentioned, is dynamically typed, which means that this function here does not expect any particular types. It just knows that it will receive 2 parameters, and that's it. So it's not statically typed. The types for this function are not announced ahead of time. Instead, it just takes whatever it gets and then tries to execute this code. And that code happens to work with numbers. But this code also happens to work with strings. And hence, if I convert my 2 numbers into strings here by wrapping them with quotes, then I got 2 different types here. I got 2 strings instead of numbers, which are types JavaScript knows. And if I change it like this and save this file, if I reload, you see now we get 25 here. Because now the plus operator does not add these 2 arguments in a mathematical way, but instead it concatenates 2 strings because it receives 2 strings here. And that shows why just JavaScript is okay and great, but why it might not always be best. Why having static typing could enhance your code and prevent errors like this. Now, of course, you might say, which error? I can simply not call add like this. I just make sure that I always pass in two numbers and I won't face this problem. And that's true, but in a bigger project with lots of code files and potentially a lot of people working on the code base, you might sometimes call a function or use some object in an unintended way. And then you could run into problems like this because nothing is warning you that this is not how you should use this function. Nothing is telling you that this function actually wants two numbers instead of two strings or any values. And that's where TypeScript can help us. Because with TypeScript, and I'll show you this code even though we haven't installed TypeScript yet, but I have it installed on my system already, and we will install it together in the next lecture too. But let me show you this first. So with TypeScript, if I copy this code, what we will be able to do is we can add type annotations here, simply by adding a colon after our parameter, and then adding the type which should be used for this parameter. And I'll do this for B as well. And we'll also not just be able to use type annotations on function parameters, but as you will see throughout this module, we can use types in many other situations as well. So now I'm making it clear with TypeScript that here I actually want two parameters which both should be of type number. And hence I already get an error here in my IDE which tells me that this argument of type string is not assignable to a parameter of type number. Pretty helpful. And with that I can catch such an error, such an unintended use of this function before I run and test my code. And that, of course, allows us to write better code in the end because we can avoid such errors and we don't have to track them at runtime, but we see such errors right when we start writing code. And that's why using TypeScript could be worth a thought. So now that we know what TypeScript is, that we can add types to our programs with it, and how the syntax generally looks like, let's make sure we can all use TypeScript. And therefore, if you search for TypeScript, you can visit typescriptlang.org, and that's the official TypeScript webpage where you can learn more about TypeScript and where you can also learn how to install TypeScript. As a side note, if you want to learn way more about TypeScript, I also do have a complete TypeScript course where I dive deeply into TypeScript. In this module, I'll just cover some basics. So if you want to learn more, my full course might be interesting to you as well, or the official docs, of course, in addition. So now to install it locally, we can click here on install locally. And now we basically need to run this command here. Now for that, we need to make sure that Node.js is installed, but we needed this for this course anyways, and therefore that should already be installed. So therefore we can now run this command to install TypeScript. And running this command will install TypeScript into a specific project. If you want to install it globally on your system, then you need to run npm install -g TypeScript. But often installing it just into one specific project is enough so that you can then use TypeScript in that project into which you install it. And therefore, that's what I'll do here now. I will open my terminal, which is integrated here into this project, and run npm install TypeScript. And actually for this, I'll first of all run npm init -y to create a empty package.json file, because we'll need that to install dependencies, and then I'll run npm install TypeScript. And this will now install TypeScript into this project. So now TypeScript is installed. With that installed, we can now invoke the TypeScript compiler. And that is really important. As you learned, TypeScript is a superset to JavaScript. extending the JavaScript syntax with those extra types. Now, the important thing to note is that TypeScript code does not run in the browser though. So if you try to execute TypeScript in the browser, it will fail. Therefore, we need to compile TypeScript to JavaScript. And during that compilation process, all our type annotations will be removed because JavaScript doesn't know those annotations. But it's during this compilation step where we will be notified about errors, in addition to the notification we get in the IDE already. So it's this compilation step which then will warn us of potential code problems if we haven't spotted them in the IDE before. And then it's that compiled code which will run in the browser. Now, to invoke this compiler, we need to run this command here, npx_tsc. So now if I run npx_tsc like this, you'll see that I get an error though. I get this error because if I run this command just like this, then it expects a TypeScript configuration file in that project folder that tells TypeScript which files to compile. Now we'll add such a configuration file later. For the moment, we can run this command slightly modified. We can point at a file that should be compiled. In this case, with TypeScript.ts. So if I run npx_tsc with TypeScript.ts, then this file is getting compiled. And hence now here I get one compilation error, the same error my IDE warned me about before. So if I haven't spotted it in the IDE, now I get an error here. Now you will notice that a no TypeScript.js file was created nonetheless. That simply happens because by default, even if you get an error during the compilation, it still completes. It just warns you because of that error, but it still gives you a JavaScript file. And this JavaScript file, sorry, this one here, is now based on our TypeScript file. And you see it's almost the same code, just without the types, and actually it changed const to var because by default right now it still also compiles the code such that it runs in older browsers as well. That is something which can be overwritten with the TypeScript config file, but we don't have such a config file yet, and therefore we have this code change as well. But of course you see that other than that, it's the same code as we wrote in the TypeScript file. Now, of course, we should get rid of that error though, otherwise using TypeScript doesn't make any sense, and hence I'll convert my two strings here to numbers, and if I save this now, the error is gone in the IDE, and if I now compile again, this also compiles without errors, and we still have the same JavaScript output as before. But now it's this JavaScript file which we could import here and use here. If I now save this and then reload this page, I get 7 again. But now, if we continue working in the TypeScript file and then compile it to run in the browser, now we actually protect ourselves against errors like we had it before, thanks to TypeScript. And now with that installed, and now that we understand what this compiler does and how this generally works, let's dive into some core features you need to know when working with TypeScript before we then thereafter are ready to use TypeScript with Angular. Now let's dig deeper into TypeScript. And for this, I'll add a new basics.ts file in which we'll dive into some core basics you need to know about TypeScript. And for that, I want to start with the basic types you can work with in TypeScript, which you will need all the time. And that will be our primitives, which we know from JavaScript, numbers, strings, and booleans. And then, of course, we also have more complex types like arrays or objects, for example. And then thereafter, we'll also talk about function types, parameters, and much more. So that's generally what I want to talk about here. And let's start with the primitives here. The primitive values we have in JavaScript are numbers, strings, booleans, and also null and undefined, and also symbols, but we can ignore that. And number, string, and boolean, as well as null and undefined, are the important ones therefore. Now, if we have a variable, let's say the age of a user, and we want to make it clear that in there we want to have a number, we can make that clarification with TypeScript by adding a colon after the variable name, and then simply specifying the type of value that should be stored in this variable. And then we can finish this variable declaration here. If I then later assign a value, assigning a number is okay, including floats, so numbers with a decimal place, but assigning a string would give me an error. That's what we saw before with that function and its parameters as well. Now, of course, we can also assign a value here right away. We don't have to have this declaration without a value assignment. Both is allowed. Now, we also can, of course, have a username, which should be a string, and for that, we can assign a type like this. String is the type we want to use here. And one important note here, in TypeScript, it's number and string written like this with lowercase starting characters. It's not number like this. We don't get an error if we use that, but this actually points at the number object in JavaScript. We want the number primitive type, which starts with a lowercase n. The same for string. We want the primitive type, which starts with a lowercase s. And then, of course, here we can assign a value. And we can also, of course, store Boolean values like is instructor and add Boolean as a type assignment so that thereafter I may store true or false in that variable. And these are our core primitive value types which we can assign, in this case to variables. Before we also saw how we set types for function parameters. And we'll see more places where we can set types in the next minutes. Now, as I mentioned, we also have null and undefined as types, but we don't typically set something to be null. If I set hobbies to null here, then this would be possible. But then whenever I try to assign anything, I get an error, which of course is not too useful. Instead, we'll use null and undefined in a slightly different way, which we'll learn about in a couple of minutes. So numbers, strings, and booleans are the core primitive value types we should be aware of. Now let's talk about the more complex types, so arrays and objects here. And let's start with arrays. If I have my hobbies, that might be an array of strings. Hence, this type assignment is wrong. This allows me to store a single string in hobbies, but I want to have an array of strings. To tell TypeScript that I want an array of strings in there, we can instead assign this type, string with square brackets thereafter. This tells TypeScript that we want to have an array of strings in hobbies. And of course, we could have the same with an array of numbers, an array of booleans, whatever. But here I want to have an array of strings, and that allows me to store an array of strings in there, like this. Now, this is possible. If I would add a number in addition to the strings, I again would get an error, because that's not a string, and I'm making it very clear that only an array of strings may be stored in hobbies. So that's how we can set up array types. Now we also can set types for entire objects. Let's say I have a person variable, and in there I don't want to store a name or an age, but an object. I want to be able to store something like this, an object with a name and an age. Something like that. That should be stored in person. Now, of course, this works like that because TypeScript out of the box without configuration is quite forgiving, and it by default allows me to store any value in a variable. It has a special any type for this, which we can see if we hover over person. The default type assumed is the any type, which we can also explicitly set like this, which simply tells TypeScript, I don't want to tell you anything about the types of values stored in this variable. Anything is allowed. And that, of course, is a fallback type, which you typically should not use, because that kind of defeats the entire purpose of using TypeScript in the first place. With the any type, you're basically back to standard JavaScript. So it's the default, but of course, it's not what I want to keep here. Instead, I want to make it very clear which kind of object can be stored in person. I want to allow this object, for example, but storing another object with a different structure, where I have, let's say, just a Boolean in there, that's something I don't want to allow. And for this, we can again add a type assignment, but now we want to add an object type, a type defining an object. And for this, we then add curly braces, just as we do it when we create an object. But please note that this is not on the right side of an equal sign here. So we're not creating an object here. Instead here, it's in the place where we set a type for a variable on the right side of this colon after the variable name. And therefore this here is actually a type assignment. And hence here we're not creating an object, but instead we're using a TypeScript feature here, which is the object type definition. So we're defining the type for an object. We're defining the structure of an object. And here we can then, for example, say that person should store objects that have a name field where the value of that name field is a string, and which have a h field where the value is number. So where the value is of type number, I should say. And with that, we're telling TypeScript that only objects that have this kind of type should be storable in that variable. That's why I can store this object here, because that object down there has exactly the structure I'm defining here. It has a name field, which has a string as a value, and the h field, which has a number as a value. On the other hand, this object down here is not storable, and hence I'm getting an error here because it is having the wrong type. This object's type would be that it has an isEmployee field, which stores a value of type Boolean, which does not match this type description here. So I'll comment this out. And that's how we can define array types and object types. Of course, we could also combine these two. If I wanted to have an array full of people, so full of people that have this type signature here, then I could set the type of people here to this object type. So I'm repeating this, but as an array by adding square brackets thereafter. Now I'm saying in people, I don't want to store a single object of that structure, but an array of such objects. And that's how we can then already get a bit more advanced by combining different TypeScript features and by combining different types. Now that we learned about those base types, before I'll dive into functions and parameters, I want to talk about type inference. In all those examples which are listed here, I always declared a variable with a type assigned, and then in a second step, I set a value. Now, often in programming, you do that in one step. You create a variable, and you then also immediately assign an initial value. So therefore here, let's talk about type inference. And let me show you what that is. Let's say we have another variable down there, the course variable, and in that course variable, I want to store the name of a course, like React the Complete Guide, like this. Now, if I create this variable like this, and thereafter I try to store a number, for example, the course ID, then you will see that I get an error, because the type number is not assignable to type string. But why am I getting this error? After all, I don't define a type anywhere. Well, here TypeScript used its powerful feature of type inference. By default, TypeScript tries to infer as many types as possible. So it tries to know which types are used where without you explicitly stating those types, which means that you need to write less code. I could also set my type here, as we learned it. That would not be wrong, but it's redundant. Because if you immediately initialize this variable with a type, TypeScript will look at the value type here, so it will see that we stored a string in that variable, and it will then use that value type as an inferred type for this variable. And if you then try to assign a different type thereafter, you'll get an error because of type inference. And it is considered a good practice and a good idea to embrace that type inference feature, so to not unnecessarily specify the type in addition. You can do that, you can explicitly state the type, but it's really redundant. It just means more work from your side, and therefore you should not do that. You should instead stick to that type inference and use it whenever possible. And that's another super important feature which I wanted to highlight here. Now, type inference is great, and in general, up to this point, we already learned quite a bit about TypeScript and its core types. But up to this point, we also always had the scenario that every variable took just one type. So we always had just one possible type that could be stored in a variable. Just a number, or just a string, or just a boolean. And often, that is what you need. But sometimes you want to allow multiple different types. Let's say here for the course. We might be fine with storing a string in there, but maybe storing a course ID as a number should also be correct. It really depends on what you're building. It's not unrealistic that we could have a variable where both a string as well as a number should be allowed. Or that you have some variable which should allow two different kinds of objects. And for this scenario, that you have more than one type which you want to allow, you have a feature called union types. A union type is a type definition that allows more than one type. You add it like any other type assignment by adding a colon after the variable name on the left side of the equal sign, and then your type. Now, I mentioned that explicitly setting string again here would be redundant. But it's not redundant if you don't want to use the type inference here, but if you instead want to specify such a union type, hence allowing multiple types. You set up such a union type by adding a pipe symbol after your first type, and then adding another type like number. And you can have as many types which you want to allow here as needed. But here I just want to have string or number. And now you see that that error which we had down here before is gone, because now we are allowing a number alternatively to a string value. And of course you can use such a union type anywhere where you have a type assignment, not just when you're using type inference. I could also use a union type up here, allowing username to be a string or let's say an array of strings, for example, so that we have first and last name in an array, for example. That's also something I could allow here. Union types are another key TypeScript feature which allows you to define more flexible values and types. Now, the more TypeScript code you're going to write, the higher the chances that at some point you might be repeating some type definition. And we're actually already doing this here. Here, for people, I'm saying that I want an array of this kind of object, so that I want an array full of objects that have this structure, and that's the same object I have up here for person. The same type definition, just in the non-array form. But the object type is the same. Now you can, of course, duplicate the type definition, but it's more realistic that you want to avoid that duplication. And for that, you can create a so-called type alias. You can define your own base type, in which a more complex type definition is stored, and then use that type alias instead of repeating the entire type definitions. For that here, for example, before we use this object type for the first time here, we can define such a type alias with the type keyword. And that's a keyword which does not exist in standard JavaScript, but which is added by TypeScript instead. Now, after this type keyword, you use any name of your choice, which will be your new type name. For example, person, like this. And then after the equal sign here, you then have a type definition, because this is a pure TypeScript feature. This will basically be thrown out of the window when the code is compiled to JavaScript. So here on the right side of the equal sign, it's not a JavaScript value, but instead a type definition. And that could be our object type definition here, which I now store here in this person type. And now in all those places where I used this object type, I can use my alias instead now. And it's therefore still the same type, but I only define it once, and then I can repeat it in all the places where I need it. And I can still also change it like I'm doing it down here to use it just as person like this, or to use it as an array full of persons. That also works. And that's the very important feature of type aliases, which can save you a lot of typing work and which can therefore make your code more concise and easier to maintain. Now, there are a lot of other core TypeScript features which I do explore in greater detail in my TypeScript course. To come to an end here for this introduction, there are just two last features which I want to cover here. And that would be functions combined with types, and then thereafter generic types. Let's start with functions and types. And I'm saying function and types because when we work with functions, there are different places where types can be assigned. Let's start by adding a function here. Let's say the add function again, which we saw before. The add function can get parameters, of course, like any function, just as I did it before. And then for these parameters, we can assign types. That's what we saw before here in this first example. Just as we can set types for variables, we can also set types for parameters. We can make it clear that here we want to allow numbers, for example. And then I can return a plus b. But with that, we also have one inferred type here in this function. And do you see where we're using type inference here? Well, here in this function, I am returning a value, and that tells TypeScript something about the return type, the type of the returned value of this function, and it infers this type. We can see the type it infers if we hover over add. Then we see the TypeScript definition of this function, and we see that, of course, for the parameters, we have the two types we set up, the number types. But then here, after this function name and the parameter list, this colon here and this type here, that's not coming from us. We haven't added this code. Instead, that's the inferred return value type TypeScript infers here. So TypeScript knows that here it will get a number as a return value because it sees that this code with these parameters, which are always of type number, can only return a number. There's no other value that could be returned. And that's why this number return value is inferred. We could also explicitly set it though. We can set the return type of a function by adding a colon after this function parameter list, and then setting the return type here, like number or string, or a union type. That would also be possible. That's something we can do. But just as before, if you don't have a reason for doing that, you shouldn't do that. TypeScript already infers a type here, and if that's the type you want to stick to, then there's no need to explicitly define it yourself. Still, I want to mention this, that functions, when we work with types, don't just use types for the parameters, but also for the return value. That's easy to overlook, but it makes a lot of sense, because a function, after all, does not have just some input, it also has some output, and hence it has a return type. Now, there is a special return type, which is also worth knowing. And for that, let me add a print function where I get a value, and that could indeed be of type any, because the only thing I'll do with that value is I'll console log it. So I don't really care about the concrete type of this value, I'm just logging it. Now, one important note about naming this function print, though, which I unfortunately only discovered after I named the function like this. Of course, in JavaScript, there is a built-in print function already, so now this function will clash with this built-in function, and hence if you would try to compile this TypeScript file, you would be getting an error because of that, so maybe just name it print output or something like that to avoid that error. But the important thing about this print function now is that this function does not return anything. It has no return statement. And therefore it has a special return type called void. Void is basically comparable to null and undefined, but it's only used in conjunction with functions, and it means that this function never returns. So if I want to work with the returned value from that function, I will work with undefined. And that's that special void type for functions, for the return value of functions. I want to conclude this basic introduction to TypeScript with a slightly more advanced yet very important TypeScript feature, and that would be generics. Now, this can be tricky to wrap your head around, but I'll try my best to explain it such that it makes sense. Let's say we have a function here, which I'll name insert at beginning, and this function takes an array and a value as parameters, and the array should be an array full of any kinds of values, and the value should be any kind of value, because I don't care in this function if it's an array full of numbers or strings or of person objects. Whatever it is, what I want to do in this function is I want to create a new array, for example, by using the spread operator and copying the existing array. That's a standard modern JavaScript feature, also supported by TypeScript. And then in front of that old array, I want to insert the value. And then I want to return this new array here. That could be a utility helper function which we create to have a function which we can easily call to add a value in an array without changing the existing array. So the advantage of this function could be that the original array never changes, but instead we're getting a brand new array. Now for this, I could of course have a demo array with, let's say, 3 values. And then I get my updated array where I call insert at beginning, and I pass in the demo array, and then a value of -1, let's say. With that, I know that the updated array will be this array with -1 inserted at the beginning. So this will give me -1, 1, 2, 3. And hence, thereafter, I might want to do things with that array, which I can do with an array full of numbers. But the problem is that updated array, if I hover over it, is inferred to be of type any array. So an array full of any kind of values. TypeScript here doesn't pick up that it's an array full of numbers. Why? Because here I have any as a type. And I can't say that I only want to allow numbers here, because what if I want to use this utility function with an array full of strings? So we need any, but at the same time, that kind of removes all kind of TypeScript support we might be getting after calling this function. We're not getting any good TypeScript support for updated array thereafter, because that is inferred to be an array full of any kind of objects or any kind of values. And that's not useful. If I then, for example, try to access the first element and call split here, which I could call on a string, I don't get an error here. I would get a runtime error instead, because I can't call split on a number. But again, TypeScript doesn't know that the first value in updated array is a number. We know it as a developer, but because of our type definitions here, which we need, TypeScript doesn't know it. And to work around such problems, we have this feature of generics. And that's why I had this lengthy introduction here, because it is important to understand why this feature exists. With this generics feature, we can convert this function to a generic function. For this, we use a special syntax here. After the function name, in front of the parameter list, we add angle brackets. And that's now not a standard JavaScript feature, but really only a feature we can use here since we're using TypeScript. And in here, we can define a generic type, which will only be available inside of this function. Typically, that's called T for type, but any identifier of your choice is okay. Now you can use this type in your function, including the parameter list. And here I'm saying, I want to use this for my array. So my array will be full of t's and my value. This should also be of type t. But how does this help us? Well, like this, it of course is just very cryptic. But now when we call this function, now TypeScript actually is able to understand that it should look at the concrete values of the arguments here. And it understands that this is an array of numbers and this is just a number. And therefore it understands that updated array will be an array of numbers. Because of this generic type feature, because we're telling TypeScript that the type here is actually not any type. It's not any kind of value. Instead, we tell it that the type of this array and of this value should be the same. Just that this is an array, but it's an array full of the same types of values as this single value has it. And that's an important piece of information. Therefore, TypeScript is able to look at the type of demo array, which it knows. It knows that this is an array of numbers. It's able to infer this. And it looks at this type. And then it knows that logically, the array which gets constructed here has to be of the same type as the input array. It's able to infer this here. And hence, it's able to infer that what we get back here has to be an array of numbers. And if I would call insert at the beginning here with an array of strings, like this, and I then pass in a string here, and I have my string array here, TypeScript is also able to infer this correctly, because again, it looks at this type, and it knows that the return type is of the same value as this type, as the input array, and hence it again infers this correctly. And therefore, for the updated array here, where it knows that it has to be an array full of numbers, it's now able to warn me when I try to call split. It tells me that this does not exist on type number. So that's this important feature of generics. It simply helps you write functions, in this case, which are type safe yet flexible. They are flexible, they work with any type, but then once a certain type is used, for that function execution, that type is locked in and known. And that allows you to get the best of both worlds, flexibility and type safety. Now, I got one last feature which I also want to cover here, and that would be classes and interfaces with TypeScript. And we know classes from modern JavaScript already. You can define blueprints for objects with help of the class keyword. And again, this is a keyword supported in TypeScript, but it is actually also supported in modern JavaScript. Now, with classes, as I just said, you can define blueprints for objects which you plan on instantiating. For example, here I could create a person class, or let's maybe create a student class, and then you can add properties and methods to that class. So for example, here we could say that every student should have a first name property, and we can assign types to these properties to make it clear that this first name property here should be a string. And then we maybe also have a last name, which is a string, maybe an age, which is a number, and maybe a courses array, which is an array of strings. Now with that, we define such a blueprint. Now we can also add a constructor function, a constructor method to this class to then define the default method that will be called when we instantiate a new object based on that class here. And here we could accept certain arguments like first, which is a string, last, which is a string, age, which is a number, and courses, which is an array of strings. And you see that I have the same argument names as I have properties, and therefore we could then set first name equal to first, this last name equal to last, this age equal to age, and this courses equal to courses. Like this. And if we do that, we can define a new student down there by instantiating this student class like this. And then we can pass in these values for our parameters to this constructor function. By the way, of course, your class doesn't have to take any arguments in the constructor. You could also set those properties in a different way. For example, by assigning default values or after you created an object with the dot notation. But here I'll then pass in my values for these different arguments like this, and with that we create such a new object. And on this student we can now use the dot notation to access the different properties, and if we had any methods besides the constructor function, we could call those methods as well. And speaking of that, we can add a method here, let's say the enroll method, which allows us to enroll this student into a new course. And therefore we could accept the course name as an argument here and then add it to courses like this. And that's how you add a method to such a class. This is the method shorthand notation. You have the method name, then your parameter list, and then the function body. So it's basically defined like a regular JavaScript function with the important difference that we don't have the function keyword. We don't have that. That then is how we add a method. And now we could call this method here and call enroll and pass in React as another course this student is enrolled in, and thereafter if you would access student.courses, this would include both Angular and React. That's how we can define a class. Now, the special thing about TypeScript and classes is that we can define all the properties this class will have in advance and set the types for these different properties. In standard JavaScript, we would not do that. We would not have these property assignments. Instead, properties would be added by just setting them inside of the constructor. With TypeScript, you can define them ahead of time, including their types. And also very important, with TypeScript, you can control whether a property or a method should be publicly accessible or if it should be private. Now, private properties and methods can only be used from inside this class. Public methods and properties can be accessed from outside through this dot notation. And therefore, as you can tell, by default, all these properties and methods are public because by default I can access them all. But we could say that courses should be private by adding the private keyword in front of this property definition. And then we could, of course, add another method, let's say list courses, and there we then return this.courses. Now, this might be a bit redundant. We don't really gain a lot by doing it like this. We gain a bit more if we call slice, because then at least we return a copy of courses and make sure that if someone would push a new element onto this array from outside this class, the original array inside of the class would not be altered. But in general, this is just an example. Now, with those adjustments made, I can't access student.courses here. I get an error. Instead, I can call list courses if I want to see all the courses this student is enrolled in. And that's then simply another TypeScript feature which you will also see in action throughout this course. Now, it's also worth pointing out that it's a very common pattern in TypeScript that you define properties like this, and you then assign values to those properties through the constructor. You don't necessarily do it in all the classes you create, especially with Angular. You will see a lot of classes where you don't do it, but it's definitely also not uncommon. And because it's so common to assign values to those properties which you defined before, you can do it in one step with TypeScript. Instead of defining your properties here, you can add these modifier, these accessor keywords in front of your parameters in the constructor method, and add public in front of all the parameters that should be set up as public properties, and add private in front of all the parameters that should be set up as private properties. Then you don't assign values like this, and I'll now change this to first name and last name here, auto format this, and now this in the end leads to the same result as we had it before. So this is a shorthand notation for defining certain properties of this class and their types, and for also letting the user assign values to those properties when that class is instantiated. So this code down there still works, but now with that shorthand notation. And that's this classes feature, which is also part of TypeScript. Now, another important feature, kind of related to classes and objects in general, is the interfaces feature. And that's a feature which only exists in TypeScript, not in vanilla JavaScript. And any interface code which you write, which you'll see in a second, will therefore not be compiled to JavaScript. Now, what are interfaces? In their most basic form, interfaces are really just object type definitions. So we could say that we have a human object in our application, and we can define it with the interface keyword, then curly braces thereafter, and now here, between those curly braces, we can define the structure, the type of any human object we want to create. So we could say a human should have a first name, which is a string, and should maybe have an age, which is a number. And then let's say every human should also have a method to greet other humans. And for this we can add greet here, but now, very important, we don't add the method definition, we don't add the actual code that goes into that method, but instead just the type of that method, which we can do like this, for example. Now we're saying that every human should have a greet method, which actually is a method that takes no parameters and returns nothing. Now we can use this interface, as I just said, as an object type. So if I have a new variable named Max, because I want to store information about myself in there, then I could make it clear that this should be of type human, like this. And now if I want to assign a value, I'm not allowed to store a number. I am allowed to store an object, but only an object that has this structure. And I now also get auto-completion. And I have to make it clear that there is a first name, an age, And now I have to add a greet method as well. And here we now have the actual code, not the type definition. And now this works because this object, which I store in max, fulfills the requirements set forth by that interface. So we can use interfaces to define object types. But we could also do this with the type keyword to create an alias. Like this. That would work as well. So why do we have interfaces then if we can do the same with the type keyword? Well, for one, of course, interfaces are simply an alternative, and you can use interfaces instead of the type keyword when you want to define object types, but they also have one other extra feature which the type keyword does not give you. Interfaces can be implemented by classes. And when they are, they force classes to have that structure defined by the interface. Now, this might sound very abstract, but this can be helpful if you're building an application with multiple developers and you want to ensure that a certain class written by another developer has a certain structure because you, for your part you are working on, need that class to have that structure. You need that class to have a certain method, for example. And it's the same for Angular. Angular, as you will see in this course, also has a couple of interfaces, which we will use from time to time in this course, which then force us to add certain features to the classes we define. And we will work with a lot of classes when working with Angular. And Angular gives us interfaces that force us to add certain features to our classes so that it then is able to use these classes correctly internally. And you'll see all of that in action throughout the course. Now I'll give you an example. Let's say I add a new class here, instructor, and I want to make sure that this class has this shape because someone else who's working on the team needs that class to have that shape. Then we can add the implements keyword and implement our interface before we add the curly braces to start defining the class. And now because I'm implementing this interface, I'm getting some red squiggly lines here, and I'm being forced to correctly implement this interface. Which means I have to add the first name property of type string here, I have to add a age property of type number here, and I have to add a greet method here. And only if I add all of that, no matter which exact code I then have in that greet method, but only after I add the general structure here, this error goes away because I'm now correctly implementing this interface. And that's another key part of interfaces. They don't just act as object types, instead they also force us to set up a certain structure for our classes. And that's what we're taking advantage of here, and that's what we'll also see in action throughout this course. Now, to really conclude this TypeScript introduction section now, let's talk about configuring the TypeScript compiler. You might recall that before, when I executed just npx tsc, I got this error here that basically a TypeScript configuration file is missing, and that's why I had to target a specific TypeScript file like this to then compile just this file. Now, sometimes you want to compile all the TypeScript files in your project in one go, and you also might want to configure how the TypeScript compiler behaves. And for this, you can add a TypeScript compiler config file. You can do this with npx tsc-init. What this does is it adds a tsconfig.json file, though I will say, once we work with Angular, we don't need to do that because our Angular project got TypeScript configuration files out of the box, and you should really only change them if you know what you're doing. But here we now got such a TypeScript compiler configuration file, and in there we got lots of options which we can set. Now, one of the most important options is the strict mode option here, which by default is set to true. When using strict mode, TypeScript, as the name implies, does very strict type checking, and there are many things which it doesn't allow, like for example values where it's not able to infer the type. You then have to explicitly set a type for those. But that's just one example. Now, in general, you can read through this config file to understand these different settings, and of course I do talk about them in way greater detail in my full TypeScript course. As I said, with Angular projects, we get a TypeScript file out of the box, and therefore this is not really the focus here, because this default Angular TypeScript compiler file will do the trick for us, and we don't really need to change them. Nonetheless, this is how you can configure the TypeScript compiler, and feel free to dive into these different options to play around with them. But with that, we now got all those important basics out of the way, and now with that, you're definitely ready to dive into Angular and TypeScript.